8 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem, the National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by various research institutes, and have more than 70 research centers and supporting units. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Penggunaan sinar radiasi ultraviolet C atau UVC merupakan salah satu metode dalam sterilisasi. Sinar radiasi UVC dipercaya dapat melengkungkan struktur materi genetik virus dan mencegahnya berkembang. Pusat Penelitian Elektronika dan Telekomunikasi LIPI telah mengembangkan alat sterilisasi ruangan portable berbasis sinar UVC. Sisusan atau Simple Smart UVC Sanitizer memanfaatkan sinar UVC yang dikendalikan secara cerdas. Sisusan memancarkan sinar UVC yang menyinari langsung permukaan benda di ruangan atau kabin.
Seperti kita ketahui, sinar UVC adalah mempunyai kemampuan untuk melemahkan mikroorganisme, termasuk diantaranya adalah bakteri, virus, pada suatu permukaan benda dan di suatu ruangan. Sisusan dapat digunakan untuk menghambat penyebaran COVID-19.
Parameter penyinaran dapat diatur melalui aplikasi Android, seperti lama penyinaran sesuai dengan luasan ruangan dan jenis virus atau bakteri yang akan dibasmi. Penjadwalan penyinaran dilengkapi sensor keamanan dari aktivitas manusia. Sisusan didesain dengan sangat sederhana, portable, dan murah sehingga dapat digunakan di rumah tangga, klinik atau puskesmas, sekolah, kantor, dan lain-lain.
Saat ini, kebutuhan magnet permanen di Indonesia relatif tinggi. Magnet permanen adalah magnet yang memiliki sifat kemagnetan yang lama dan tetap sehingga sukar untuk dihilangkan. Magnet permanen banyak dimanfaatkan pengaplikasiannya oleh industri dan UKM pada berbagai komponen elektronika. Namun, tahukah kamu, sebagian besar kebutuhan magnet permanen di Indonesia masih diimpor dari negara lain, seperti Cina, Jepang, dan Amerika. Salah satu magnet permanen yang cukup banyak digunakan adalah magnet barium ferit. Magnet barium ferit, atau yang sering dikenal juga dengan sebutan magnet keramik, adalah magnet permanen dengan rumus BaFe12O19 yang terbuat dari bahan baku utama oksida besi dengan teknologi serbuk. Untuk meningkatkan kekuatan magnet barium ferit, Pusat Penelitian Elektronika dan Telekomunikasi Lembaga Ilmu Pengetahuan Indonesia di Bandung telah menemukan sebuah invensi berupa magnet bonded hybrid. Apa itu magnet bonded hybrid? Magnet bonded hybrid merupakan penggabungan dari magnet barium ferit dan magnet neodymium iron boron (NdFeB) dengan menggunakan teknologi hot press bernomor paten P0020140733. Keunggulan dari invensi ini adalah harga lebih murah bila dibandingkan dengan produk impor. Jumlah, bentuk, dan spesifikasi dapat dibuat sesuai kebutuhan pengguna. Keunggulan lain dari invensi ini adalah menggunakan produk lokal limbah oksida besi, temperatur Curie, dan ketahanan korosinya lebih tinggi dibanding magnet NdFeB, serta kekuatan magnetnya lebih tinggi bila dibandingkan dengan magnet barium ferit. Saat ini, pembuatan invensi magnet bonded hybrid masih dilakukan dalam skala laboratorium di Pusat Penelitian Elektronika dan Telekomunikasi. Pengembangan selanjutnya
Invensi ini dapat diproduksi secara massal dan digunakan untuk memenuhi kebutuhan industri elektronika nasional, seperti meteran air, printer, pengeras suara, keyboard komputer, alat bantu dengar, generator, dan motor listrik. Kami menantang Anda untuk menjadi teknopreneur melalui teknologi ini. Apakah Anda berani? Ayo membangun bisnis berbasis teknologi.
The latest release for Dassault Systèmes 3D Experience platform delivers an elegant, powerful business experience environment. With role-based functionality, easily access apps and services users need with one click. The new 3D Experience Marketplace offers an ecosystem of qualified industrial service providers for operations like 3D printing, and self-defined 3D dashboards streamline collaboration for both users and management across industries to create innovative consumer experiences. Companies understand the need for realistic simulation to reduce costs and increase performance. In fact, simulation can go even further. We believe simulation is a comprehensive tool to reveal the world we live in. This can be clearly seen through the latest Simulia R2020X portfolio, which delivers enhancements that maximize the value of simulation for end-to-end industry processes. Requirements management, conceptual design, validation, manufacturing, and consumer end use all can be tracked and enhanced on the 3D Experience platform. A complete set of multi-scale and multi-physics capabilities power these industry processes, including connections to state-of-the-art established technology for structures, fluids and acoustics, electromagnetics, and multi-body simulation. Simulia R2020X also supports our mainstream product designer community, including tight integration with both CATIA and SOLIDWORKS. New structural designer and structural engineer roles provide a complete linear structural analysis solution to assess the performance of products throughout product development. And the structural professional engineer role provides advanced simulation technology fully integrated with design, especially with SOLIDWORKS. Customers can secure their existing investments in simulation methods, data, and results by connecting directly to the 3D Experience platform with Power BI to do even more. Increase the visibility and value of project data, collaborate with stakeholders, distribute best practices, and integrate simulation more fully into design and business decision-making. Finally, for maximum simulation efficiency, you need scalable access to both computing hardware and software licensing. Simulia on-cloud roles accommodate a wide range of computing requirements and provide access to the 3D Experience platform without requiring a local platform installation. Simulation is fully integrated with design, engineering, test, and manufacturing on the 3D Experience platform, bringing the virtual and real worlds together to power innovation and business and reveal the world we live in. Available on-premise and in public or private cloud, Dassault Systèmes 3D Experience platform is a business experience platform that enables our clients to create delightful experiences from design to point of sale for their ultimate customers or consumers. For more information, please explore our website or contact sales for a personal demo.
Banyak terjadinya kasus pelanggaran terhadap aturan karantina bagi suspek COVID-19. Teknologi monitoring diperlukan untuk mengawasi gerak suspek COVID-19 agar menekan tingkat penyebaran virus. Sistem monitoring yang ditanamkan pada sebuah wearable device akan dipasangkan pada suspek COVID-19 di suatu wilayah karantina.
SIMONIC merupakan singkatan dari Smart Innovative Monitoring for COVID-19.
Teknologi SIMONIC terdiri dari 3 subsistem. Yang pertama adalah wearable device, yang kedua adalah mobile apps, dan yang ketiga adalah server.
Wearable device berbentuk gelang yang di dalamnya terdapat chip Bluetooth Low Energy yang dapat juga diaktifkan tanpa mengeluarkan suara ataupun bunyi. Software berbasis Android yang diinstal pada smartphone dari individu yang diawasi akan menjembatani komunikasi antara device dengan server, sekaligus akan memberikan informasi posisi dari individu yang diawasi melalui fitur GPS yang ada di dalamnya. Komunikasi antara gelang dan smartphone akan diterima oleh server dalam bentuk data lokasi, rute perjalanan, informasi waktu, dan lain sebagainya. Informasi-informasi tersebut akan diakses oleh pengawas lapangan untuk memastikan proses karantina mandiri atau karantina terpusat dijalankan secara baik dan benar. Individu yang memakai wearable device tersebut dapat melakukan berbagai kegiatan seperti biasa tanpa ada hambatan.
Untuk kerjasama, saat ini kami sudah melakukan penjajakan kerjasama dengan Badan Penelitian dan Pengembangan Daerah atau BP2D Jawa Barat. Kami merencanakan uji coba dalam skala yang lebih besar ya, dan nanti wearable device ini akan diuji coba langsung oleh orang dengan status positif COVID-19 seperti orang yang dengan status suspek, terkonfirmasi, atau juga orang dengan status kontak erat ya. Harapannya produk yang sudah kita hasilkan ini tentunya kami berharap agar ini bisa segera diimplementasikan oleh pemerintah ya, baik itu pemerintah daerah maupun di tingkat pusat ya. Artinya ada satu kebijakan yang mendorong supaya orang-orang dengan status positif ini bisa diawasi dengan menggunakan SIMONIC ini atau Smart Innovative Monitoring for COVID-19. Sehingga ini akan mempermudah pengawasan bagi si pengawas ya, untuk orang-orang dengan status positif tadi, agar mereka bisa melakukan karantina atau isolasi mandiri yang baik itu di rumah maupun di tempat-tempat yang sudah ditunjuk oleh pemerintah. Dan nanti sehingga harapan ke depannya bila ini dapat berjalan dengan baik, tentunya kita harapkan dapat menurunkan reproduction rate ya, baik itu di tingkat daerah maupun di tingkat nasional.
Next generation technologies like radar and satellite communication with high data rates call for innovative testing solutions to develop and manufacture RF components. A critical part in the development and design of large communication systems, as well as single RF components for microwave devices like oscillators and amplifiers, is phase noise measurement. This is used to show developers if a signal source noise is as low as it should be. With the launch of the R&S FSPN, Roda & Schwartz is adding a new member to their phase noise analyzer portfolio, enabling increased efficiency and reproducibility of phase noise measurements and VCO characterization from lab to production. The R&S FSPN only takes a few seconds to perform VCO characterization. This not only speeds up the lab processing time, but also multiplies the measurement throughput in VCO manufacturing lines. As the leader in this area, Roda & Schwartz was able to develop the best phase noise and VCO tester on the market, whose pre-configured setup allows easy testing and instantaneous results for the lab, as well as for production applications. The R&S FSPN, unrivaled sensitivity meets high speed. Find more information and learn about phase noise and VCO testing on our website.
5G is revolutionary. It promises extremely fast communication, ultra-reliable low-latency data links, and support for huge numbers of connected devices. To make it work, network providers depend on micro-base stations to provide high-capacity coverage through beam steering and massive MIMO, that is, multiple input and multiple output systems. The best route to each device is determined by pilot signals and computations on the base station side of the network. Through virtual prototyping with Simulia electromagnetic simulation, specifically CST Studio Suite, you can ensure the best possible network connections, even in complex environments where a hand or a large object in the street may block the direct signal path. You can also optimize antenna arrays and high-speed circuit performance, as well as ensure safety and critical regulatory compliance. Simulia electromagnetic simulation gives you the ability to simulate complex multipath environments, measure signal strength virtually rather than time-consuming manual measurements, and optimize microcell placement. Taking real-world scenarios into account, clean handoffs between base stations can be ensured with no coverage gaps. Simulia electromagnetic simulation provides efficient end-to-end 5G simulation solutions, allowing you to deliver high-performance designs in a short time frame and at lower costs, without compromising compliance, reliability, and safety. Let the revolution begin.
Jurnal Elektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as DOAJ, Google Scholar, Mandiri, and etc. JET is also ranked as Center 2 in Kemendristek Green Accreditation System. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge and therefore no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by various research institutes, and have more than 70 research centers and supporting units. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Good morning, ladies and gentlemen. I'm Ardita Septiani. I will be your MC for today. We are delighted to welcome you to the 2021 International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunications, or Icramet 2021. The Icramet 2021 covers multitude aspects in electronics and telecommunications research and health annually. However, during the COVID-19 pandemic, is organized online. The conference will last for 2 days, covering 6 keynote speeches, 55 paper presentations from 6 conference tracks. I hope that Icramet 2021 will provide a great opportunity for prospective participants to share their recent theoretical advances, research findings, and novel technology in the information and communication field. This year of Icramet conference theme is Managing the Impact of COVID-19 Pandemic, Together Facing Challenges Through Electronics and ICTs. It is an honor to me to introduce you and welcome the distinguished guest, Dr. Agus Haryono, as the head of Engineering Science Research Organization, National Research and Innovation Agency, BRIN Indonesia, Dr. Budi Prawara, as the head of Research Center for Electronics and Telecommunications, National Research and Innovation Agency, BRIN Indonesia, Dr. Ing Wahyudi Hasbi as the chair of IEEE Indonesia section, our patrons, Dassault Systems, PT Rohde and Schwarz Indonesia, PT Berka, PT PP Persero, Bank BRI. Also, our keynote speakers, Professor Muhammad Slim Al-Uini from King Abdullah University of Science and Technology, Saudi Arabia. Professor Wiku Bakti Bawono Adisasmito, MSc, PhD, as the Indonesian COVID-19 Task Force spokesperson. Professor Marco Di Renzo from Paris-Saclay University, France. Associate Professor Dr. Jumril Yunas, University Kebangsaan Malaysia, Malaysia. Air Vice Marshal Juleksi Tambayong as the Head of Research and Development of the Ministry of Defense, Republic of Indonesia. Also, Dr. Budi Prawara, Head of Research Center for Electronics and Telecommunications, National Research and Innovation Agency, BRIN Indonesia, as well all of the presenters and participants. Before commencing our opening ceremony, I would like to provide you with the speakers we have this morning. First, we will hear an opening remark from Dr. Novita Deanti as the Chair of Icramet 2021. Next, an opening remark from Dr. Budi Prawara as the Head of Research Center for Electronics and Telecommunications, BRIN, followed by remarks from the representative of our co-technical sponsor, Dr. Ing Wahyudi Hasbi as the Chair of IEEE Indonesia section. Finally, we will welcome Dr. Agus Haryono to officially open this event. Prior to begin our first agenda, we will do a screen capturing sessions. Our first agenda, we will have with us two distinguished speakers. First, Associate Professor Dr. Jumril Yunas from University Kebangsaan Malaysia, and Professor Wiku Bakti Bawono Adisasmito, MSc, PhD as the Indonesian COVID-19 Task Force spokesperson. For the first agenda, I would like to invite Dr. Novita Dayanti as the Chair of Icramet 2021 to give her opening remarks.
Thank you, MC. Distinguished Head of Engineering Science Research Organization, National Research and Innovation Agency, BRIN, Head of Research Center for Electronics and Telecommunication, BRIN, Chair of IEEE Indonesian Section and Chapter, keynote speakers, ladies and gentlemen. Good morning. Assalamualaikum warahmatullahi wabarakatuh. I'm Novita Dayanti, the Chairman of the conference. It is my great pleasure to be here to welcome all of you to the International Conference on Radar, Antenna, Microwave, Electronics and Telecommunication, Icramet 2021. This conference will hold virtually for 2 days, November 23rd until tomorrow, November 24th, 2021. The theme of the conference is Managing the Impact of COVID-19 Pandemic, Together Facing Challenges through Electronics and I-Series. We have invited 6 great keynote speakers. Professor Wiku Bakti Bawono Adisasmito, MSc, PhD. He is an Indonesia COVID-19 Task Force spokesperson. Professor Muhammad Slim Al-Uini from King Abdullah University of Science and Technology, Saudi Arabia. Professor Marco Di Renzo from Paris-Saclay University, France. Associate Professor Dr. Jumril Yunas from University Kebangsaan Malaysia. Air Vice Marshal Juleksi Tambayong from Research and Development of the Ministry of Defense, Republic of Indonesia. And last but not least, Dr. Ing Budi Prawara from the Research Center for Electronics and Telecommunication, BRIN. We would like to warmly thank to all keynote speakers who were willing to contribute to this conference. And we have selected 55 papers from 14 countries, which were covered in 6 conference tracks undergoing a double-blind review process. Thank you for the contribution and the excellent papers. We would also like to express gratitude to IEEE Indonesian section as technically co-sponsor, IEEE Indonesian chapter, APMTT as sponsor, and Himpanindo West Java as an organizer. Finally, many thanks to the members of organizing committee who worked tirelessly to prepare this conference, reviewers, our patrons, Disal Systems, PT Rohde and Swar Indonesia, PT Berkahan Daya Perkasa, PT Pembangunan Perumahan Persero, and BRI Bank, and other parties that cannot be mentioned here who have helped and supported this conference. I wish this event is successful and enjoy the conference. Thank you.
Thank you, Dr. Nofrita Idayanti, for delivering the remarks. Ladies and gentlemen, please join me in welcoming Dr. Budi Prawara as the Head of Research Center for Electronics and Telecommunication BRIN for delivering his remarks.
Thank you, Ardita. Distinguished Head of Engineering Science Research Organizations, National Research and Innovation Agency, BRIN, Chair of IEEE Indonesia Section and Chapter, keynote speakers, ladies and gentlemen, good morning. Assalamualaikum warahmatullahi wabarakatuh. I'm Budi Prawara, Head of Research Center for Electronics and Telecommunications, BRIN. It is my pleasure to be here to welcome all of you to the International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunications, Icramet 2021. Yeah, I think this is second time we have been doing this conference on pandemic condition. Yeah. We do hope the pandemic will be over soon. The theme of the conference this year is managing the impact of COVID-19 pandemic, together facing challenges through electronics and ICTs. I hope this event can contribute to solving problems and resource productivity by technology of electronics and telecommunications. Also by discussion and sharing knowledge from keynote speakers, authors, scientists, engineers, private sectors, non-governmental and intergovernmental organizations are responsible for building a better life and safety for society through the application of knowledge. On behalf of the organization committee, I would like to warmly thank to all the keynote speakers, Professor Wiku Bakti Bawono Adisasmito, Professor Muhammad Slim Aloini, Professor Marco Di Renzo, Associate Professor Jumbril Yunas, and Air Vice Marshal Juleksi Tambayong. Thank you for your willingness to contribute to this conference. We would also like to express gratitude to the IEEE Indonesia section as technically co-sponsor, IEEE Indonesian chapter, APMTT as a co-sponsor, and Himpenindo West Java as an organizer. Reviewers, our patrons, PT Dissolve System, PT Roda and Swas, Indonesia, Bank Rakyat Indonesia, PT Berka, and PT PP who have supported this conference. Stay healthy and enjoy the conference. Thank you.
Thanks to Dr. Budi Prawara for the opening remarks. Moving right along, it is now my pleasure to introduce you to Dr. Ing Wahyudi Hasbi as the Chair of IEEE Indonesia section to deliver his remarks.
Distinguished guests, colleagues, researcher, professional, ladies and gentlemen, very good morning. Assalamualaikum warahmatullahi wabarakatuh. A prosperous and warm greetings. First of all, please allow me to greet the Honorable Head of Engineering Science Research Organization, National Research and Innovation Agency, Dr. Agus Haryono, Head of Research Center for Electronics and Telecommunications, BRIN, Dr. Budi Prawara, Chair of the 2021 International Conference on Radar, Antenna, Microwave, Electronics and Telecommunication, Dr. Nofrita Idayanti, all distinguished keynote speakers from various countries, committee, all participants, ladies and gentlemen. It's such an honor and pleasure for me to be able to greet you all and give you a few words to represent the IEEE Indonesia section at the opening of this conference. On behalf of the IEEE Indonesia section, I would like to express my sincere gratitude and welcome you all to the 2021, the 10th International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunications, Icramet. The conference is an annual event organized by Research Center for Electronics and Telecommunications, BRIN, and this conference aims to bring together all researchers, scientists, engineers, scholars, students, and practitioners interested in advanced technology of communications and electronics, including remote sensing, radar systems, antenna devices, and techniques, RF or radio frequency and microwave theory and devices, electronics materials, devices, and components on circuits, wireless and wired communication, signal and image processing techniques, and all other related topics. Distinguished guests, colleagues, researcher, professional, ladies and gentlemen, the COVID-19 pandemic has led to a severe health and economic crisis with rising unemployment level around the world. Its impact on the ICT, electrical, and electronic sectors was become a central topics as well. While some segment of ICT, electrical, and electronic industry like consumer electronics, aviation, and automotive have seen massive dismissal of workers, the demand for semiconductors and devices related to the data centers and next generation of high-speed communication network system like 5G is steadily growing. Even currently, we are facing low supply of chips and semiconductors around the world. During the global pandemics, digital technology have become a critical enabler for connectivity, facilitating the continuity of our regular lives and connecting people more than ever before. As cities and countries have been asking the population to stay at home, more people have turned their computers and smartphones as lifeline and tools to substitute their in-person activities online. Some of the habits may continue in the new normal, or at least until a long-term solution to current challenges such as vaccine or medicine are become effective. Hence, the need to access a reliable digital infrastructure has become increasingly important, and certain aspects of ICTs are critical in period of isolation, such as increased ICT opportunities from teleworks, telemedicine, food delivery, and logistics, online and contact lens payments, remote learning, and entertainment. The pandemic is likely also to accelerate technology related to Industry 4.0 like robotizations and artificial intelligence. ICT, electrical, and electronics worker in telecommunication, energy, and healthcare division report a higher workload than usual. In such a, I believe that the theme of the conference, managing the impact of COVID-19 pandemic, together facing challenges through electronics and ICTs, is very relevant to these rapid changes and is very important in highlighting the innovation to accelerate the electronics technology and its utilization for humanity. Distinguished guests, keynote speaker, ladies and gentlemen, IEEE Indonesia as regional organizational unit of IEEE was founded in 1988 in Indonesia. And over the past 33 years, IEEE Indonesia has contributed significantly to various activities that encourage science and technology for humanity in Indonesia. Together with all volunteers, members, and all stakeholders, IEEE has produced various activities by supporting more than 60 high-qualified conferences every year, including this conference. And compared with the previous years, in 2021, the conference supported by the IEEE Indonesia increased by 53%. As we all know, the high-qualified conference paper within the scope of IEEE are published in the IEEE Explore Digital Library indexed by Scopus, Web of Science, and any other major databases, with more than 5 million publications and more than 15 million downloads every month. As we all know, IEEE always maintain high-qualified publication as part of our intellectual culture. IEEE also developed industrial standards such as IEEE 802 as a standard Wi-Fi that we use in our daily life. IEEE Indonesia also holds more than 40 professional, technical, non-technical, and administrative activities every year for all its members. Currently, we have more than 2,700 Indonesian members and more than 60 senior members consisting of professional, industry, academia, and government researchers. IEEE Indonesia also supported 26 technical society chapters and joint chapters, 30 university student branches, and 9 IEEE student branch chapters. All these chapters have become forum for members to have various international technical collaboration and social activities and provide Indonesian student members a great experience. In addition to that, we also have 3 non-technical affinity and interest group, namely IEEE Young Professional, IEEE Women in Engineering, IEEE Special Interest Group on e-health and telemedicine interest group as well. On 27 July 2021, IEEE Indonesia has established a cooperation agreement with Directorate General of Higher Education and Technology, in which IEEE activities support and synchronize the Indonesian Ministry of Education, Culture, Research and Technology program, including taking part in the Campus Merdeka Merdeka Belajar or Independent Campus Freedom to Learn. This historical collaboration shall strengthen the development of Indonesian higher education, especially to the 8 leading indicators of higher education in Indonesia. We are also exploring a cooperation with Indonesian industries in various activities and actively involved in providing and preparing related government regulations. In IEEE Indonesia, we also believe that research collaboration between all stakeholders is the key point to face all the current technological challenges and will speed up the advancement of innovation and technology in Indonesia. Ladies and gentlemen, on this occasion, I would like to express my gratitude to all of the Committee of Icramet 2021 who have worked very hard in preparing for this high-qualified IEEE conference and event. I'm very aware that putting together an international event with this size is not an easy task. Therefore, I sincerely hope for your cooperation and active participation in all of this program. I hope all of you will have an enjoyable and valuable experience during this conference event. I wish you stay active, stay healthy. Thank you and have a great day. Wassalamualaikum warahmatullahi wabarakatuh.
Thanks to Dr. Wahyudi Hasbi for the warm welcome. Now, please welcome Dr. Agus Haryono for officially opening the 2021 International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunication.
Welcome, ladies and gentlemen. Thank you to each and every one of you for being here virtually today at this important, the International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunication, Icramet 2021. My name is Agus Haryono, Acting Chairman of the Research Organization for Engineering Sciences of the National Research and Innovation Agency. It is such a great honor for me to speak on behalf of BRIN. Let me begin by giving you a warm welcome to this virtual conference. Before we get started, I would like to express my appreciation to the Honorable Chief Guest, respected Director, speakers, and all of other guests. We could not have done this conference without your participation. I am also grateful to all the Icramet 2021 steering committee members, and also the members of the organizing committee, and all the volunteers who have arranged us this wonderful program. I welcome all the participants from academia, students, industrial practitioners, and researchers. We are also fortunate enough to get supported by partners who also sponsors and organize this scientific conference. This conference is aimed to bring together researchers, academians, and industries to share the information and share the research result. This year is the second year to be held virtually with the theme Managing the Impact of COVID-19 Pandemic Together Facing Challenges Through Electronics and ICTs. The speakers in this program are uniquely placed based on their topics and on the telecommunication and information technology. I hope you will have the most productive 2 days of interesting and stimulating discussions. I would like to close my speech by expressing my sincere wishes for this conference will be a great success, not only as a chance to share knowledge and share experiences in telecommunications and information technology, but also discover new opportunities in the still growing area of research on the future technologies, as well as collaborative research opportunities. Thank you to the Research Center for Electronics and Telecommunications and the organizing committee that has organized this wonderful event. I would like to all of you have a fruitful and productive discussion today. Last but not least, I would like to sincere thank to all of you for being able to join this virtual conference during this COVID-19 pandemic. Please stay healthy and happy during this long pandemic. By say Bismillahirrahmanirrahim, I officially open the Icramet 2021 conference. Again, thank you very much and enjoy the conference.
Thanks to Dr. Agus Haryono for officially opening Icramet 2021. Next, we move on to screen capturing session. I would like to request all honorable guests, distinguished speakers, presenters, and all of the participants to turn on your cameras. We will capture the frame 3 times, so I will do 3 times of the signaling. For the first, in 3, 2, 1. Second, in 3, 2, 1. And all of the participants, please turn on your camera. And last, in 3, 2, 1. For the first, in 3, 2, 1. Thank you for all your assistance in this screen capturing session. Ladies and gentlemen, we have concluded our opening ceremony. I would like to thank all honorable guests, distinguished speakers, and all of our presenters and participants for the participations and attendance in the opening ceremony of Icramet 2021. Now, we are beginning our first agenda, that is to hear the keynote talks, which will be delivered by Associate Professor Dr. Jumril Yunas from Universiti Kebangsaan Malaysia and Professor Wiku Bakti Bawono Adisasmito, MSc PhD, as the Indonesian COVID-19 Task Force spokesperson. The first keynote speech session will be moderated by Dr. Natalita Maulani Nursam. First, I would like to introduce you to Dr. Natalita Maulani Nursam. She received her bachelor degree of engineering in electrical engineering from Universitas Indonesia in 2004. Then she received her Master of Engineering from Australian National University in 2010 and received her PhD degree in Material Chemistry from a joint program between the University of Melbourne and CSIRO in 2016. She joined Indonesian Institute of Science, or now BRIN, in 2006. Her research interests includes engineering of photovoltaic devices and their electronic applications, and modifications of functional materials for photovoltaic and photocatalysis. Please welcome Dr. Natalita Maulani Nursam.
Yeah, thank you very much, Ms. Ardita, for the kind introduction. Hello and good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. I hope everyone is doing great this morning. First of all, I would like to thank the organizing committee of Icramet 2021 for inviting me as moderator. I'm Natalita. I'm a research scientist at the Research Center for Electronics and Telecommunication of the National Research and Innovation Agency, or BRIN. and I'm going to be your host for this morning session. So this morning, we will have two exciting talks from two of our distinguished speakers, Associate Professor Dr. Jumril Yunas and Professor Wiku Bakti Bawono Adi Sasmito, PhD. Good morning and welcome to Dr. Jumril and Professor Wiku. Thank you for joining us this morning. But before we proceed to the first speaker, I would like to read some of the general guidelines for this session. So each keynote talk session will be allocated for a maximum of 45 minutes, including Q&A. So each presentation itself ideally should be around 30 to 40 minutes at the maximum. And for the audience, if you have any questions at the end of the talk, you can use the raise hand feature on the participant menu on your Zoom screen, and I will call out your name so that you can ask your question in person. Alternatively, you can also write down your questions later in the chat menu, and I will read your question later on during the Q&A. So now let us proceed to the first talk, which will be delivered by Dr. Jumril. But before that, let me briefly introduce him. So Associate Professor Dr. Jumril Yunas received his bachelor and master in electrical engineering from the University of Technology from the RWTH Aachen in Germany. In 2008, he received his PhD in semiconductor technology from the University Kebangsaan Malaysia. He has several research experience, and currently he is working as a research fellow in MEMS Research Lab in IMAN, UKM, and he is currently working on developing lab-on-chip project. His research interests include MEMS and NEMS technology, lab-on-chip, microsensors, microactuators, RF, power electronics, and also optoelectronic devices. And today, Dr. Jumril will be giving a talk about microfluidic system for biomedical applications. So without further ado, Dr. Jumril, the floor is yours.
Okay, thank you very much, Dr. Natalita, for this kind introduction. Assalamualaikum and a very good morning to all. So I try to share first my slide. Okay, yeah. So you can see the slide and the first is clear?
Yes, thank you.
Okay, thank you very much. Okay, first, I would like to thank the organizer for inviting me to come to give talk in at this conference. This is really an honor for me. Actually, today I would like to talk about a very technical topics. So the title is Flexible Microfluidic Delivery System for Biomedical Application. So why I use this term flexible? So because we use the material having very good mechanical property, able to be deformed and have also the magnetic property. So my name is Associate Professor Dr. Jumril Yunas. I'm from Institute of Microengineering and Nanoelectronics, IMAN, from University Kebangsaan Malaysia. Okay, this is the contents of my talk today. So I'll start with introduction, then I show you the mechanism of the actuation of the flexible membrane, which is the focus of my talk today. Then I'll show some publication for the MEMS microactuators, microfluidic valve and pump, and also microfluidic mixing system. Then I show you some tests for the functionality, to see the functionality of the devices, and I'll close this talk with a conclusion. Okay, this is the introduction. Microfluidic delivery system is a system that uses that is used to transport microfluidic sample from the sample reservoir. Here I show you a schematic of general system kit of the microfluidic. It should be able to transport microfluidic sample from the reservoir to a biological or chemical analysis system, or to a miniaturized lab, or even to human body, so such as for drug injection. So the system consists of micropumps, microvalve, and also micromixers. So the pump and valve is used to transport the low sample volume, having precious dose that are required due to its compact, thin, and small size, and able to control the vibration in various way. While the mixer is to mix the sample region that require homogeneous characteristics, such as for chemical analysis, for sample preparation, pre-concentration for detection, PCR for virus detection, and some other biomedical analysis. So if the mixing process take too long time, so it make the analysis too slow, and that may kill the sample, such as DNA or cell or virus. So the important part of the actuator that is driven by electromagnetic field induction of magnetic membrane. So this is the important part. So the actuator, having the function to precisely control the pressure, enabling the microfluidic sample flow, and for fast mixing. So there are several methods to enable pumping and mixing. So among them, so electromagnetic actuator found as compact and controllable device. However, it is limited only in short fluid flow range. So therefore, there is the challenge to expand this fluid flow range. Either we need to make a higher fluid flow, especially for dialysis process, or to reduce the fluid flow, especially for biomedical analysis system. So to improve this performance, so we need to design and fabricate actuator membrane with having the flexible material quality, with a high magnetic property. So these are some of the potential application of the microfluidic delivery system, such as in lab on chip. Lab on chip is a miniaturized lab that fabricated on a chip. So this chip will need the flow rate from 10 nanoliter minute up to 1 milliliter per minute only. So this chip include the micromixer, micropump, microvalve, and some other reaction chamber for cell separation, for cell detection, and etc. Another potential application is portable insulin delivery to inject the insulin drug. So as you know, the diabetic patient have to inject several times a day with the flow rate between 1 microliter per minute up to 1 milliliter per minute. So with the controllable pumping system, so it can have the patient to deliver the drug 1 time in a day. So another potential application is for wearable dialysis systems, such as for blood filtration process, which require the flow rate from 1 milliliter per minute up to 100 milliliter per minute. So that means we need a pumping system to deliver the dialysis or to transport the blood at a very high fluid flow range. This is a schematic of microfluidic system. It consists of actuator and microfluidic system here on the top of the device. So the actuator consists of electromagnetic coil that include the current planar microcoils on PCB laying perpendicular to the permanent magnet and magnetic polymer membrane. Yeah. This membrane include the thin film flexible matrix from magnetic membrane, magnetic chamber, and also permanent magnet. Yeah, the membrane is made of PDMS, polydimethyl siloxane polymer, which is mixed with magnetic particle inside, and also this part will be bonded with a microfluidic part that include the inlet channel and outlet channel, a fluid chamber, and also a diffuser valve here. Okay, here I would like to show you how the mechanism for the actuating using electromagnetic magnetic field for pumping purpose. So actually the actuators consist of a flexible membrane and also electromagnetic coil. Yeah. So the function of these actuators is as a pressure controller through the membrane. So through the push-pull action, it will create the pressure difference between the chamber here and the channel. Hence, it's enabled the fluid flow from the inlet to the outlet. So thus the structure consists of copper-based planar conductor metal on PCB, on glass, or on silicon, and PDMS membrane made of polydimethyl siloxane polymer material with magnetic. So that must be a magnetic composite material. So the mechanism how this device actuates. So due to the interaction between magnetic field and magnet here on the top of the coil that finally produce the magnetic force. So if we apply voltage here, so the current flow through the coil, it will generate electromagnetic field. And if the magnetic field interact with the magnet, so it will produce magnetic force, hence enable to push and pull the membrane up and down. So this force is depending on the height of the magnetic induction and the volume of this magnet. Yeah? So it is proportional to the volume of the magnet and also proportional to the electromagnetic field, yeah, gradient generated by the coil. So if the coil have the long distance between the coil and the magnet, so that means that the force will be low. And also the deformation capability of the membrane will be depending on the this magnetic force. The higher the force, so the higher the membrane will deform, and also depend on the mechanical properties of the membrane, yeah, such as the Young modulus and etc. So we have studied the design of the membrane. So we try to study how's the effect of the membrane shape on the deformation capability of the actuator. So we try with the first with the circular membrane type, and then with the square type, and also the rectangle type. So we found that circular membrane shape will have the highest membrane deformation among other shape. And we also have studied the effect of the material. So we try to study the PDMS, silicon, and polyimide. We found here that PDMS will have the best material for the the flexibility, as the best flexibility material for use as actuators among other two material in the study. Here, I would like to show you how our microfluidic system has been fabricated. So, as I mentioned before, the system consists of actuators and microfluidic part. We have here inlet and outlet, and we have also here the valve and pump chamber. So, for the actuator, we have electromagnetic part consisting of planar coils, and we have mechanical parts having the matrix type of matrix polymer composite. We can fabricate this part separately. So here I can show you that first we fabricate here the microcoil part by etching the material, electroplated material on PCB, or by depositing the metal layer on silicon or on glass. And then we fabricated the membrane and the chamber part to create the magnetomechanic part here. So we first we etch the silicon to create a hole, and then we transfer a polymer composite having the matrix form here and put on the top of the silicon hole, and we bonded onto the actuator, onto the microfluid electromagnetic part. So we have here an actuator, and then we can fabricate another part, namely the microfluidic part, by using soft lithography or micro molding. So here we pour the polymer material onto a master mold, and then after curing, so we peel out and then transfer onto the actuator. Then we bond them together, so we got a complete system of the microfluidic system. So this is some photograph of process fabrication of the microfluidic system. So we have here actuator, and we have here the microfluidic part, and we bond them together. So we got a complete system here. Then we try to let microfluidic flow through the microchannel to see if there is any leaking on the device. Okay, the most important part of the electromagnetic actuator is the magnetic membrane. This membrane is developed by mixing magnetic particles made of NdFeB material. So we mix with PDMS to get a magnetic composite material. So for this process, we use micro molding, that can create the matrix form of the magnetic polymer mold. This is a schematic of this process fabrication. First, after we have a master mold, so we pour here the polymer composite, and after hard cure, so we peel up, and then we transfer onto the actuators. So here, through this process, we can have a matrix part of the polymer composite material. This is photograph of the fabricated membrane having the matrix type 3x3. So we take picture under SEM photograph, and this is the photograph of the polymer composite membrane after transfer onto the silicon substrate. So we characterize this membrane property by observing through the SEM and VSM measurement. So this membrane composite having the composition with NDFEB from 10%, 20%, and 30%. And we observe the effect of this composition on the physical property and magnetical property. So we can see here. So if we mix with much higher magnetic particles, so the membrane thickness will increase also. Yeah. So that means the higher the composition, so the higher the volume of the membrane. This should also increase also the magnetic property, and this have been measured using VSM. This confirm this hypothesis. So through this measurement, we can see here that the membrane having the magnetic particles up to 30% will have the highest magnetic induction property here among other composition. So therefore, the more magnetic particles, so the thicker the membrane, hence it increased the magnetic induction. So the performance of the membrane have been also tested by using the membrane deformation. So this mechanical property is analyzed on the deformation capability. So we measured the deformation of the membrane using the laser displacement method. So here we use two types of the membrane. First one is the membrane with magnetic flat magnetic composite layer, and the other one is the membrane having the matrix type of magnetic composite polymers. So this is the schematic of the measurement setup. So we have here our device under test. Then we have a power supply to give input power for the microcoil to generate electromagnetic field. So on the top of the device, so we put our laser displacement meter. So if the membrane deform, so it will give a signal to this measurement unit. And we also measured how high the Gauss magnetic induction generated by the magnet or generated by the electromagnetic coil. So this is the photograph. We have here the device under test. So the membrane made of PDMS with embedded magnetic particle. So we try to mix the membrane having the composition from 5% up to 30% of weight, and we observe the property of the membrane. For this measurement, we give input power maximum of 1 watt only. This is the result of our analysis. So two types of the membrane of analysis, namely flat, embossed, and matrix type. And we found here that the maximum membrane displacement of approximately 9.2 micrometer have been resulted from this measurement for power consumption of maximum 1 watt. So we use here 1 ampere, so the power is 1 watt. We found that the flat membrane here show that if we increase the non-particles composition inside the polymers. So we can see that this membrane will lose its flexibility. So it will deform lower than the low magnet composition. However, if we use a matrix form, so we can see with the increase of the magnetic particle inside the polymer, the membrane deformation will be better, will be higher. So from this analysis, we can conclude that making matrix, the deformation can be improved. So this actuator, we found that it is able to deform periodically, which is required for peristaltic fluid pump application. This is the photograph of our final device. We have here inlet and here outlet, and we have the chamber here having a square type, having a radial type. So here we also can see that the channel having the width or the depth up to 200 micrometer have been fabricated. So we can also see here that the membrane having the pillar structure have been also successfully fabricated. We can see here under a 3D view. So this is the actuator part, and the top of this actuator we have a transparent microfluidic part. So for this device, we require only the total area dimension of maximum 1.5 times 1.12 cm square. So it's a small device when we compare with here 5 cent ringgit Malaysia. So it's almost 10 times smaller. Yeah. So to see the functionality of the actuator for the pumping system, we try to observe the fluid flow in the fluid tubing with the response of the actuator membrane actuation here. So we have here the fluid tank, the reservoir that should be able to. We have here the device under test, our micro pump that should be able to deliver fluid from the tank here to the other side of the microfluidic system. And if this actuation is working, then we can observe here the fluid flow by using here camera connected to the computer. So we can see here photograph of the system. We have here the tank, the fluid tank, the reservoir. We have our device under test here, and the fluid flow observation here. So we can see the fluid flow during the test. So for this test, we use the membrane having the matrix 2x2 and 3x3. As well as the coil form such as coil diameter and 1 layer and 2 layer coil form. And this observation was done for about 2 minutes. So here we can see the result of our observation. So we first, we try with a 2x2 matrix using a bigger coil, large coil diameter. For this test, we got only 2.75 nanoliter per minute. So this type of the pump only can deliver fluid flow up to 2.75 nanoliter per minute. If we use a double coil as the electromagnetic generator, we can see that the pump can is able to deliver fluid flow up to 6.5 nanoliter per minute. So it improves about 3 times. Yeah. So therefore, we can conclude that our system has been successfully functioning. The system is able to transport of the liquid sample in low range of flow rate from 2.75 nanoliter per minute up to 6.5 nanoliter per minute. Next, I would like to show you the electromagnetic actuator used for mixing purpose. So this this device having a pillar on inside the chamber, so which is needed for fast mixing. We call this device as a active micromixer. Yeah. So the function of this mixing chamber is for creating turbulence, yeah, through the pillar movement and membrane deformation. So here we have the mechanical part with the moving part of the membrane and pillars, and the electromagnetic part here to generate electromagnetic magnetic field. Yeah. And then we have here also the microfluidic part, consists of inlet, outlet, first inlet and second inlet. So we have also here a micro channel, and here the outlet. So the mechanism for mixing process is similar for pumping, yeah, for our pump system. So the mechanical part here consists of array of micro pillars on mechanical movable mechanical membrane. So here we can see if magnetic force applied on the membrane, so this pillar will move like this. So hence it create the turbulence inside the chamber. So this structure consists of copper planar conductor trace on PCB and flexible membrane with magnet and pillars. Yeah. So the mechanism similar to the pump function. That means we use interaction between magnetic field and magnet to produce pillar deformation, pillar movement here on the membrane. Then it should actively mixing the fluid sample inside the membrane. Okay, we analyze the effect of the pillar design. Here we have micro pillar having the radius about 50 micrometer or a diameter of 100 micron. And so we see also the effect of the space distance between the pillar and also the pillar radius. So we found here the membrane having the circular shape. Yeah, is the shape that enable the deflection of the highest deflection of the membrane. Yeah. So if we put a pillar on this membrane, so the deformation capability will slightly reduce. Here also we can see that membrane with a circular shape without micropillar will have its highest deformation capability. So if we put pillars having various radius, so it will slightly reduce its deformation capability. Yeah. So that means that membrane without micropillar will deflect higher. So yeah, for membrane with pillars, the deformation will be affected by its dimension, as the pillar width or the distance between the pillars. Okay, after fabrication, we try to test the mixing result. Here we try to mix two colors of food colors dye. That's streamed into the micro mixer. So this mixing process will be captured by our microscope that connected to the computer, and the color image after mixing then converted to a mixing index value by using color scale factor. So that will be converted to the mixing index value. So here, if the index value is 1, that means it has completely mixed. But it should be considered as mixed if the value above 0.8. So we have here, we try to mix two colors different of dyes without any actuations. So that means we let the samples mix under diffusion process. That means the mixing will be result due to the diffusion between the molecules. So we found here after 2 minutes, it is still difficult to mix. This is a typical characteristic of microfluidic property. So we call as non-mixing. So if we on our actuator using frequency 1.1 up to 3.7, so we observe here that after 60 minutes, so it is already mixed, and before 2 minutes, below 2 minutes, so it's already complete mix. So we therefore we conclude that there is no improvement were shown in the natural diffusion in the passive mode without any turbulence inside the chamber. So and we found also here that the mix index increased significantly, reaching about 0.8 mix index within 60 seconds when using actuation of the pillars on the flexible membrane. So finally, we try to see the functionality of our micro mixer by test mixing of the sample for sugar level analysis, for glucose level analysis here. So here we try to mix a DNS reagent and glucose solution. This is actually the standard procedure to check the sugar level. So we have here the composition one by one. First, we mix our samples by using conventional centrifuge system. So that generally used in biomedical instrumentation, and then we mix also the sample using our micro mixer. So if mixing happen, so the sample we put in UV vis instrumentation. So if the mixing happen, so the absorbance signal will show to be appear. So we can see here the absorbance. And then we provide similar plot with small difference of this is linear aggression, which means the linearity of the glucose detection, which likely match with the conventional method. So we can see here that our mixer will show its profile similar to the conventional. And if we compare also with the chamber without any turbulence inside, so there is no detection of the glucose concentration here. So that means we can conclude that our microfluidic mixer is reliable for biomedical sample mixing, with several advantages, such as we use low sample volume, so it is fast, and we use a simple detection procedure. As conclusion, so I have shown electromagnetic driven microfluidic delivery system that consists of micropump, microvalve, and micromixer. So we have also seen a simple technique in fabricating the system using MEMS technique. So the system part consisting of electromagnetic actuator and microfluidic system that can be fabricated separately, yeah, and then we can integrate the system with additional bonding process. So the flexible membrane of the actuator is made of polymer composite, PDMS, with embedded NdFeB magnetic particle as actuator. So this actuator can obtain the membrane deformation up to 10 micrometer. So we have also seen the functionality of the micropump that show the controllable fluid flow rate at low range of nanoliter per minute. So we have also test our micromixer using by mixing the glucose and DNS reagent that show that this fabricated micromixer can obtain mixing index above 80% only in 60 seconds. Yeah. And finally, this magnetic polymer-based fluid delivery system, pump, valve, and mixer will have its potential application to regulate precisely the microfluidic sample for various biomedical sample preparation, and also for some biomedical analysis purposes. Yeah, okay, I think that's all my talk today. I thank you very much for attention, and I welcome for any question, suggestion, or discussion. Thank you very much.
Okay, thank you very much, Dr. Jumril, for the very interesting and very elaborate presentation. So, ladies and gentlemen, now we are entering the Q&A session. So I would like to invite anyone in the participant. If you have any question for Dr. Jumril, please raise your hand. And also you can also write down your question in the chat. Let me check first. Is there anyone asking? Oh yeah, we also have some audience in the YouTube, because this event is also broadcasted in YouTube. So if anyone from the YouTube audience have any question, you can also send your question in the chat menu. Okay. So we have one question actually from the chat, the Zoom chat. This question is from Mr. or Dr. Johnny Wellman Simatupang. He's asking if what kind of materials you use for the substrate in your system.
Oh yeah, okay. As I mentioned before, the system consists of three parts. Yeah, so the microfluidic part and actuator part. For the actuator part, so we can choose several type of substrate, such as silicon or glass. So for this type of material, so we can put electromagnetic coil, planar coil. Yeah, so it must be a planar, not solenoid. A planar coil that can be fabricated by a tatted process or metal evaporation process. So Another type of the substrate is the PCB. This PCB is common substrate for any electronic circuit. Normally, it has been electroplated with copper coil. So this electroplated copper coil can be patterned, can be etched to create a planar electromagnetic coils. So we can choose either silicon, glass, or PCB. So another advantage of silicon or glass. So glass is transparent. So that means if we use glass as substrate and we have also PDMS as substrate, both material are transparent. So we will have a transparent microfluidic delivery system. So it's a very very useful to observe the mechanism inside the chamber. Silicon can be used. So if we want to integrate with CMOS IC circuitry, so normally MEMS device is fabricated after CMOS processing. So we can also use this substrate to be able to integrate with IC circuit.
Okay, thank you very much for the answer. And then there's another question from the same person, from Mr. Johnny Wellman. Is it possible to use 3-5 semiconductor materials as substrate instead of the substrate that you have mentioned before, Dr. Jumril? And also, what is the advantage and disadvantage for those substrate compared to the silicon?
Oh yeah, okay. 3-5 compound. We have once tried also 3-5 compound as we want to integrate with a cell photo detection. So using photodiode, LED photonic device. So as the source of the light for this detection, so we try also the 3-5 compound such as gallium arsenide photo LED. So it's will be also useful if we use 3-5 compound semiconductor if it is regarding the photo effect. For detection or for manipulation of the biocell. However, in our studies, we use a silicon substrate because silicon is cheap material, so it is already the technology is already familiar. So we use only silicon, but it is not possible to use also 3-5 compound material, but for limited application.
Okay, thank you. So I guess in summary, you should consider what the application is to choose what kind of material that can be used as a substrate, and also maybe cost is also an important consideration. Okay, thank you very much. And also thank you, Mr. Johnny. Oh, there's another question from the same person. This is the last question before we move on to the next person asked. So is it your fabricated devices already commercial or still in lab scale devices?
Yeah, it is still in a lab process as we still need to optimize the design and we still to test the reliability of our pump and mixer system as if we use for microfluidic sample, it is difficult to use the device for several times as we use chemical fluid system. So sometime after first test, so the channel will be clogged, clogging. So So we cannot use the device anymore. So therefore, we still have to study the reliability of the device. Yeah.
Okay. Okay, so it still needs some optimization
Yep.
towards commercialization. Okay, thank you very much. And thank you, Mr. Johnny Wellman, for the question. We move on to the next question is from Dr. Yuyu Wahyu from BRIN. How to ensure that the force of pump is linear?
We have measured the magnetic force, generated through the interaction between electromagnetic coil and permanent magnet. It is actually depend on the input power. So if we increase the current, so the magnetic field also will increase. Hence, the magnetic force also will increase. So how to ensure the linearity, the consistency of the magnetic force? We should make sure that the device doesn't vibrate, must not vibrate. As if the system vibrate, so because the membrane will vibrate after giving the input. So if the system vibrates, so the distance will also be vibrating. So therefore, we have to ensure that the system is compact and have no effect with the vibration.
Okay, thank you very much. I hope it answered the question from Dr. Yuyu. And we still have another 2 minutes, maybe one more question, last one. We have one question from Dr. Dedi from BRIN. He's a magnetic expert. So Dr. Dedi said you use the neodymium-based composite magnet as pumping component on flexible substrate, but the BR is very low, around 0.2 G in the hysteresis curve. Is that correct?
Yeah, maybe it's correct. This is actually the experiment made of my students. So if you want to ensure if it is correct or not, so we can discuss later.
Okay, so basically it's still relatively low, so maybe it can be optimized in the future. So yeah, we still have 1 more minute. Is there any question from the audience for live Q&A? Just checking one more time. Okay, so I guess if there's no more question. Oh, okay. Sorry. So Dr. Budi, I have a question for Dr.
Yeah, thank you, Pak Jumril, for your interesting presentations. So so you show us your microfluidic prototype. So I'm interested to know, could you share to us what kind of equipment or facilities that you use for this kind of experiment, especially for manufacture for micro component?
Okay, Dr. Budi, thank you. So actually, for MEMS fabrication, we don't need special instrumentation. It is similar for IC fabrication. What facility we need for IC fabrication, so we can also use this facility for fabrication of MEMS devices. So for this microfluidic device, so we for creating the membrane, so we use a spin coater, a molding system, and also we use metal evaporation or sputtering deposition system. SEM we required for observe the fabricated structure. So there is no special equipment. It is similar to the IC fabrication process facility.
How about for the pillars? You show us the microsize of some pillars for mixing the liquid.
Yeah, pillar is made first. So we need to create the master mold. So that means this master mold can be created by using standard lithography process. We can use SUH, or we can also use etching structure of silicon substrate by using deep RIE. So yeah, we need deep RIE equipment to create the. So the master mold for the pillar actually has the form of trends. Yeah, so it must be a trends. Then after we pour the polymer, so and we fill up, so it will result to a pillars. So we use a standard photolithography process for the pillars.
Okay, thank you very much.
You're welcome.
Okay, thank you very much, Dr. Budi Prawara, for the question. And I guess that concludes our session with the first keynote speaker. Thank you for everyone who have participated in the discussion. And of course, thank you very much, Dr. Jumril. And on behalf of the organizing committee, I would like to express our token of appreciation for delivering keynote talk at the 2021 Icramet. Thank you again for your time, and we hope to see you again in the future. Please give a round of applause for Dr. Jumril Yunus.
Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, so now let us continue to the next keynote speaker, Professor Wiku Bakti Bawono Adisasmito. Professor Wiku will be giving a talk about the importance of data collection and data management during the COVID-19 pandemic, which is of course very highly relevant to our current situation. But before that, let me briefly introduce him. So, Professor Wiku Bakti Bawono Adisasmito, MSc PhD, received his veterinary doctor degree from the Bogor Agricultural Institute, and then he received his master and PhD degree from the Colorado State University in the USA. He has several impressive research experience, such as being a researcher at the US CDC Division of Vector-Borne and Infectious Disease in Fort Collins, Colorado, and also in the US CDC WHO laboratory in San Juan, Puerto Rico. He has been inaugurated as a professor of the Faculty of Public Health in the University of Indonesia, and also as an adjunct professor in the field of infectious disease at the Tufts University. He is currently a lecturer at the University of Indonesia, and during the COVID-19 pandemic, he became the chair of the expert team and also a spokesperson for the task force for the acceleration of COVID-19 response. His research interests include infectious diseases and also dengue fever, and he also has an interest in the health analysis and policy, hospital management, and environmental management. Welcome, Dr. Wiku. And the floor is yours. You may start your presentation, please. Thank you.
Okay, thank you. Good morning. Assalamualaikum warahmatullahi wabarakatuh. It's an honor for me to be invited in the 10th International Conference on Radar and Antenna Microwave Electronics and Telecommunication of the Indonesian Institute of Science. I'd like to mention the Honorable of Dr. Nofrita Idayanti, Dr. Budi Prawara, and Dr. Wahyudi Hasbi, and also Dr. Agus Haryono, and also, of course, the previous speaker, Dr. Jumril Yunus. This sessions, I think it's an important sessions for the LIPI, the Indonesian Institute of Science, but I'd like to raise the issue about the data management and how we handle the COVID-19 from that perspective. And I will mention about how we utilize the technology, the system, to combat the COVID-19. And for that, allow me to share the screen about COVID-19 and how we deal with this issue in Indonesia. So first is that we have the silver lining of the pandemic COVID-19 in Indonesia, and one data or satu data and its transparency for all is an important issue because our enemy is only one, which is the virus. And we have to make sure that everybody in the world, not only in Indonesia, but of course I will be talking about in the perspective of Indonesia, that we need to be together and combat with this challenge or enemy, whatever we want to call it, the COVID-19 or the virus. And for that, we need to have the navigation, which is the one data of COVID-19. And I think this is the breakthrough of one data in Indonesia, starting from COVID-19. And of course, this will inspire for other one data programs in Indonesia, whether it's in the health sector or other sectors, or cross-sectoral, or cross-country, cross-regions, or internationally. Because if this is a pandemic, I think we need to read the same data across countries, across the world. But of course, that remains the challenge for now. And I don't think this will be solved in the near future, but at least we have to start from ourselves, from Indonesia. If it's not from Indonesia, then it's from one area. And then it has to be expanded into other areas in Indonesia. So if we look at this kaleidoscope of the COVID-19 handling in 2020, in terms of time, within several weeks and months, the progress of the issue is really fast, and the world was responding quickly as well. And the response from the country, including Indonesia, not necessarily in the same speed, because it's relatively new. So that's why they don't know what to do. And then, of course, they will be learning from one country to the other. And in each country, they have the uniqueness in responding the issue and mobilizing the resource to combat and to prevent the issue to be specific. And if we look at this situation, we know that the condition was not ideal. Even the world authorities, through the World Health Organizations, was in the positions only to inform how the country to respond. But each country has to find their own self in terms of responding to COVID-19, including Indonesia. And from the beginning, when the formation of the task force, when I joined, which is on the March 13, we ascertained the situation, and then we wanted to make sure that we have the resources to combat with this and protecting the nation, protecting the people. And we always in communication cross-sectoral with other ministries and institutions, central government and also local governments. And that is the key, because we are not a small country. We are a big country with high population. And that's why our cohesiveness in responding to this issue has to be quick and effective and efficient. And for that, we believe that if we have the good data, we can formulate a specific and targeted policy. And that's what we did for the first year and continue to the second year. So if you look at the national COVID-19 data strengthening concept, because we believe from the first time this is a new disease. We don't know anything about this disease manifestation. We know the virus, but we don't know how this virus manifested in the human. because the transmission is human to human, although the origin of the virus is from the animal. So that's why what we need to do, we need to make sure that the whole data has to be included into one system. This is not only to put all of the data into one basket and then analyze it. We need to make sure that we restructure or structure the data in a way that with the same data, with the complete data, can be accessed by the all stakeholders, by the all actors or institutions, resulting in the same information. Because at the beginning, because we were in the way that we manage is usually sectoral, and that's has been disrupted by the COVID-19. Whether we like it or not, if we didn't change, then we could not win with this, with the combat with the COVID-19. And we put all of the COVID-19 data, from the health data, from the treatment aspect, from the plasma convalescence data, the people mobility, because this is one of the risk factors, and then the behavior aspects, and then we make the infrastructure of the limitations of people mobility, and we have the PPKM micro data from central to local level at the village level. We want to make sure that we know all of the activities of the people that are risky to the COVID-19 transmission. And then we mobilize the volunteers, the journalists across nations, thousands of the journalists recruited. And then we want to make sure one narrative messages from the central government to make sure that everybody is in the same pace. So that's why we need to have a dashboard, a data that is accessible by all levels. And that's a big challenge. And that's, I think the technology has to come. But of course, in the eyes of the Indonesian Institute of Sciences, of course, we'll say that we have a lot of information. We have a lot of sciences that can be used. Yeah, of course. But then when we need to implement that, a lot of experts are tossing their own science. And I think we need to have someone or an institution that can cook all of the sciences into one solution. And data is one of the issue. So that this is the way that we manage the situations. So all of the data are included in this system. So I'd like to describe the step-by-step of development. The first is that we call it Bersatu Lawan COVID. So we want to make sure that we are one vision. And then at the beginning, of course, this is a health issue. So we need to make sure that we put all of the data in from the detection aspect, which is the laboratory. And there are a lot of technological issues in the detection aspect, from the PCR laboratory, the BSL-2, BSL-3 laboratories that need to be mobilized, need to be standardized, so that all of the PCR tests conducted across nation, across laboratories are validated, and to make sure that the results with the same standards. And it's a big challenge. And then also the hospital, we want to make sure that their operation somehow has to be standardized. And we knew that hospital operate by themselves relatively. They are in the same format if they claim the insurance from the BPJS. So that's why we need to make sure that the private hospitals also engage with this, with which they have different systems. Each hospital, they always modify based on the needs of the customers, the internal customer and external customers. So there are a lot of systems. The laboratory has its own system, hospital has its own system, public health offices, they have their own system, logistics have their own system, and then we need to put things together. For people who don't know the science, they think it's easy. Okay, all applications put together into one applications, and one day or 1 week, everything settled. That's not the issue. We cannot do that because everything has its own definitions or variables. So that's why in solving this issue, it's not only about the science. It's about communication, about coordination, and collaboration. And if we fail to communicate, we fail to collaborate, we fail to coordinate, the science itself will not be the solution. It's only on the shelves. And once we make the first generations and then we move on to the second generations, because we believe that curative is not the answer. Preventive and promotive actions for this issue is the key. And everywhere in the world, usually their approach for the disease is always curative. And we know if we go into the curative stage, the healthcare facilities will not be able to absorb or provide services to the public because the number of the beds are limited. The number of the people who can be infected enormous in the country like Indonesia. So that's why we need to make sure that we we can control the behavior changes in the people so that they will not be exposed, so they will not be sick. So that's why, and then we need to make sure that everybody in Indonesia understand about the situations. That's why we need to have the journalist, which has one narrative. And then the healthcare, healthcare workers are also limited. So we need to make sure that we can mobilize the volunteers, but when they act professionally. So we need to train them, etc. And we need to pull things together into one data so that it can be assessed whether we put the resources in the right places. So, and then the next generations also, we include the data of the population mobility in the planes, in the trains, so that we can, I will show you all later about the data that we have, so that we can make the policy based on the data that we have. And the data, the system that I will be presenting here is that the system that can be real-time and interoperable. I think the two keys issue is real-time, because we need to be quick, reliable, of course, and then interoperable. The data that being read by the local levels, the army or the police or the local governments should be the same with the central government or the president at the same time. And that's the challenge. And we prove it, we can do it. So the reporting acceleration flow of COVID-19 data quality improvement in Indonesia, we started with all data from the Puskesmas, the Dinas Kesehatan, the hospitals, and also the logistics. We want to make sure all of the data inputted into new all record system, which is in the Ministry of Health, that has been improved, although it's not perfect. But then inputted into the BLC, Bersatu Lawan COVID, United Against COVID-19. So basically that's the system, we call it BLC, where all of the data inputted over there, make sure that the variables are the same, and it can be read, accessed by all stakeholders at all levels. As mentioned, central, regional, ministries, government, mayor, so all of that with the same dashboard. So the key, again, real-time, interoperable. Otherwise, our reaction to this COVID-19 will not be concordance with the situation. And of course, for that, we need to have a strong infrastructure, IT infrastructure. And this infrastructure, of course, is not made in Indonesia, and we have to purchase that overseas. but the system that we make is not what you call it, like leasing the space. Basically, we purchase the platform, the cloud platform, and this infrastructure is placed at the BNPB and use the cloud native infrastructure, and then we have the elastic microservices to make sure that the analytics that will be processed over there can be run quickly, smoothly, and can be accessed. And these are the, what you call it, the dashboard that we can use. And with this, at the national level, we know the surveillance, we know the conditions, the provincial level, and also the district level, at all levels. And then, some of the descriptive, not only the number of the cases, but also we started to make the figure of the groups. So let me see if I can, yeah. And then we make the a zonation a zonation map of Indonesia that always be updated every week based on the cases that recorded. So even from the mid of last year, we have used this system, and then each cities and districts in Indonesia can read the situations of their own. And of course, we can also see the trend from time to time to see whether that's an improvement or that the situation is worsening. And with the coordination meeting frequently occurred in a week, we discuss with the local governments, the leaders, whether it's from the civil authorities as well as from the police and also army, to make sure that they understand the data, understand the situations, and then they have to improve the conditions from time to time. Of course, the infection itself is dynamic, so therefore in some weeks they have problems, but in some weeks they can control the situations. And this is the health protocol compliance. We monitor up to now, we have more than 1 billion data stored, and without any delay, So we know everything in the field, and we have the people over there. So the people who are reporting were police and also army, Babinsa, Babin Kamtipmas, and also the behavior change ambassador at the local level. They take pictures, and once they take the pictures and then they report it to us, we know the locations, let alone we know the person. And of course, in one day that when they report, it will be recorded automatically and can be read by their supervisors, whether it's if it's an army, that is from the Koramil, and then the Kodim, and then the Kodam, and then the central government. So all data are really recorded and becoming a dashboard like this. So that's why the higher authority can control the lower authority to make sure that they manage to see the situations. And then we analyzed weekly, and then the data is also provided, of course, to the president frequently. And president really, understand very well about the data of each area in Indonesia. So therefore, when he goes to one area, for example, he always bring the data and then discuss with the local authorities with the data, with the dashboard. So this is the use of the technology and the system, so infrastructure and the system, to make sure that the data can be used not only by the health science persons, but also by officials. And then also with this public transportation data processing, we know the train where where they are coming from time to time. From which station we know, and we can select between times and the destinations and the origins. Also for the airlines, so the people mobility from using train, using the airlines, we know that. So that's why when we control an area, this is based on the data. And even the journalists, we have thousands of journalists, and we want to make sure that they send the news, and we have the list of the news every day from everywhere in Indonesia. So we are monitoring this very closely to make sure that the information from the central government is disseminated to the public, so that when we move to which direction, all of the people are moving in the same directions. So that is the key. And also the volunteers, we have the distributions, and we can contact them directly across Indonesia. And we also have the centralized isolations. When we have the second peak, we want to make sure that all of the isolation facilities in Indonesia, 20,000 beds, we provided within several weeks, ready to make sure that we can support the second wave. So with this type of data, we can see which area that need to be supported with the isolation facility, centralized isolation facility. And in terms of the education, we are working with the Ministry of Education and also Ministry of Health, and also the local governments, the Ministry of Internal Affairs, to make sure that we know where the schools are being open and how the behavior over there, as well as the cases that are being reported. And we started this in June, July last year, when the president came to BNPB and watch and see what we have in terms of the data management in the central command room, and we presented over there. And then the president was very confident, and then asked us to show the public it in the palace, to make sure that everybody understands that the president, when he make a decision of a policy, is based on the data. So this is a good step, proven that data technology is being used, the one data, by the president, and of course all of the authorities. And so basically, one data system, the public health resilience, and public communication. These are the key that how we really manage in controlling the disease. Let me be quick to end this presentations. So the data utilized in the public communications, of course, and then we translate the data into something that is easy to be understood by the public. So therefore, as a spokesperson, I always make sure that the data that I presented in the press conference already edited, already translated into an easy understood message to the public for the journalist. And frequently, the journalists always just copy and paste of the statements that I make. It means that it's easy for them to really understand that, and they don't have to think more. So because the public is easy to understand about the content. And of course, for that, we make the agenda, we set the agenda. So the agenda is not set by the public, it's not set by the groups that put the hopes, etc. We make the agenda. We drive the agenda, we give the information, because we have a wealth of data. The only one that have a wealth of data about COVID-19 is the government. So that's why with this infrastructure and systems, we strongly manage the situations in Indonesia. and with the collaborations, of course, with the pentahelix, with all aspects, stakeholders, and even when we make the policy, now I'm moving to the policy, we have the multi-layered control strategy in terms of policy. We control the transmission between country through the limitations or screening international travelers, also mobility restrictions of the domestic travelers. And also we make the PPKM up to the regency, cities, and micro, the post-command at the village level and kelurahan level. So that's why we really, once the data we have from the local, then it can be analyzed easily. And so what is the lessons learned from the future national disaster management? We want to make sure that we increase the responsiveness because of the data, and then the quick response itself can be utilized for other disasters, not only non-natural disasters, but can be for natural disasters. And of course, people is going to be part of this the journey. Okay, so again, we have to be united against COVID-19, and that's why when the science can be applied more quickly and adaptable to the situations without spending too much time on the debate, discussions, then it will save a lot of lives. If we and there are a lot of issues related to technology. Every institutions, sometimes they don't know each other, that they are doing the same thing. When the government call for innovations, everybody is showing the same thing. So we need to improve in the future how we manage the technology developed by any institutions, including LIPI, and make sure that this is not only a science, can be applied in a very quick way. Otherwise, the policy will move on. For example, the vaccines. Vaccine developments, Merah Putih or Nusantara or others, it takes time to really implement in Indonesia up to a product to be industrialized, because the coordination across sectors are not optimal. So when the government has to choose something, of course, they will purchase from other countries that are ready to protect our nations. If the vaccines, the national vaccines available, of course, we will use that. But it's more than 1 year now. So that's why this is a lessons learned from, for everybody, to make sure that at least from one data that we can show that we utilize the best resources, and all of the systems that I mentioned to you all, it's made by Indonesia. I'm the coordinator for that. Okay, so thank you very much for your attention, and I'm ready for any questions related to this presentations. Thank you very much.
Okay, thank you very much, Professor Wiku, for very nice presentation and for giving us a very elaborate description about the journey for data collection during the pandemic in Indonesia. It is very interesting and very challenging in my opinion. So we still have time, probably around 10 minutes for Q&A. So I would like to invite anyone from the audience, if anyone want to ask Professor Wiku in person, please raise your hand. So yes, we already have one question from Dr. Novlita Idayanti. Please.
Thank you. Thank you, Professor Wiku. Very nice presentation and informative. I have question. Actually, in designing satu data, what is the strategy on applying the system acceptable and operatable by all the institutions in Indonesia involved? And is there any recommendation as a basis for the researcher into developing it? Thank you.
Okay, may I respond directly?
Yes, please.
Okay. Thank you, Dr. Novlita. So again, this is not about science. As I mentioned, and it was also quoted, that we need to have a good communication, collaborations, and coordination. The science itself will not be flying if we cannot communicate the innovations and can be accepted by other institutions. Because when you say one data, every institution will say, I have the one data. If you call to Ministry of Health, they'll say, it's all about one data, we have it. But if we ask them, do you know how many cases now occur in a district, in Nusa Tenggara, for example? They cannot answer it at that moment because the data itself was collected through the aggregate system. It's not an individual data. What we have is an individual data. So we need to communicate to those institutions, not only Ministry of Health, but also Ministry of Internal Affairs and others, that if we don't have this, we cannot react quickly. So that's why even if we act quickly based on the patient data, it's already too late. If you are a virus, if I'm a virus, I can make a problem first and then make a disease. So you will never look at me because what you are chasing is the patient. So that's why we need to inform to other institutions to make sure that we have to have one data. And we are all disrupted by the COVID-19. Once they understood, because of the coordinations, then we ask for collaboration. And then this is not only one shot, this is multiple shots. We make a lot of coordination meetings because this is COVID, so everybody can be invited into Zoom. So we discuss them every week. We probably have more than 4 to 5 days. That's only coordination meetings across sectors with the local governments from the beginning up to now. It's very exhaustive, but that's what we have to invest: communication, coordination, and collaborations. So the science itself, once we agree, has to be able to provide quickly. If it's not, then we will move to other options. So that's the key, basically. Thank you.
Thank you, Professor Wiku. So I guess the answer is communication is the key and also collaboration. So I guess for us researcher, scientific communication is very, very important. Is that answer your question, Dr. Novita?
Yes, thank you, Professor.
Okay, thank you. And before we invite anyone else for the live question, there is one question in the chat that probably still related to the previous question. This question is from Dr. Edi Kurniawan from BRIN. Dear Professor Wiku, that is a very interesting presentation. Thank you. I am interested with the quote that science is not only solution. We still need communication, coordination, and collaboration. So the question is, how do you enforce or practice an effective communication and collaboration among many parties together with the utilization of science and technology to make an immediate action and effective policies within a short amount of time? Thank you.
Okay, thank you, Edi Kurniawan. So let me give another example, which I didn't present that, but about 2 to 3 weeks after the first formation of the task force of the gugus tugas, we were faced with the shortage of personal protective equipment, the APD. And it was surprising at that time how come a textile industry country like Indonesia shortage of PPE. I cannot understand the situations. So I checked again, communication, coordination, collaborations. So I checked one by one. I called the WHO representative in Indonesia. I called the Ministry of Health. I called the Ministry of Industry. I called the universities, the ITB, University of Indonesia, the experts of the infectious disease. I called them all, including the industry itself, the textile industry. My question is whether we have the raw materials to make the PPE, and who made it, which industry, how much. And if we have, who is going to give the approval or permit? And I made only 2 hours meetings, but really with the top leaders, with the DG of those, from the Ministry of Health, Ministry of Industry, and also from the associations of the textile industry. And then I got the answer, really, that we have the polyester, and if all of the polyester made, to be made as a PPE, and it's registered or tested with the ISO, then it can fulfill not only the Indonesian need, but the global needs. 17 million PPE pieces that can be made by the Indonesian industry. It's very silly. How come this country? But I only spent 2 hours, and even with the Balai Besar Tekstil in Bandung, I asked them whether they can check the quality of the PPE if it is made by the Indonesian industry, textile. They said yes, they can. And I asked, okay, I asked the textile industry, do you have the product now in the development? They said yes. And I checked whether the laboratory in the textile industry compared to the government research institutions, including the university, which one is better. Everybody said industry laboratories for the textile is much better than the university laboratories. So, and I asked the BBT, okay, if they send you now, can you test, and how long will you provide the results? They said, well, we need to, we work from home, we cannot test that. But I asked them, do you have the capacity? They said, yes, we have the capacity. Okay, I ask you to start now. If you cannot start now, I will send the army over there to work in your laboratories. This is about humanity. You do it now or not? And they said, okay, we will prepare it. So this is emergency. And I asked if the Balai Besar Tekstil provide the evidence that it's past the standards. I asked the Ministry of Health, I asked the Ministry of Industry, will you give the permit? They said yes. Okay. Next, I asked the WHO Indonesia, if they give the permit and if they give the certification from the laboratory, the government laboratory, would you give support or you endorsement? They said no. How come? If you don't give the support, then I ask you, what can you do? Otherwise, we don't need you. And they said, as long as they meet the criteria that we published, WHO published, international standards, then it's accepted. Okay, I take your words. And then I said, okay, let's decide now which PPE that will be sent to where. And at the same time, at the time where airlines was closed, I asked the Minister of Foreign Affairs, would you help us to send this the PPE to be tested ISO in the United States? And they said yes. And then with the representative at the United States over there, of the Indonesian representative, after several weeks, so the total is one and a half months. Finally, from the first beginning of the meeting, 2 hours meeting, we have that product. You see, is that about technology? Is that about the science? Well, yes, but minimal. More importantly is the permit from the governments to prove with the laboratories and to make sure that it's standardized internationally. And it has to be, we need to make an orchestra across sectors. So that's why I said communication, coordination, and collaborations in action. If you do it now like this, of course, you can solve many issues, including mainstreaming the science and the technology innovations from Indonesia. If you don't do that, you are working on your own silo and no one knows that you have. Or at that moment, we don't know that we have the capacity to produce a PPE. But once only spend 2 hours, not more, we know finally that we can do it ourselves, and then we can wait for that. So that's the key. Thank you.
Okay, thank you very much, Professor Wiku, for sharing your previous experience. I think it's very interesting, and also we can learn a lot from your experience. And we're a bit running out of time, but maybe 2 last questions from Dr. Yusuf Nurwijayanto and Dr. Nasrullah Army, because the question is a bit similar. So the first question by Dr. Yusuf is regarding the vaccination, because now in Indonesia, most of us have Sinovac as a vaccine, and apparently it's not accepted in many countries like Moderna, Pfizer, or others. So is there any recommendation which vaccination will be the most widely accepted in overseas? And also the second question is similar from Dr. Nasrullah and Dr. Yusuf regarding the prediction for the next, for the future. Like, do you have any comments about the third wave of pandemic, and how are we as a citizen should do to prepare or to support the government to face the third wave? Thank you.
Okay, thank you, Yusuf Nur Wijayanto. So basically, the response is the same. If you're talking about which type of vaccines, Moderna, Pfizer, Sinovac, Sinopharm, whatever, Pfizer, communication, coordination, collaborations, but at the global level, at the regional level. If you only discuss about PPE, this is for the interest of the nation, then you talk with the central government and local governments and the industry. But if you're talking about which vaccine that can be accepted to cross the border, of course, you have to talk across countries. So that's the task of the international relations, which is, of course, led by the Ministry of Foreign Affairs, to make sure that we have global health negotiations. So this is part of the diplomacy across countries to make sure that what vaccines being used in Indonesia can be accepted by other countries, and reciprocally that their vaccinations can be also accepted by the Indonesian. So that's why the vaccine travel lane with the Singapore, for example, we cannot only just suggest or propose VTL without having the diplomacy across 2 countries. So that's why if we want to be accepted, whatever we have across nations in the world, of course, we need to make the forum. Don't wait for the forum. You make the forum. We make the forum. And then we ask them to discuss. And of course, in the discussions, negotiations need to be done, and we need to be skillful in negotiating for the national interest. Okay. Second, Pak Nasrullah Armi, about third wave. Don't wait for the third wave. Just prepare, have the disciplines and consistency in 3M, in the behavior, together across countries, across people. If we can do that, there will not be a third wave. So the Christmas and the New Year breaks are an important challenge for us. If we can control the border of the new variant, so of course the quarantine is key, although the temptation is several countries don't apply the quarantine. Indonesia still apply, even only 3 days. But if we are losing that control at the border, the potential like in Europe can be occur in Indonesia. The second is people mobility in the country. So that's why the central government now apply the level 3 PPKM. We want to make sure the people mobility is restricted, reduced, but the economy still running at a level that is safe to COVID. This is the key. If we cannot apply this to limit the people mobility, and we cannot be disciplined in the health protocols, we will harvest the third wave or the explosion of cases in January. And for that, we will suffer from the next G20 meeting. We jeopardize the G20 meeting next year in Bali. So that's really, we work together. We never, up to now, for the long holidays, we never be successful. Always every 2 to 3 weeks after the long holiday, the case increase. Let's prove this time it will not increase the case. Thank you.
Okay, thank you very much, Professor Wiku, and thank you all to everyone who have participated in the discussion. I would like to conclude this session. And thank you very much, Professor Wiku, for your presentation and for coming to the Icramet 2021. We learned a lot from your messages and your presentation. And on behalf of the organizing committee, I would like to express our appreciation for delivering keynote talk at the Icramet 2021. Thank you very much for your time, and we hope to see you again in the future. Please give a round of applause for Professor Wiku. Thank you. So I guess that's a wrap for our first keynote session. Thank you very much for everyone who have attended and participated in this session. I hope you all have enjoyable time during this conference. Thank you very much. And I will return this session back to the MC.
Thanks to Dr. Natalita Maulani Nursam for having moderated such engaging discussions, and also to Associate Professor Dr. Jumril Yunas and Professor Wiku Bakti Bawono Adisasmito, PhD, for their excellent talks. Since we are already behind our schedule, we will have a very brief break. After this, we will invite our patron, Dassault Systems, before commencing the parallel session. Please come back with us again in around 5 minutes. Also, please keep your Zoom account logged on during the break. Thank you.
Next-generation technologies like radar and satellite communication with high data rates call for innovative testing solutions to develop and manufacture RF components, a critical part in the development and design of large communication systems, as well as single RF components for microwave devices like oscillators and amplifiers, is phase noise measurement. This is used to show developers if a signal source noise is as low as it should be. With the launch of the R&S FSPN, Roda & Schwartz is adding a new member to their phase noise analyzer portfolio, enabling increased efficiency and reproducibility of phase noise measurements and VCO characterization from lab to production. The R&S FSPN only takes a few seconds to perform VCO characterization. This not only speeds up the lab processing time, but also multiplies the measurement throughput in VCO manufacturing lines. As the leader in this area, Roda & Schwartz was able to develop the best phase noise and VCO tester on the market, whose pre-configured setup allows easy testing and instantaneous results for the lab, as well as for production applications. The R&S FSPN, unrivaled sensitivity meets high speed. Find more information and learn about phase noise and VCO testing on our website.
"5G is revolutionary. It promises extremely fast communication, ultra-reliable low-latency data links, and support for huge numbers of connected devices. At work, network providers depend on micro-base stations to provide high-capacity coverage through beam steering and massive MIMO. That is, multiple input and multiple output systems. The best route to each device is determined by pilot signals and computations on the base station side of the network. Through virtual prototyping with Simulia electromagnetic simulation, specifically CST Studio Suite, you can ensure the best possible network connections, even in complex environments where a hand or a large object in the street may block the direct signal path. You can also optimize antenna arrays and high-speed circuit performance, as well as ensure safety and critical regulatory compliance. Simulia electromagnetic simulation gives you the ability to simulate complex multipath environments, measure signal strength virtually rather than time-consuming manual measurements, and optimize microcell placement. Taking real-world scenarios into account, clean handoffs between base stations can be ensured with no coverage gaps. Simulia electromagnetic simulation provides efficient end-to-end 5G simulation solutions, allowing you to deliver high-performance designs in a short time frame and at lower costs, without compromising compliance, reliability, and safety. Let the revolution begin.
Thanks for joining with us again. Next, we will have our patron session with Mr. Matthias Meyenhofer from Berdaulat Systems. However, I would like to mention several things regarding the parallel presentation sessions. The three parallel sessions will be conducted in the breakout rooms. Our hosts will first assign presenters who are presenting in the respective session based on the program schedule. For the rest of the participants, you are free to move between rooms by clicking the breakout rooms. Also, some reminders: keep the naming convention according to the guidelines so our host can monitor if any presenters are in the incorrect rooms. We also encourage you to keep logged on even during breaks. For the presenters that are in their assigned sessions, please turn on the video for the whole sessions. Please be reminded it is compulsory for presenters to be present at their respective Q&A sessions. And also do not forget to fill in the attendance form as the presenter when you are in your own sessions. And also for asking questions, please use the raise hand menu that can be accessed from reactions in your application. We also welcome honorable guests and keynote speakers to join our presentation session. For now, before moving into the parallel sessions, first we will have our patron session. Please welcome Mr. Matthias Meyenhofer from Berdaulat System and also Dr. Eri Kurniawan for moderating this session.
Thank you for the introduction. Good morning, all respected keynote speaker, invited guests, all presenter and all participants of 2020 Icramet. In this time, we are going to move to an industrial talk from Berdaulat System. In this session, we have 30 minutes in total that consists of 20 minutes for the presentation, followed by 10 minutes for Q&A. For the audience or participant who want to ask the question directly, you can raise your hand by clicking the reaction button in your Zoom, or you can write your question in the chat box. Okay, the speaker for this session is Mr. Matthias Meyenhofer. He is Simulia Partner Sales Manager of Berdaulat System. If you know CST electromagnetic simulation, SolidWorks, CATIA, Simulia, those are the product from Dassault System. This company is one of the largest software company and develop software for 3D design, product, simulation, or manufacturing. Mr. Matthias Meinhofer holds a bachelor degree in electrical engineering and master degree in industrial technology from Hochschule für Technik Rapperswil in Switzerland. He moved to Singapore in 2016 after completing his master thesis there at Nanyang Technological University. After working as the antenna designer at a large company within the medical device sector, he joined Dassault System Singapore in 2018. Mr. Meinhofer has since been working as a consultant for electromagnetic simulation, leading and supporting engagement across Asia Pacific and South Asia. Okay, I think Mr. Meinhofer have already prepared a very nice and interesting presentation. Please, Mr. Meinhofer, to deliver your talk.
Yeah, thank you very much. Can you hear me?
Yes.
Okay, perfect. I'll just share my screen before we get started. Okay, is it, can you see my screen?
Yes, I can see your screen.
Okay, yeah, then thank you very much again for the introduction, and it's a pleasure to be here. So thank you very much for making this happen, and a big thank you as well to PTNSI. They are our distributor and partner for Indonesia, and thank you so much for helping out on this one. So for today, I have prepared a couple of things. I wanted to show you how we contribute to research and development, not only in Indonesia, of course, everywhere, but Indonesia is also a very important market, and there's a lot of R&D going on, and I would like to show you a couple of things today. Let me just start with a brief introduction about the company for those of you who do not know Dassault Systems. We like to say we're a very scientific company. Everything we do, there's a lot of science involved. We have about 17,000 employees globally, almost 200 offices around the world. We service over 200,000 customers across many different industries, as we are going to see. We have over 12,000 partners. Again, they're everywhere, and they help us to basically service our clients better, provide consulting services, provide technical support for our customers. And then we're very long-term driven. We have a great vision, and our revenue was about 3.4 billion, just to throw a couple of numbers out there to introduce us as a company. We have a couple of headquarters around the world. On the US side, it's in Boston. Then we have one in Paris, in France. And for Asia, it's in Shanghai. But we do have other offices as well. Personally, I'm based in Singapore, and we even have an office in Indonesia, in Jakarta. Just a couple of companies we are working with. Those are some of the references we have. Transportation and mobility is a very big industry. A lot of car companies there that are using our solution, our technology to make their products better. We're in aerospace and defense, high tech. I'm sure you also recognize some of the companies. Everyone has a mobile phone, everyone has a laptop. So all those products have been engineered with this kind of technology. And of course, we also work with smaller companies. Those are very big corporations, but we have a lot of customers, and also the smaller ones, of course, they also need simulation software, this technology to design and improve their products. Just a couple of things. What is our purpose? So basically, we want to harmonize product, nature, and life. We believe we cannot continue to consume products the way we did in the last century. So there needs to be a bit of a change. We also need to look at the environmental impact. And at the same time, I think we should also look at nature itself in order to improve our products. So we can look at a couple of concepts there and then see if we can apply them to our designs. And we believe we have been building this kind of technology with something we call the 3D experience to harmonize all those three things. We started at around 1980 with a very or rather simple 3D design technology. So this was basically to draw the surface of things. Very simple CAD software that allowed you to do some basic modeling. And at the end of the 80s, we introduced the digital mock-up technology. So you can see here an entire airplane that you're able to build up. So with this technology, we took it one step further, and this allowed you to design an entire systems, big and complex systems. And then in 1999, we introduced product lifecycle management technology, basically to give the whole thing another dimension, the dimension of time. And in 2012, we launched the 3D experience platform. And this is really a platform we have built where we try to include all our technology and embed it to create this kind of environment for the innovators to work with. And with this platform, we believe that you can look at emotions and perceptions and so on. So we believe it's a very interesting tool that will help companies to make their products better. In terms of strategy, of course, we want our technology to be easy to use, and it should be easily accessible. For example, on your mobile phone, should be online, and this is what the platform is. And then this is another very important point. We have been working very closely with industry. For example, with all those car companies you have seen, all those high-tech companies you have seen, to basically figure out what do they need to do, right? How do they design their products? What is important to them when they do so? And how can we basically build or change our tools to best suit their needs? And we call this business solutions or business experiences that we have built. And this is basically off-the-shelf workflows and technology we have captured and put into those industry solution experiences that can help businesses to captivate on this knowledge that we have captured, to access all this technology, and to apply it to their work. Just to mention it, there's a lot of brands that we cover. Today, I will be talking a bit more about our simulation brand, which is called Simulia. But there's a lot of other different brands, for example, Geovia, where we have solutions for mining. You see there CATIA, which is our CAD software brand. We have BioVia for biological kinds of simulation. So really a broad simulation portfolio. And again, today we will be talking a bit more about Simulia. All those solutions can be used across many different industries. So we're mainly working with those 11 industries you see out there. Again, the car companies are a very big part of our customer base, but you need those solutions everywhere. And we're also working with home and lifestyle industries. We're working with consumer packaged goods, life sciences, of course, that has become it has been getting more and more important, not only because of COVID as well, but a lot of different industries there where we can apply this technology. So Simulia, this is really our simulation brand, and it allows you to reveal the world we live in. What does this mean? So with this brand, you can get insights into your designs. You can capture knowledge. You can rethink knowledge, and this is really the power we have there of this simulation technology. There's a lot of trends out there nowadays. We have also touched a bit on this in the other presentations we have seen. For example, with 5G, I've recently spoken to a company. They're already talking about 6G and thinking about 7G. There's electric vehicles that we start to see more and more companies start to look into that. We have artificial intelligence. There's 3D printing. So those are all very happening trends right now, but all of them introduce a subset of challenging problems. And in order to address and solve these problems, we need sophisticated technology. So what we have done over time is, again, we started with CATIA to basically build a CAD tool that allows you to draw structures on the surface level. And we have then been fully committed to simulation and continuously built our portfolio. So early 2000, we acquired Abacus, for example, which is our mechanical simulation software. And we then acquired iSight as well, for example, which is an automation software, general automation software and optimization software. There's been SIMPAC for multi-body simulation. In the context of this conference, I'm sure a lot of you have heard of CST, which we have acquired around 2016. And after that, we have also acquired a couple of fluid simulation solutions. So this really shows the commitment that we have to build a holistic and powerful simulation portfolio. And it's much more than just electromagnetics. And this is the platform I mentioned. So this is where we want to bring together all this technology that we have under our simulation portfolio. And you can see the different domains again here. For example, the structural domain, we have electromagnetics, there's fluids, and we bring this together, this multi-domain portfolio on multiple scales as well on our 3D experience platform for businesses and companies to use. And let's look at the portfolio in a bit more detail. Again, there's a couple different solutions here. I just wanted to show you what we have beyond electromagnetics, but I will also show you what we have in electromagnetics. And very importantly, since it's multi-domain, it's also possible to combine those domains. So you could do an electromagnetic simulation and at the same time look at structural performance, for example, if the device heats up, or you could look at a CFD simulation for fluid analysis, for example, how the on some thermal effects, if you have a fan there that's supposed to cool your device. So a couple of interesting things for you, I think. So just briefly, if we look at the structure simulation technology, again, this is technology from Abacus. This is technology from FESafe, which is one of our durability analysis tools. And we have Tosca in there. Tosca is our non-parametric optimization software. So we have put all of this into a portfolio, into a sub-portfolio that allows you to do structural analysis. And you see a couple of applications here, again, very broad, and it allows you to answer questions. For example, how can I improve my design? What if I drop it? Again, here we see a shampoo bottle. Doesn't need to be a shampoo bottle. Can be a mobile phone with a 5G antenna. If you want to see whether it would break, or more importantly, how it would break, how long it will last, whether you can make it lighter, and a lot of other things. For example, certification is always very important. If you want to bring your product to market, you need to pass certain certifications or regulations, and this you can also look into with simulation. So that's one of the things we have. And then I mentioned the fluid simulation technology. So here we also have a couple of different tools. For example, technology from PowerFlow, technology from XFlow, which use a lattice-Boltzmann approach. So that means you don't need to do meshing of the parts, which is the great advantage of those tools. And then we also have Navier-Stokes-based technology, basically the mainstream CFD kind of solution. So again, you see a couple of applications here. We have some aerodynamic simulation going on the top left. We have a simulation of some cooling system. This could be an air conditioning inside an airplane. And recently with COVID, just to mention it, we have also been looking into simulations on what happens if you sneeze, right? What happens if you sneeze in the office? What happens if you cough in the office, right? Where does it go? How does it spread? So this is also has become quite important. And with this technology, we can look into that. Again, it allows you to answer a couple of questions if you're working on cars currently or related to the automotive industry. It would allow you to answer a question, for example, whether or how you could make your design more fuel efficient. Very important also because of the environmental impact. Then how you could reduce noise. So that's also very important for the user experience. If you drive a car, you don't want it to be noisy, or you don't want it to be noisy in a disturbing way. So we also look at noise with those kinds of solutions. For example, the gearbox, we look at lubrication as well to make those parts lasting and run smoothly. Then probably the most important in the context of this conference is our electromagnetic simulation technology. Again, you see a couple of applications here, and here it's mainly CST. Then we have Opera as well. So CST is our high frequency simulation software. And if you purchase it, it comes together with Opera. Opera is a specialized low frequency simulation software. And then we have Antenna Magus as well, which is an antenna template library, another software. And all these make up our electromagnetic simulation portfolio that allow you, for example, to simulate mobile phones here on the top left. How do my antennas perform if I put them into the mobile phones, right? How do they interfere with each other? And so on. On the top right, you see a lightning strike analysis of an airplane. So again, very broad in terms of applications, thanks to the diversity of technology here. You could answer questions such as, will your product meet the technical specifications? Is it power efficient? What kind of material do you have to choose? How about the heating or the thermal performance, which is always very important. Again, will the antennas or components, will they interfere with each other? Or more importantly, how would they interfere with each other? And the last point here is especially important. Does my device comply with regulations out there and with standards? And it needs to, otherwise you cannot bring it to market, right? So an important thing here as well is that more and more of those regulation or certification bodies allow you basically to hand in simulation results instead of actual measurement results to get your product certified. And I think this itself speaks for the accuracy of this kind of software tool. We have other things as well. I'll not touch on them. I'll just touch on them very briefly. For example, SimPack, which is our multi-body simulation technology where you can simulate entire systems. Again, we see the example of a car simulation. We have vibroacoustic simulation. This again is very important when it comes to noise. What kind of noise is generated? Again, for example, if you sit in an airplane or in a car, where does the noise go? How does it spread? For this, we have our Wave 6 technology. Then this is also a very important tool. I will touch on that because you can use it with any other tool, especially CST. This is technology we have from iSight. It's a generic optimization and automation software tool in which you can basically build your own workflows. So let's say your work is to design an antenna. With this tool, you can include a CST simulation, and you can say, I want to run this a couple of times. I want to run an optimization on certain antenna KPIs, and it will allow you to access a lot of optimization methods. It will create for you some results analytics. So very important and powerful tool to make your products as good as possible. Just in terms of takeaway, so there's a lot of physically realistic kind of simulation. It's accurate, it's precise. That's exactly why those certification bodies allow you to hand in simulation results to get your product certified. It's become very, very efficient and high performance, scalable with powerful computer architecture. So this has not always been the case, and there's been a lot of development on this over the last 20 years, but now we are at a level where you can run fairly complex simulation in a rather short amount of time, and they scale excellently if you have GPU cards, if you have a high-performance computing system. The last point here is they're multidisciplinary, multi-scale, and you can combine them the way you want. You can combine a electromagnetic simulation with a fluid simulation, for example. So this has also improved tremendously over time. And then I talked about those industry solution experiences, and I think that's the last topic for today I would like to talk to you about, just to show you what we really have there. So one solution experience we have built with the high-tech industry is the one you see here. So we basically offer solution and technology packages from everything from the initial conceptualization of your design, validation, verification strategy, and so on. Then next, you would look into the sensors and components, the electromagnetic performance of them, where again, we have technology that you can use. You would then go into an electronics design analysis where you take those components and sensors and look at them. Next is the antenna engineering and certification. So this is where you do the actual system integration and simulate the entire device with the antennas, for example. And then the other things, again, structural performance, thermal performance, as well as multidisciplinary trade-off to find the ideal compromise for your product based on certain KPIs that you have established along the design cycle. So if we look at this antenna engineering and certification solution experience in a bit more detail, we have three parts here. One is integrated antenna design. Then we have co-site interference mitigation. So the antennas need to be able to work concurrently. And we have human exposure compliance, which again is the certification aspect and the safety aspect of it. Just a couple of things here for the antenna design itself. Again, we have tools that allow you to directly get the antenna design. So you can tune it and then export it for a CST simulation, for example. And all this will help you to reduce the number of prototypes you need. So you can actually save a lot of time and money by using this in this virtual environment rather than building a large number of prototypes. We have advanced meshing technology. So this allows you to get very accurate results because there's no compromise on how we approximate the geometry. Speaking about the geometry, we have excellent CAD compatibility, so you can import your mechanical files, for example, if you're working with CATIA. And then there's an automation part of it as well. Not only with iSight, the automation tool we have seen, also in CST, there's a couple of things you can automate to really speed up your design and improve your product. Here you see a workflow, just this one slide where we get the antenna from the tool on the left. We then export it to CST. We have designed an array where we do a beam simulation, and we then take it into the mobile phone itself on the right, where we have integrated it for a system level simulation. Then co-site interference, that's the second aspect of it, where we look at how different communication systems interfere with each other. Do they obstruct each other? Is there a problem to be resolved? Where we have a very nice workflow that allows you to get a so-called interference violation matrix, where you would see that, for example, the GPS antenna can work with the Wi-Fi antenna, but the GSM antenna has some issues with the DCS antenna. Things like that you can get out of it, and you then know I need to go back to my design and see how I can fix that. Human exposure, again, this is the last aspect of it, big safety concerns, especially with new technology that we're getting exposed to. Here we have biomodels that you can use for simulation. Again, was quite hard to get them, so we have worked with those certification bodies to make them as realistic as possible. You can pose them, for example, in like you see here, where the person is holding a phone. And yeah, here we look at the specific absorption rate that we try to minimize in order to get our product certified and make the products as safe as possible. Just one more example of this specific absorption rate. You see on the left, specific absorption rate for frequencies below 6 gigahertz. So they penetrate the human head. You see the level of penetration there. Blue is relatively low, weak. Red is high power, basically. And we see that they significantly penetrate the human head, and this shows us the importance of this kind of analysis. Now, on the right-hand side, with 5G, we're talking about much higher frequencies, and they do not penetrate the human head or tissue better to say that, as significantly or as deeply. And there we're also actively working with those certification bodies to see what kinds of new standards could they be launching. Can we look into them with simulation technology as well? So a lot of development that's going on in this particular topic as well. So this was it. I hope you've seen something that you think is interesting. Of course, if you would like to know more, you can always reach out to us or to our partners. And thank you so much again for having me here and for giving me this chance to introduce our company and the products we have. So thanks a lot, and back to the host.
Thank you, Mr. Meinhofer, for the informative presentation. For the audience, if you have a question, you can raise your hand by clicking your reaction button in your Zoom. So because this is limited time, we only have 5 minutes for the Q&A. Any question from the floor? Okay, before the floor can ask the question, may I have one question, Mr. Meinhofer?
Please, yeah, go ahead. Yeah.
As we know, there are so many commercial software available in the global. How about your company positioning in the global market, especially in the electromagnetic simulation? So what is your a special feature that differentiate with the other product?
That's always very difficult to say, right? But we believe that we have one of the best measures out there. So whenever you import a geometry file, the software needs to approximate it before you can run the simulation. And we have actually some patented meshing technology that really allows you to mesh your design as accurately as it gets. And this is something we have patented that no other software company out there has. And we believe that really gives it this final bit of accuracy then that a lot of times is necessary. And then, of course, we also have a lot of very specialized solvers. So you can distinguish between general purpose solvers that you can use for a broad range of applications. But sometimes the certain applications are very niche and require like a very special approach, special kind of solver to solve them efficiently. Otherwise, it just takes too long. And there we also have a wide range. We have over 20 solvers that you can use. And maybe one more advantage, of course, is we have a big industry team in Singapore. So we have over 3 or 4 CSD experts that basically do consulting, that do technical support together with our partner network. And I think in this region, this puts us very close to customers and really helps us to provide them with the support and guidance they need. It's not always easy to use those tools, and this is where we are also always happy to help.
Okay, thank you. One question from Mr. Yuyu Wahyu Brin. How is the error between the simulation and the realization?
Yeah, that's a good question. That's very important, because if the error is large, then simulation or measurement, yeah, there's something wrong there. One thing I can say is that whenever you run a simulation, it's important that you include as many details as possible. So sometimes we, for example, for EMC simulations, sometimes we include the entire chamber, or we definitely include the EMC table. So you need to make the simulation as realistic as possible by including as many details as possible. And then most of the time you will see a reasonably good alignment between measurement and simulation results. And then, of course, there's always a couple of tips and tricks, a couple of things you should be considering that can help you to again get a better overlap or better match between simulation and measurement results.
Okay, thank you. Any question from the audience? Okay, from Mr. Edi Kurniawan. Dear Menhofer, in the community of academicians and researchers, we heard a lot of simulation software such as LabVIEW and MATLAB, which are also having many toolbox for different type of application. Could you please enlighten us the main difference between your software and the other?
Okay, sure. So I don't know all the toolboxes those softwares currently have, but a lot of them are rather high level. So our solution is going much deeper, can do much more complex and detailed analysis, and I think that's one of the main differences. So whenever I see whenever we talk to companies or clients, I have never heard that they have done the kind of simulation you have seen in this presentation with those tools. So we might need to look at what exactly they have and how does it apply. But I would say that our simulation technology goes much beyond what they currently have.
Okay, thank you. One question from Mr. Budi Prawara. From human exposure and safety assessment, is there any tool to simulate long-time exposure to human body? That's the question.
Currently, we don't have that, but I'm sure our R&D has been looking into it. Of course, if we think about it, I would say it's also difficult to simulate it, because you would need to simulate the tissue behavior over a long time as well, and I think that's the challenging part. So currently we don't have that, and I think that's where some more studies and probably research is needed until we can develop those kinds of capability.
Okay, maybe this one is the last question from the audience. From Dwi Sinta, what are the challenges that your company face in this pandemic, or maybe advantage you can get in this pandemic?
Yeah, as we know, the pandemic has been affecting all of us, right? And we're we need to figure a way around that, or we need to figure out a way to work with it. So of course we have also seen that with a lot of our customers, and we've been actively working with them actually throughout the pandemic to see how we can help them, right? And one of the things we have done is we have provided COVID licenses under certain conditions, because a lot of companies had to move to work from home as the new default, and sometimes couldn't access the software in their office. So we found ways around that to basically help and support them. And I think that was also greatly appreciated. And I'm also happy to say that now we see that the situation is getting better and better by the day. And I hope that soon, we can go back to the normal we were used to.
Okay, I think that's enough from the floor. Maybe in the last question from me, Mr. Menhofer, how we contact you in terms of if we have a webinar or technical meeting, or do you have any representative or partner especially in Indonesia?
Yeah, we do. We have, for example, PT-NSI. I think they're in this part of this conference as well. So you may reach out to them, or you may just look up distributors for our software, or then you can always reach out directly to us, to Dassault Systems. Again, in Singapore, we have a big office. So you can always contact us or email me directly, and I would be happy to see what we can, how we can help. Yeah.
Okay, thank you, Mr. Mitterhofen. Okay, finally we reach end of this session. Thank you once again on behalf of 2020 Icramet International Conference on Radar, Antenna, Microwave, Electronic and Telecommunication. We would like to thank and give express token of appreciation to Dassault System as the gold patron in this conference. We hope you can support us in the next future. So as moderator of this session, I will conclude this session. Thank you once again for Mr. Menhofer. Please give applause to Mr. Menhofer. Okay. For the next paper session, the organizing committee will split you all into the breakout room according your presentation schedule. Please stay tuned on the 2020 Icramet, and thank you very much.
Recording in progress.
Stop. Udah. Okay, good morning, ladies and gentlemen. I am Lia Aprilia from Research Center for Electronics and Telecommunication BRIN. Will be taking place as moderator in session paper 3. Today we are going to have 3 presentations in this session. The 3 wonderful presenters in this session will be Mr. Joni Simatupang from Presiden University, Mr. Hana Arisesa from Research Center for Electronic and Telecommunication BRID, Mr. Robert Manurung from Research Center for Electronic and Telecommunication BRID. I think all the presenters are already here. So before we see the first presentation, I'd like to remind you these things. First, for all presenters in this session, please keep your video on until this session finishes. We will have screen capturing session by the end of this session. Second, the time for each presenter is 20 minutes long, so please make sure you are present during your question and answer session. Third, for the participant who would like to ask questions, please use the raise hand function on your Zoom or type in chat. Fourth, also fill out the attendance form during these sessions. Okay, for the first presenters, we would like to invite Mr. Johnny Wellman Simatupang to present his research with the title "MDID Smart Globe Using Ultrasonic and Flame Sensors for Helping Visually Impaired People." Okay, for Mr. Johnny, the floor is yours.
Good morning, ladies and gentlemen. Today we will present our work with the title of Embedded Smart Glove Using Ultrasonic and Flame Sensors for Helping Visually Impaired People. My name is Johnny Wellman Simatupang, and my student is Bintang Ramadan Prasetya. We are both from Presiden University, Cikarang, Indonesia. This is the motivation and purpose of this work. As we know, visually impaired is someone's condition of lacking visual observation due to neurological and physiological factors. And nowadays, fire and coronavirus made the situation worse for especially the visually impaired people. So the helping tool is very needed to overcome these problems. So in this paper, we propose a prototype of an embedded glove using ultrasonic and flame sensors to provide a convenient and safe method for the visually impaired people to overcome difficulties in their daily life. This table 1 shows the related works comparison. We compare our work with some previous researchers done the same work with us in 3 parameters comparison, such as microcontroller, hardware and sensors, and detection, obstacle and fire. So 2 of the researchers previously used Lilliput Uno as microcontroller, but for the rest of us use Arduino Uno. And most of them using the ultrasonic and vibrator, but for us, we use not only ultrasonic, but also flame sensor and SIM 800L for communication. There are 4 main design components in our work. The first one is microcontroller Arduino Uno R3. The second one, ultrasonic and flame sensors. The third one, SIM 800L GSM, and the fourth one, buzzer for alarm. Those 4 main components are assembled and implemented together for making the design of device prototype. In this page, we shows each of the main component design specification. The first one, Arduino Uno R3 module, comprised board of Atmega 328P with IC of 14 digital input and output pins. The second one is ultrasonic sensor. This ultrasonic sensor offers working frequency of up to 40 kilohertz. And this ultrasonic sensor is widely used for the blind because it doesn't affect it by the environmental noise. The third one is KY026 sensor module for flame. This flame sensor module has a distance range up to 100 centimeter. And the working principle of this flame sensor module is to detect the infrared or ultraviolet radiation caused by a fire or came from the burning flames. The fourth one is the module of SIM800L GSM. This is the very popular one used by the engineer or professional. And this SIM800L GSM, not only for sending the message, but also for making and receiving a call, connecting the internet through TCP/IP, GPRS, and many more. Figure 5 shows the block diagram of the full device prototype. There are two buttons, button 1 and button 2, which are connected to the Arduino Uno R3 module as the microcontroller, which are also connected to the ultrasonic sensor and flame sensor, where the flame sensor also connected to the SIM800L for communication. And of course, both ultrasonic sensor and flame sensor are connected to the buzzer for sound notification. This figure 6 shows the schematic diagram of full device prototype of our embedded globe. As we mentioned before, the microcontroller are connected to the ultrasonic and flame sensor, also connected to a buzzer for sounding alarm, and also the ultrasonic sensor and flame sensor connected to the buzzer. And the flame sensor here is connected to the SIM1800L for communication. Those are connected in the white breadboard. This figure 7 shows the flowchart of the smart globe mechanism. There are two active modes. The first active mode is for the push button 1. When the push button 1 is activated, the ultrasonic sensor will immediately work to send the signal to any obstacle. So where there are any obstacles, then the ultrasonic will receive a reflected signal at receiver, which was sent before by the transmitter. And of course, the ultrasonic sensor is connected to Arduino and buzzer, and the buzzer will give the sound notification when the ultrasonic sensor detects the obstacle. When the push button 2 is activated, then the flame sensor and SIM800L were also activated, and they are both are connected to Arduino as intermediary. So this mode 2 activated where there is a fire or flame burning papers, for example. So then the flame sensor will detect the fire and send the message to the through the SIM800L to the family for notification, and also sounds the buzzer. This figure 8 shows the front view of the full device prototype, which is ready to be tested. And figure 9 shows the placement of flame sensor and SIM800L module. So flame sensor was put inside the wood box here, and SIM800L was placed outside the wood box because it will be easier for the sensor to find the signal for communication. Actually, this arrangement due to the drawback of our prototype, because we used the wood box for making the components, wrapping the components in one place. We did some experimental tests. We put the prototype on hand, and then the prototype will sense the obstacle near the prototype, and will work the buzzer. Will work the buzzer to give the sound for the impaired people. And also we do some experimental testing to detect the small fire using the matches, and also through the burning flames paper for detecting the big fire. Usually the small fire, we got the distance about 15 centimeter, and the big fire, we got the distance about 20 centimeter far from the prototype. The experimental results when using the prototype and acrylics, the wood box, and also when put on hand. So when put on the wood box or acrylics at 50 and 60 centimeter distance, was not able to make the ultrasonic detect an obstacle. However, when the box is brought near, the ultrasonic and buzzer immediately detect and emit a sound, respectively. We see that for the distance of 40, 30, 20, and 10 centimeter, both. As a brief summary of our simple work, we already shows that the embedded smart glove detection prototype has been successfully implemented and tested in our research. And when mode 1 is active, ultrasonic sensor will detect the obstacle and range, and will give the tone through alarm buzzer. But when the mode 2 is active, the flame sensor and SIM 800L will be activated to detect the fire, small fire and big fire, and sending a message to the family for notification. For the future works, we can change the main box from wood to be acrylic, as we mentioned before, to reduce the device prototype weight, or to make it light when we'll be wearing it on hand, to make it easy to be used. And also we can use IoT for activating another function like GPS tracker to find out the person's position, whether they are at home or outside the house, by sending map coordinates. Thank you for your attention, and we will welcome comments or any feedback or questions from the audience. Again, thank you so much.
Okay, thank you very much for the interesting presentations. Now let's continue to the session's question and answers. Is there any question from the audience? Okay, maybe the first question from me. From your presentations, I see the size of the flame is like a small and bigger size. If the sensor can detect the smaller size of the fire, does it mean the sensor is sensitive?
Thank you, Dr. Leah, for the question. Actually, we can say it is sensitive in the working range, Dr. Leah. So, as we mentioned before, that the detection range for the small fire using matches, we got average in 15 centimeter distance. 15 centimeter distance. While for the bigger one, a little bit further. It's about 20 centimeter. That's from our simple experimental testing. Yes.
Thank you. And how to increase the coverage distance? Which part should be optimized?
Yeah, actually, it depends on the ability of the KY026 module sensor for the flame, because it was mentioned before in our main component specification that actually the distance range up to 100 centimeter afar. But in this case, we only can detect for 20 centimeters, the maximum. So because we bought the cheaper one of the expensive one, yeah, because this is due to the final project of my student. Yeah, that's Dr. Leah. Thank you.
Okay, thank you very much for the answers. So for the audience, is there any question?
I think I have one question. Thank you for your interesting presentation, but I'm sorry if I missed. Have you implemented this application to the real condition, and what is their suggest about this, about your application?
Condition. Thank you, Mr. Hana, for the question. You mean the real condition, like we use the prototype directly on hand?
Yes, yes. In real condition, in maybe in road and everywhere.
Yeah, no. Yeah, that's the drawback of our experiment. We only use at home. We only use at home, not outside the home.
Do you have any consideration about that, or maybe have a difficulty about that? Why you not yet implemented in real situation?
Yeah, because if you see in our last summary, we give the recommendation for using IoT, right? Yeah, because in the at home we only use the communication using the in this prototype we only use SIM 800L GSM for communication, if you know that. So we cannot use that for outside range, for the farther range. For small range, just like 2 to 400 centimeter.
Do you have any? Thank you. But do you have any suggest if you want to extend this application to the real condition?
I think we can do, but we need we need to work again to make the glove become more light, easy to be used on hand, and then we can bring it outside home, because now we only use a wood box. Yeah, a wood box. That's the drawback of this experimental.
Yes, I see. Thank you very much.
Thank you, Mr. Hana.
Okay, Mr. Hana, did it answer your question?
Yes. Thank you.
Okay, thank you very much. Is there any questions from the audience? Okay, if there's no other questions, let's give a big applause to Mr. Johnny Welman Simatupang. Thank you very much. Now, okay, we invite to the second presenters. We would like to invite Mr. Hana Arisesa to present his research with the title Far UVC Beam Propagation Characterization in Air Medium for Human-Friendly Virus Sterilizations. Okay, Mr. Hana, the floor is yours.
Hi, good morning, everybody. I am Hanare Sesa from National Agency of Research and Innovation, RIN. Today, I would like to present my study during this pandemic condition on the title of for UVC beam propagations characterization in a medium for human-friendly virus sterilizations. This is my outline today. First, in the background, I will describe about the pandemic condition in Indonesia in general. Next, I will talk about the COVID-19 preventions, including the COVID-19 timeline in Indonesia, and some prevention methods that are implemented. Then I will discuss about UVC radiations. What is UVC radiations, its benefit and disadvantages, and why is it used in this study? Later, I will show you my measurement setup and the discussion, and the last in my presentation I will sum up my presentation in conclusion. This is a COVID-19 timeline. At the end of December 2019, the China alert WHO to several cases of pneumonia with no known cause in the Wuhan. And then in the January 7, 2020, WHO official announced that they have identified a new virus named SARS-CoV-2 that caused COVID-19. And later, on the January 11th, China announced the first death linked to COVID-19. Meanwhile, for Indonesia, first and second case suspect COVID-19 announced in the February 2020. Until on the March 2, Indonesian government officially announced there was a COVID-19 in Indonesia. In March 11, a first death due to the COVID-19 occurred. After that, from September 2020 until right now, Indonesian government implemented large-scale social activity restrictions and also enforcement of community activity restrictions from level 1 and level 12, extended by level 1 and 4 until now. The important event that the vaccine program started on the January 13, 2021. This is a recent report on the daily cases in Indonesia. Right now, the number of cases is very low. However, we experienced about 1.5 years had the pandemic conditions. This during 1.5 year conditions, many activities stopped. Only important activities allowed to suppress and prevent the COVID-19 infection. So we did solutions to. Meanwhile, we doing activity, we can protect and we can minimize the COVID-19 infections. This is a coronavirus COVID-19 transmission and infections. Basically, there are two points here. First, the COVID-19 is suspected because of a droplet contain a virus in the air. So airborne transmission is very important here. And the second, that if the droplet fall on the surface or object and touched by hand, it could be possible goes to nose and mouth, and then we can get the COVID-19 symptom. So how to prevent and to protect droplet airborne transmission is very important during the pandemic situation. So this is some prevention method issued by Ministry of Health. Some activities that are prohibited is like activity that can bring the COVID-19 infections. So one of prevention method is cleaning by disinfectant to clean the stuff and object every day. However, this after that, this activity is banned due to the health issue. At that time, it was disinfectant spray. It was installed in everywhere, such as in train stations, in the airport, main road, and the building. However, due to the safety and health to the human, it was banned after that. So we need more solutions to do a disinfectant process. This is a UVC spectrum. Basically, there are three kinds of UVC. First is UVA that has a longer wavelength that can penetrate the middle layer of our skin. And then UVB rays that have a short wavelength that reach other layer of our skin. And the last is UVC radiations that usually from sun that doesn't reach in the Earth's surface because it's blocked by the ozone layer in the atmosphere. However, recent report that UVC has a long history to use a disinfectant sterilization process. So the one and the only one to produce UVC is from artificial lamp or laser. This is for UVC radiations. Basically, there are two kinds of UVC. First one is conventional UVC, and the second one is far UVC. Conventional UVC usually use a 245 nanometer and has a long history to use it for germ sterilizations. However, recent report that far UVC and the wavelength 222 nanometer has a prospect to use for human sterilization because it's less harmful than conventional UVC at 245 nanometer. This is a UVC irradiation report. In 2007, Walker used a UVC 245 nanometer to make it in the target of fungi, bacteria, and virus. And also W.G. Kowalski in 2009 also used a 245 nanometer, but the target is virus. Recent report, Rubio Remoro et al. In 2020 used a 245 nanometer for target virus. However, the recent report started in 2080 from that all use a far UVC wavelength 220 nanometer for target Staphylococcus bacteria, and then continue by Buan Nando et al. 222 nanometer for some virus, including virus caused influenza A, H1N1. And the last is Kitagawa H et al. And 2021 use 222 nanometer for SARS-CoV-2 study. So the key factor for UVC sterilization is three things. First is exposure time, the intensity and dosage. From the Kitagawa report that the dosage 3 millijoule per centimeter square is enough for 99.7% efficacious. And other report use 1.7 millijoule per centimeter square or 1.2 millijoule per centimeter square. This is my setup measurement. I use a UVC lamp source to generate 20 to 122 nanometer, and I use a sensor HP350 UV irradiance colorimeter to retrieve the irradiation of the far UVC. This lamp is constructed in some house and module, and there are some reflection material here to get the optimum irradiations. We also measure a vertical angle measurement and horizontal measurement angle to calculate the optimum room that can be accounted to sterilization chamber. This is the result of discussions. This is a spectrum measurement. The peak of far UVC in 218.7 nanometer, and then we measure a line of sight measurement for variation of distance. The highest irradiation at the zero position, around 4,242 microwatt per centimeter square. However, this irradiation is exponentially decreased respected to the distance from the source. Then we also measured the vertical and horizontal angle. The measurement distance is 100 centimeter or 1 meter. The sensor placement in the center of the lab. We saw that until the angle 45 degrees, the average of irradiation is same, about 140 for a vertical angle and 147 for horizontal measurement. So based on that measurement, we calculate the time, the minimum exposure time to implement in the two-dimensional room. The formula to calculate exposure time is minimum dosage is divided by irradiance. So in the case that lamp installed in the ceiling, only use one lamp, and horizontal and vertical angle used for calculation is 90 degrees and no blocking object. So we can calculate the contour of minimum time exposure. At the 50 centimeter, the exposure time is about 8 seconds, and until the 3 meter, the exposure time at least is 150 seconds. So this is my conclusion: is the characteristic of far UVC beam propagation that I have was report. The far UVC beam has a radiation loss exponentially in the free space medium. The beam radiation angle of about 100 degrees for vertical and 120 degrees for horizontal. It can be used for further design of sterilization using the far UVC examiner to achieve effective and efficient installation and operation. And this is the end of my presentation. Thank you, and thank you your attention.
Okay, thank you very much, Mr. Hana Arisesa, for your nice presentations. Now let's continue to Q&A sessions. So is there any questions from the audience?
May I ask question, Dr. Lia?
Yes, please, Mr. Joni Simatupang.
Yeah, interesting. Thank you for Pak Hana, ya, Mr. Hana. I wrote, there are two questions if I can mention here. The first one, yeah, actually what kind of parameters you are characterized and why are they important in your research, Pak Hana?
Okay. Thank you for your question. Firstly, that as we know that UVC is, according to the report, is harmful for human. So we make sure that this alarm source doesn't contain any UVC spectrum. So we just only focus on far UVC, that is a 222 nanometer first, and doesn't contain any UVC spectrum like UVA or UVB. So we need to make sure spectrum measurement of this lamp. This first, and the second is, as I mentioned before, that we characterize the degradation of irradiation. So we do not have any propagation model right now about the characterization of far UVC propagation model. So we need to measure this in real situation. So we have exponentially degradation of this UVC. So we need to consider this value to make this lamp in real situation or real implementation. So, and the third, maybe I would add this information that we need to optimize the irradiation of far UVC. So we need to make a design of UVC lamp or enclosure or maybe module that can give our optimum irradiation. So we need some adding extra material, reflective material or something like that. So we get the optimal irradiation. I think that's three things that we need to consider about this study.
Okay. Can I ask one more question?
Yes, please.
Yeah, I ever want to research this part. Actually, when I heard one of the doctor in the beginning of the COVID-19 last year mentioning about the time slot that is better for our to increase our body health, yeah, to increase our body health in terms of when we go outside to get the sunlight radiation.
Okay.
So in your experience, I don't know if this is quite related, but in your experience when doing this research,
yes.
in which slot time is the best one for us to increase our immune body system when we go outside to get the sunbath, in the morning or in the daytime or in evening?
Thank you. Very interesting question, I think. However, yes, in the study, firstly, academically, that far UVC or maybe UVC, it doesn't reach our Earth surface. That's academically and widely reported in some academic report. But during this study, we also measure the sun irradiations using the some tool, some measurements, calorimeter, spectrometer. In conclusions, day for day measurement from morning until maybe afternoon. We measure a sun irradiation, and we record the value of UVC and UVA and UVB, because this tool can record from 20 nanometer until 200 until 400 nanometer. So it's contain UVC and UVB and UVA. The result is we got some UVC, UVB, and UVA irradiation, but for UVC is very small enough to make significantly high for our health. But as I said before, and that the effective irradiation is contained to the time exposure. First, if significantly small of portion of UVC or far UVC we get in human body, I think is enough. That is contained in sun irradiation spectrum. But don't forget that sun irradiation is also contained UVB and UVA. So this is trade-off. So what time the best? I cannot make sure that this hour and this hour, because we need more study, and we need more research about this, so we can give the conclusion that not harmful for human body. I think this, but in this is I think it's the interesting research and very interesting questions.
Thank you, Pak Hana. Thank you.
Okay, thank you, Mr. Hana. Did it answer your question, Ms. Joni? Did it answer your question?
Yes, yes, already, Dr. Lia. Yeah.
Okay.
Yeah, thank you.
Thank you very much. Is there any question? Maybe one question more from the audience. If there's no questions, I have one question, Mr. Hana.
Yes, please.
My question is, I'm still not clear. Why did you measure the vertical and horizontal irradiations? Is there any consideration or effect for your further application?
Yes. Okay. Yeah. Thank you very much. This about horizontal and vertical measurement. Why horizontal and measurement is important? That's why, as you know, that this lamp have a reflection and they have enclosure with which length and the height is different. No, so this is not symmetry enclosure. So if we want to calculate the exposure time, we need some homogeneous ring. That in that ring we make sure that there is irradiation is generally homogeneous. So we need, due to this is implemented to the two-dimensional room, so we need the uncertainty of inhomogeneity of irradiations should be eliminated. So although we measure that in 0 degree until maybe 19 degree, there are some portion of UVC irradiations, but we need to make sure in which degree that the irradiation is homogeneous. So we, based on this value, we calculate the optimum irradiation, so we can guarantee, or maybe we want to make certainty to the audience that in this area the irradiation is homogeneous, not variation irradiation. So we eliminate the inhomogeneity in our calculation for exposure time. I think that's for my answer.
Okay, thank you very much for your answers. Okay, let's give a big applause for Mr. Hana Arisesa. Thank you very much, Mr. Hana. So for the last presenter in this sessions, we would like to invite Mr. Robert Victoria Manurung to present his research with the title Design and Fabrication Pasteurization of Fresh Milk based on pulse electric field technology. Okay, for Mr. Robert Victoria Manurung, the floor is yours.
Good day, everyone. Today, I would like to present our paper. So please allow me to share the screen. So the title with the design and fabrication pasteurization of first milk based on the pulse electric field technology. My name is Robert Victoria Manurung, and I'm from Research Center for Electronic and Telecommunication. So our presentation consists of five-part: introduction, methodology, result and discussion, conclusion, and Q&A. So the food processing recently has raised attention. Is because of some particular reason, such as extend shelf life, maintain sensory properties, maintain nutritive properties, ensure safety, make more convenient, and also economic value. For the food processing, we have two main approach. First, the thermal, and the other is
Recording in progress. Recording in progress.
pulse electric field. So this technology has been chosen by us to develop the system. So what is a pulse electric field? It is actually use a short electric pulse to preserve the food. So the treatment is a very innovative and promising method for the non-thermal processing of the foodstuff. It is one of the most appealing technology due to the short treatment time, typically below 1 second, reduced heating effect, energy loss during heating food is minimized, the fresh-like characteristic of food, along with the high sensorial quality and nutrient content. This technology is switchable for preserving liquid and semi-liquid food, removing microorganisms and producing a functional constituent. For example, milk, fruit, juice, soup, egg, and etc. So PF technology actually is based on the pulsing power delivered to the food product, placed between a set electrode confining and the treatment chamber by the applying for the treatment gap. The equipment, it consists of high voltage pulse generator, treatment chamber with the switchable food handling system, and also monitoring and controlling device. So in this technique, food product is placed in the treatment chamber, either a static or continuous design, where two electrodes are connected together with a non-conductive material to avoid electrical flow from one to another. So by generating high voltage electric pulse, then conduct the highest intensity electric pulse to the product placed between the two electrodes. So the food product actually experiences a force per unit charge. So what we call as an electric field, which is responsible for the irreversible cell membrane breakdown in microorganisms. So what the aim of this research, developing a non-thermal food processing by design and fabrication of the PEF system. The system consists of a high voltage pulse generator, treatment chamber, agitator or mixer, and also control. The prototype has been applied for milk pasteurization and to support traditional milk industry, especially in South Bandung, West Java. For the methodology, we start with the design of the system and implement it one by one of each the subsystem. As we can see here, for the schematic design of the PEF system, at least around 5 parts consists of the system. First, the treatment chamber, where we put the milk, in this case, as a food product inside the treatment chamber. The treatment chamber also equipped with the heater belt. And then we also put the agitator inside the treatment chamber to mix the milk is very constantly and make a very uniform. And then we have a pulse generator based on the flyback transformer. And during the process, we can monitor the temperature inside the treatment chamber. Then all the process we can control and we can monitor on the display. So for the high voltage pulse generator, this consists of 2 main parts. First, a pulse width modulator. We employ the IC 555. So this will be generated the pulse, and then after that we can amplify from 1 volt become, or at least 1 volt become a high voltage by the flyback transformer. So the total output on this generator we can will be produced around 20 up to 70 kV. So this is the realization, the fabricated high voltage pulse generator that we successfully fabricated, and then this is also the power circuit. We measure and characterize the circuit, and for the part A, this is clearly show that the PWM is generated a pulse, and then for the output we can get a high voltage pulse electric is around 61 kV. After that, we also design and implemented the treatment chamber. So the chamber is a cylindric shape and made by a food grade stainless steel SU303 with a 70 height and the diameter around 20 centimeter and 1.5 millimeter the thickness. So the chamber also equipped with the, as we can see here, the heater around the body and also the electrode, anode, and also cathode. And also we put the agitator or mixer inside the treatment chamber to mix the milk constantly during the process. So as the result, we can see here, this is the total system that we already fabricated. So this is the PEF system, the prototype of the PEF system. And on the prototype, we can see here display and control panel, and also the output part. So during the process, we can calculate the electric field has been applied for the milk as a food product during the process. So after that, we can implement our machine to the real sample. So we join together with the KPBS, is the very well-known milk industry in South Bandung, and we get the sample from them, and then we treat the sample with our PEF system. We employ several different time treatment, and then we evaluate the TPC, or the total plate count. It is the number or microorganism is still inside the sample of milk. So for the result, we can see here that first we apply at least 5 samples with the different time of treatment. First, the control. We not treat at all the sample of milk with our pulse electric field. And then the second sample is 5 seconds. We inject the high pulse electric field, and then 10 seconds, 20 seconds, and then 60 seconds. So we can see from the table that for the TBC, for the control, we get nearly 1.8 million CPU per mil. This is the number of the TBC for the control. After we treatment with 5 seconds, it will be decreased around 90, 100 CPU per mil, and then 10 seconds, 720,000 CPU per mil, and then 20 seconds is around 390,000, and then lastly for the 60 seconds we get 350,000 CPU per mil. So it's mean we can get here that the 20 seconds, this is the optimized time of treatment for our prototype, which means the total plate count for the 20 seconds and the 60 seconds, it's not much different. So by this data, we can plot the graph, and then we can get it's around 80% successfully to inactivate microbial. With the electric field around 5.5 kV per centimeter. So we make a variation for the time of treatment, and then we can get is around 80% that we successfully to inactivate the microorganism. Then after that, we try to evaluate also the nutrient content for the milk itself. So again, we apply for the different sample, first the control, and then 20 seconds, 30 seconds, and then 40 seconds, we inject the pulse electric field. Then we evaluate for some the parameter for to represent the nutrition itself, so for the fat, protein, lactose, total solid, and water content. So the data shows that the number of each parameter not different much. Even we apply for the longest time, 40 seconds. So the 20 seconds, this is our optimum time. And we can see here, it's not much different. So it means that the pulse electric field as a non-thermal or processing food is well proven that it's not make some changes of the nutrients content. It's not degradable significantly, but it's very little effect during the process for the nutrient content. After that, for the 20-second sample, we try to test the storage of time. So it means we have the 3 samples with the 20-second inject of the high pulse electric field, and the first one in that day and on the same day, we also we calculate the TPC and we get around 1.7 million CPU per mil, and then we keep that for the 5 days for another sample, and then during the 5 days we calculate the TPC and we get the 17 million CPU per mil. So it means it's increased 10 times, and then for the 10-day sample we get the 30 million CPU per mil. So again, we can see here by the employing the PEF technique, so we can keep at least for the 5 days, this only increased 10 times. Without the PEF technique, without the non-thermal processing food process, the milk will be degradable right away on the same day. So it means without any treatment, the milk is very easily to broken or spoil. So for the conclusion, the design and fabrication of pulse electric field pasteurization is successfully conducted. The electric field on per centimeter inside the treatment chamber we measure is around 1.5 kV per centimeter. So by this this number of electric field, we can get the optimum time of treatment is around 20 seconds. So the prototype has been successfully applied on the real sample, and we get the data show that is have the effectiveness to inactivate microorganism is 80%. So for the future work,
as you mentioned in your presentation, you use calculate or you measure the microorganisms or microbacteria or something like that. I'm sorry. What kind of these microorganisms? Indeed, that is a harmful microorganism or harmless microorganism? Thank you.
Yeah, thank you very much, Mr. Hana, for the question. It's a very interesting question. So I would like to address for your first question. For the health matter of the sample, especially for the milk using this technology, for your information, actually this technology has been very mature in the Europe countries. Yeah, not only for milk, but only for the but also for another like fruit, potatoes, and liquid food. So it's mean there are so many commercial product on this. So you can get that if some product is available and commercially. So it's mean this is by already have been characterized, testing, including health issue on the health department for the license. So of course, this is very well-known food processing has been applied in the advanced countries such as Europe. So I think health issue is not significant at all for this one. So for the second question, yeah, this is very good question. Actually, this is the drawback. One of the drawback of this technology. We cannot select between the harmless or the harm microorganism. We cannot select the bacteria. So this is directly destroy all kind of the bacteria, good one or the bad one. So yes, this one is one of the drawback of this technology. I think that's my answer. Thank you.
Yeah, thank you. Thank you.
May I ask Dr. Lia?
Yes, please, Mr. Joni.
Yeah, thank you, Dr. Robert Manurung. Very great presentation and very real, yeah. And it's important for us. But as a electrical engineering lecturer, I'm interested in the last part of the conclusion. Yeah, the second conclusion, Dr. Robert. Would you like to explain again why you make as a conclusion about the electric field strength compared to the optimum time that you mentioned about 20 seconds. And if I expand one more question related to that, so what actually the target for each of the parameters for the fat, protein, and also the lactose to make it, as you mentioned, the optimum condition for each of them? Thank you.
Yeah. Okay. Thank you very much, Dr. Johnny Lemar. Okay, so it's nice to see you again. Yeah. I know that you are the expert for this. Why I point out as two factors here, because the electric field is very important regarding to the energy has been applied to the cell membrane. Yes. We use a commercial flyback transformer. So we cannot control and tune the energy will be applied on that sample. So that's why we are using a distance between one electrode to another. So now, by the literature, is for the energy is around 1.5 kV per centimeter. Is the optimum to make the cell membrane break down, to make a tiny hole on the cell membrane and make a water is come out. So the starch will be not come out. So the freshness is still maintained and the nutrition still maintained. However, for some research has been shown that some enzyme has been broken in there. Nobody is perfect, even the technology itself. So why I choose also time treatment, because this is our first prototype. So we cannot control the pulse number, the width of pulse, because this is regarding with the energy. And then also because this technology, we would like to address to the farmer. So the very they don't know anything about the technology, just know how to operate with the time. So we try to make simplify so easy to use for the farmer. So that's why we focus to just optimize the time. So in the field, it's very make it easier for them to use. I think this is our preliminary data and our preliminary prototype. For the future work, perhaps we want to collaborate with the industry and we make some sophisticated version for this. I think that's my answer. Thank you.
So the shorter time treatment will be the better.
Right. Correct.
Okay. And how about the hole? Is there any indication of the radius of the hole to the result of the final result of your measurement?
The hole? What's you mean the hole?
You use the cell membrane, right? The cell membrane you mentioned about there's a small hole, right? You mentioned. Yeah. So I mean, is it any indication about the radius of the hole to the result of the final result of your measurement?
We not yet evaluate about that. So because this is the cell dimension, so it's need a further research for that. I'm so sorry, I cannot answer about that. Thank you.
Dr. Robert, yeah.
Okay, thank you very much for Mr. Robert. Because time is up, so let's give a big applause to Mr. Robert Manurung. We will end these sessions. We would like to thank all the presenters for all your nice presentations and all the participants for your participations. For the last, we have camera session. So please open your camera. We will take the pictures. 1, 2. Okay. 1, 2, 3. Okay. Thank you very much for attending these sessions. So don't forget, for the next presentation will be started at 1 p.m. GMT +7. So please have lunch. Thank you very much.
Thank you.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development agency. Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by various research institutes, and have more than 70 research centers and supporting units. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Jurnal Elektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as the OAJ, Google Scholar, Mandiri, and etc. JET is also ranked as Center 2 in Kemenristek Green accreditation system. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge, and therefore, no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
Imagine that you are responsible for designing a modular GPS smartwatch. With each segment of the strap containing a different electronic module, there are hundreds of possible configuration alternatives. How do you identify challenges with connectivity, signal integrity, and electromagnetic interference early on? With electromagnetic simulation technology, you can not only analyze individual modules, but also the entire product assembly. Here, the antenna sensitivity of the smartwatch is shown with the strongest signal directions shown in red. This allows you to evaluate your product connectivity performance in all possible configurations early on. Human proximity effects can also be analyzed, enabling designers to verify not only connectivity when the watch is worn, but also ensuring that it meets regulatory compliance and electromagnetic safety standards. In this case, you discover that the antenna becomes detuned when not worn on a user's wrist, causing the connectivity to degrade. With electromagnetic simulation technology, you are able to redesign the module's antenna to work on and off the wrist and verify the quality improvement. Now that you have considered electromagnetic challenges, what about considering structural ones? By also performing detailed structural simulations, you can assess the reliability of the watch. This includes advanced simulations such as drop testing and other harsh loading conditions for detailed evaluation of the watch's structural and functional integrity. Another critical component of the smartwatch is the touchscreen. Simulating pressure-based sensing requires coupling between the electrical and structural simulations to ensure the screen is sensitive, but not too sensitive. Soon, touchscreens will provide haptic feedback. Electro-activated polymers, which deform with electrical input, can provide tactile feedback to your hand as you interact with this screen. Imagine a feelable button click. We feel that coupled electrical structural simulation will play a key role in evolving flexible electronic design, enabling the development of future products that will provide extraordinary experiences to consumers.
Next-generation technologies like radar and satellite communication with high data rates call for innovative testing solutions to develop and manufacture RF components. A critical part in the development and design of large communication systems, as well as single RF components for microwave devices like oscillators and amplifiers, is phase noise measurement. This is used to show developers if a signal source noise is as low as it should be. With the launch of the R&S FSPN, Rhoda & Schwartz is adding a new member to their phase noise analyzer portfolio, enabling increased efficiency and reproducibility of phase noise measurements and VCO characterization from lab to production. The R&S FSPN only takes a few seconds to perform VCO characterization. This not only speeds up the lab processing time, but also multiplies the measurement throughput in VCO manufacturing lines. As the leader in this area, Rhoda & Schwartz was able to develop the best phase noise and VCO tester on the market, whose pre-configured setup allows easy testing and instantaneous results for the lab, as well as for production applications. The R&S FSPN, unrivaled sensitivity meets high speed. Find more information and learn about phase noise and VCO testing on our website.
Penggunaan sinar radiasi ultraviolet C atau UVC merupakan salah satu metode dalam sterilisasi. Sinar radiasi UVC dipercaya dapat melengkungkan struktur materi genetik virus dan mencegahnya berkembang. Pusat Penelitian Elektronika dan Telekomunikasi LIPI telah mengembangkan alat sterilisasi ruangan portable berbasis sinar UVC. Sisusan atau Simple Smart UVC Sanitizer memanfaatkan sinar UVC yang dikendalikan secara cerdas. Sisusan memancarkan sinar UVC yang menyinari langsung permukaan benda di ruangan atau kabin.
Seperti kita ketahui, sinar UVC adalah mempunyai kemampuan untuk melemahkan mikroorganisme, termasuk diantaranya adalah bakteri, virus, pada suatu permukaan benda dan di suatu ruangan. Sisusan dapat digunakan untuk menghambat penyebaran COVID-19.
Parameter penyinaran dapat diatur melalui aplikasi Android, seperti lama penyinaran sesuai dengan luasan ruangan dan jenis virus atau bakteri yang akan dibasmi. Penjadwalan penyinaran dilengkapi sensor keamanan dari aktivitas manusia. Sisusan didesain dengan sangat sederhana, portable, dan murah sehingga dapat digunakan di rumah tangga, klinik atau puskesmas, sekolah, kantor, dan lain-lain.
Saat ini, kebutuhan magnet permanen di Indonesia relatif tinggi. Magnet permanen adalah magnet yang memiliki sifat kemagnetan yang lama dan tetap sehingga sukar untuk dihilangkan. Magnet permanen banyak dimanfaatkan pengaplikasiannya oleh industri dan UKM pada berbagai komponen elektronika. Namun, tahukah kamu, sebagian besar kebutuhan magnet permanen di Indonesia masih diimpor dari negara lain, seperti Cina, Jepang, dan Amerika. Salah satu magnet permanen yang cukup banyak digunakan adalah magnet barium ferit. Magnet barium ferit, atau yang sering dikenal juga dengan sebutan magnet keramik, adalah magnet permanen dengan rumus BaFe12O19 yang terbuat dari bahan baku utama oksida besi dengan teknologi serbuk. Untuk meningkatkan kekuatan magnet barium ferit, Pusat Penelitian Elektronika dan Telekomunikasi Lembaga Ilmu Pengetahuan Indonesia di Bandung telah menemukan sebuah invensi berupa magnet bonded hybrid. Apa itu magnet bonded hybrid? Magnet bonded hybrid merupakan penggabungan dari magnet barium ferit dan magnet neodymium iron boron (NdFeB) dengan menggunakan teknologi hot press bernomor paten P00201407033. Keunggulan dari invensi ini adalah harga lebih murah bila dibandingkan dengan produk impor. Jumlah, bentuk, dan spesifikasi dapat dibuat sesuai kebutuhan pengguna. Keunggulan lain dari invensi ini adalah menggunakan produk lokal limbah oksida besi, temperatur Curie, dan ketahanan korosinya lebih tinggi dibanding magnet NdFeB, serta kekuatan magnetnya lebih tinggi bila dibandingkan dengan magnet barium ferit. Saat ini, pembuatan invensi magnet bonded hybrid masih dilakukan dalam skala laboratorium di Pusat Penelitian Elektronika dan Telekomunikasi. Pengembangan selanjutnya, invensi ini dapat diproduksi secara massal dan digunakan untuk memenuhi kebutuhan industri elektronika nasional, seperti meteran air, printer, pengeras suara, keyboard komputer, alat bantu dengar, generator, dan motor listrik. Kami menantang Anda untuk menjadi teknopreneur melalui teknologi ini. Apakah Anda berani? Ayo membangun bisnis berbasis teknologi.
"5G is revolutionary. It promises extremely fast communication, ultra-reliable low-latency data links, and support for huge numbers of connected devices. To make it work, network providers depend on micro-base stations to provide high-capacity coverage through beam steering and massive MIMO. That is, multiple input and multiple output systems. The best route to each device is determined by pilot signals and computations on the base station side of the network. Through virtual prototyping with Simulia electromagnetic simulation, specifically CST Studio Suite, you can ensure the best possible network connections, even in complex environments where a hand or a large object in the street may block the direct signal path. You can also optimize antenna arrays and high-speed circuit performance, as well as ensure safety and critical regulatory compliance. Simulia electromagnetic simulation gives you the ability to simulate complex multipath environments, measure signal strength virtually rather than time-consuming manual measurements, and optimize microcell placement. Taking real-world scenarios into account, clean handoffs between base stations can be ensured with no coverage gaps. Simulia electromagnetic simulation provides efficient end-to-end 5G simulation solutions, allowing you to deliver high-performance designs in a short time frame and at lower costs, without compromising compliance, reliability, and safety. Let the revolution begin.
Penggunaan sinar radiasi ultraviolet C atau UVC merupakan salah satu metode dalam sterilisasi. Sinar radiasi UVC dipercaya dapat melengkungkan struktur materi genetik virus dan mencegahnya berkembang. Pusat Penelitian Elektronika dan Telekomunikasi LIPI telah mengembangkan alat sterilisasi ruangan portable berbasis sinar UVC. Si Susan atau Simple Smart UVC Sanitizer memanfaatkan sinar UVC yang dikendalikan secara cerdas. Si Susan memancarkan sinar UVC yang menyinari langsung permukaan benda di ruangan atau kabin.
Seperti kita ketahui, sinar UVC adalah mempunyai kemampuan untuk melemahkan mikroorganisme, termasuk diantaranya adalah bakteri, virus, pada suatu permukaan benda dan di suatu ruangan. Si Susan dapat digunakan untuk menghambat penyebaran COVID-19.
Parameter penyinaran dapat diatur melalui aplikasi Android, seperti lama penyinaran sesuai dengan luasan ruangan dan jenis virus atau bakteri yang akan dibasmi. Penjadwalan penyinaran dilengkapi sensor keamanan dari aktivitas manusia. Si Susan didesain dengan sangat sederhana, portable, dan murah sehingga dapat digunakan di rumah tangga, klinik atau puskesmas, sekolah, kantor, dan lain-lain.
Next-generation technologies like radar and satellite communication with high data rates call for innovative testing solutions to develop and manufacture RF components. A critical part in the development and design of large communication systems, as well as single RF components for microwave devices like oscillators and amplifiers, is phase noise measurement. This is used to show developers if a signal source noise is as low as it should be. With the launch of the R&S FSPN, Roda and Schwartz is adding a new member to their phase noise analyzer portfolio, enabling increased efficiency and reproducibility of phase noise measurements and VCO characterization from lab to production. The R&S FSPN only takes a few seconds to perform VCO characterization. This not only speeds up the lab processing time, but also multiplies the measurement throughput in VCO manufacturing lines. As the leader in this area, Roda and Schwartz was able to develop the best phase noise and VCO tester on the market, whose pre-configured setup allows easy testing and instantaneous results for the lab, as well as for production applications. The R&S FSPN, unrivaled sensitivity meets high speed. Find more information and learn about phase noise and VCO testing on our website.
Jurnal Elektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as DOAJ, Google Scholar, Mandiri, and etc. JET is also ranked as Center 2 in Kemendristek Green accreditation system. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge and therefore no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
Next-generation technologies like radar and satellite communication with high data rates call for innovative testing solutions to develop and manufacture RF components. A critical part in the development and design of large communication systems, as well as single RF components for microwave devices like oscillators and amplifiers, is phase noise measurement. This is used to show developers if a signal source noise is as low as it should be. With the launch of the R&S FSPN, Roda & Schwarz is adding a new member to their phase noise analyzer portfolio, enabling increased efficiency and reproducibility of phase noise measurements and VCO characterization from lab to production. The R&S FSPN only takes a few seconds to perform VCO characterization. This not only speeds up the lab processing time, but also multiplies the measurement throughput in VCO manufacturing lines. As the leader in this area, Roda & Schwarz was able to develop the best phase noise and VCO tester on the market, whose pre-configured setup allows easy testing and instantaneous results for the lab, as well as for production applications. The R&S FSPN, unrivaled sensitivity meets high speed. Find more information and learn about phase noise and VCO testing on our website.
Saat ini, kebutuhan magnet permanen di Indonesia relatif tinggi. Magnet permanen adalah magnet yang memiliki sifat kemagnetan yang lama dan tetap, sehingga sukar untuk dihilangkan. Magnet permanen banyak dimanfaatkan pengaplikasiannya oleh industri dan UKM pada berbagai komponen elektronika. Namun, tahukah kamu, sebagian besar kebutuhan magnet permanen di Indonesia masih diimpor dari negara lain, seperti Cina, Jepang, dan Amerika. Salah satu magnet permanen yang cukup banyak digunakan adalah magnet barium ferit. Magnet barium ferit, atau yang sering dikenal juga dengan sebutan magnet keramik, adalah magnet permanen dengan rumus BaFe12O19 yang terbuat dari bahan baku utama oksida besi dengan teknologi serbuk. Untuk meningkatkan kekuatan magnet barium ferit, Pusat Penelitian Elektronika dan Telekomunikasi Lembaga Ilmu Pengetahuan Indonesia di Bandung telah menemukan sebuah invensi berupa magnet bonded hybrid. Apa itu magnet bonded hybrid? Magnet bonded hybrid merupakan penggabungan dari magnet barium ferit dan magnet neodymium iron boron (NdFeB) dengan menggunakan teknologi hot press bernomor paten P00201407033. Keunggulan dari invensi ini adalah harga lebih murah bila dibandingkan dengan produk impor. Jumlah, bentuk, dan spesifikasi dapat dibuat sesuai kebutuhan pengguna. Keunggulan lain dari invensi ini adalah menggunakan produk lokal limbah oksida besi, temperatur Curie, dan ketahanan korosinya lebih tinggi dibanding magnet NdFeB, serta kekuatan magnetnya lebih tinggi bila dibandingkan dengan magnet barium ferit. Saat ini, pembuatan invensi magnet bonded hybrid masih dilakukan dalam skala laboratorium, elektronika, dan telekomunikasi. Pengembangan selanjutnya, invensi ini dapat diproduksi secara massal dan digunakan untuk memenuhi kebutuhan industri elektronika nasional, seperti meteran air, printer, pengeras suara, keyboard komputer, alat bantu dengan
Sudah bisa dimulai belum ya? Tes. How about my voice? Is it clear? Hello?
I think clear, Pak Yana.
Okay, let's continue this session because time is 1 o'clock. Okay, welcome back for participant and presenter. Here, my name is Yana Taryana from Research Center, Electronic and Telecommunication, National Research and Innovation Agency. I am as moderator from this for this session. Before we start this presentation, I want to remind the rule of some this session. The first, for all presenter and participant, please keep your video on until session finish, and you have 20 minutes for presentation, including Q&A, or maybe there are some opinion for all participants. And last, all participants would you like to ask a question, you can raise hand function at participant menu on Zoom, or you can write it in chat room in menu Zoom. Okay. Also, in the time, I will invite for the first presenter, Heri Dwi Kurniawan. He will present his paper with title Design Analysis of High Flow Rate Serial Connection Multi-Chamber Piezoelectric Micropump Drug Delivery System. So the time and place is yours.
Okay, thank you for the time. Good afternoon, everybody. My name is Heri Dwi Kurniawan from Research Center for Electronic and Telecommunication, National Research and Innovation Agency, Indonesia. In this session, I want to share and discuss with you our research entitled Design Analysis of High Flow Rate Serial Connection Multi-Chamber Piezoelectric Micropump for Drug Delivery System. This paper was authored by me, Heri Dwi Kurniawan, Widya Budiawan from National Tsinghua University, Taiwan, and also from Academia Sinica, Taiwan, and Mokhtar Chandra from National Tsinghua University, Taiwan. MEMS, or Micro Electromechanical System Technology, present many advantages for developing the device, including low cost, small size, and low power consumption by using microfabrication technique. Furthermore, it has also promising great potential applications, such as from the drug delivery system, cell culture, micro total analysis, backbone chip, and also insulin pump system. For the MEMS-based microfluidic devices, for the biomedical application have two essential parts. The first part is micropump, and the second part is micro needle. Various types of micropump can be classified become two types. The first type is mechanical micropump. The second part is non-mechanical micropump. Mechanical micropump are the micropump that having mechanical moving part then actuated by physical actuator or mechanisms such as electrostatic, piezoelectric, thermopneumatic, bimetallic, SMA, ICPF, electromagnetic, bastion type, and the others. On the other hand, the non-mechanical micropump have no mechanical moving part that transform non-mechanical energy into kinetic momentum so that the fluid in the microchannel can be driven. This type of micropump including magneto-hydrodynamic, electro-hydrodynamic, electro-osmotic, electrowetting, bubble type, FPW, electrochemical evaporation type, and the others. Among the various types of the micropump, piezoelectric actuator provide its advantage of moderate pressure, reliable, low power consumption, simple structure, also flexible to integrate with the component of the micropump. We can see in this illustration is the piezoelectric micropump principle. You can see in this one, a piezoelectric micropump consists of a piezoelectric disc that attach on the diaphragm, a pumping chamber, and valve. The piezoelectric micropump is actuated by the deformation of the piezoelectric material, which the deformation.
Recording in progress. Recording stopped. Recording in progress.
I think it's lost connection. Let's begin again, Mr. Eric. Let's begin.
And the generated pressure, PG, you can see in this equation also depend of these three kind of parameter. And the important parameter is the flow rate is depend on the delta V times the F. Delta V is volume displaced per stroke and F is driving frequency. So from this one, we want to design a micropump with high pressure and high flow rate. Our proposed mechanism is using multi-pump. We can see in here the working principle of the serial connection of four chamber piezoelectric. So to improve the flow rate and back pressure, we use multi-chamber in the serial connection. By utilizing four chamber, we can see in this equation the pressure is depend on the number of serial connection of micropump. This one is N times the pressure in one chamber. And for the Q also depend on the N, the number serial connection of micropump. This one is the principle. We can see in the first half cycle, the liquid movement from the inlet to chamber 1, and then chamber 2 to chamber 3, and chamber 4 to outlet. And we can see the status of valve in valve 1 and valve 3 and valve 4 is open. On the other hand, valve 2 and valve 4 is closed. So the liquid only flow in inlet to chamber 1, chamber 2, chamber 3, chamber 4 to outlet. In the second half cycle, valve 1 is closed, also valve 3 and also valve 5. Beside that, valve 2 and valve 4 is open, so the liquid will move from chamber 1 and to chamber 2 and chamber 3 to chamber 4. The working principle of this pump can be described as the periodic process. So we can find this one is the total pressure and also the total flow rate in this serial connection of multi-chamber. In our design, we propose the fixed number of serial connection, that is using 4 chamber and we adjust the diameter, also thickness, to increase the flow rate, also increase the pressure of this design. We use voltage as 36 volt with frequency 200 Hz. So we can find with the diameter and also thickness with this value, we can find the flow rate is 10.7 milliliter per minute, and the back pressure is 3.4 Newton, 3.4 E4 Newton per meter square. So what is our expected characteristic is this design should be using the low driving voltage with the high flow rate and blood pressure output, also have a design compact with the micro size dimension, and also biocompatible material using PMMA or BDMS. You can see in this design, this is the every part of our design. This is pump cell, drag reservoir, this is the actuator, pump body, valve, piston for drag refining, valve, this is the actuator, check valve, and this is outlet. So for this detail is this one. This is pump cover, this is the actuator, this is valve 1, valve 2, pump body, and this is the actuator. So for the detailed design of our micro pump, this one is in the single micro pump mechanism. This inlet go to chamber, then from chamber go to outlet by this is the actuator deformation. So this is our design. So liquid from the inlet go through here to fill to the chamber 1 here, then go to chamber 2, and then chamber 3, and chamber 4, then to the outlet. The dimension of or length of cantilever we propose using 400 micrometer, and this is the pump body dimension you can see in here, and the PZT actuator with the thickness 150 micrometer is here. So we also propose a process design of this micro pump. We propose the material of the pump body using polymethyl methacrylate or PMMA, PZT actuator using lead zirconiated tenet, valve using beryllium bronze, pump outside cell using perylene, and drag reservoir and the piston using BDMS. For the fabrication process, every micro pump or every part of this micro pump is modular micro pump. So every micro pump was manufactured using micro fabrication technology separately by precision carving machine or 3D printing machine. Then after that, we assemble together with a special material to complete this micro pump. You can see in the animation of assembly of our design. And for the simulation result, we study the flow distribution and the cantilever valve opening by using a finite element analysis software. You can see the flow distribution simulated to see the behavior and the distribution of the liquid inside the chamber. We use boundary condition is water with the inlet volume flow rate as the previous calculation 1.79 E minus 7, and with the outlet no pressure. We can see in this cross section the highest velocity valve of 1.2 meter per second was in the inlet. You can see in here is the red one, it's mean the highest velocity value, and the other spot is blue, display zero velocity, indicating the steady state has been reached at this spot. And the pressure gradient between inlet and chamber cause the fluid flow with different velocity starting from the higher pressure to the lower pressure area. The second simulation is the cantilever valve opening simulation. The cantilever constraint of using material beryllium copper valve, apply with the normal uniform pressure 34.4. This is the number is from the previous calculation to the body spline. In here, the valve was set at the end to freely move and fix at another end of the model. And the results show the von Mises stress, the fragile strength of 172 kilonewton per meter square can be the maximum critical stress of this valve. And for the deformation of Z displacement, the flexion of the valve increase upon increase the distance from the original point. The opening valve was deflected by 716.9 micrometer at the end of the valve, which was freely moving. And in the end, we compare our design with other work. As we can see, we compare with the other with reference 4, reference 5, and 6. And we have a smallest dimension compared to the others. Also, for the voltage using 36 is lower voltage with frequency 200 Hz can give 34.3 kilopascal pressure, which means the higher, and high flow rate 10.7 milliliter per minute. And we can conclude this is our design specification. So the dimension of our design is with diameter 15 millimeter and with the length 36.4 millimeter. And then the number of chamber is 4 with the driving frequency 200 Hz and the driving voltage 36 volt. And the material we propose is PG tank using the zirconia titanate and with Pambadi PMMA and valve beryllium bronze. So from the calculation, we can get the output of flow rate 10.7 milliliter per minute and the break pressure 34.3 kilopascal. This is the end of my presentation today. If you have a question, just let me know. Thank you for the attention.
Okay, thank you, Mr. Ari, for nice presentation. Maybe for participant, is there any question for Mr. Ari, or other opinion about his research? Okay, if there is no question, maybe I want to ask one question, Mr. Ari. Is your research simulation and realization or just simulation?
Okay, this study is like a preliminary design of my devices. We still ongoing on the simulation. Then if we want to fabricate, we can do after this simulation complete.
Okay. Maybe you have difficulty during your simulation or next for realization. What is your difficulty to realize your design realization for after simulation? Maybe some parameter or another else?
If we want to fabricate a small device as we design in this paper, we need like a facility to make as small as possible. If we want design like a micro pump, the dimension is under micrometer. So besides that, also in this research we make like a modular modular design that every part will fabricate separately. So I think when we want to fabricate this device, we need like a special material, as I say in the presentation, to glue every part together.
Okay, thank you, Mr. Haris, for your answering. Another question maybe for participant or for the other presenter in this room. Okay, because time is up, I think it's enough for your presentation, and give him applause for interesting and nice presentation. Thank you, Mr. Haris. Yeah.
Oh, thank you very much.
Okay, let's continue with the second presenter, Mr. Kojoni Yanto. He will present high flow and high pressure oxygen mixing for ventilator system. Time and change honorable yours, please.
Assalamualaikum warahmatullahi wabarakatuh. My name is Eko Joni Pristianto from Research Center for Electronic and Telecommunication, National Research and Innovation Agency of Indonesia. On this occasion, I will present a paper entitled High Flow and High Pressure Oxygen Mixing for Ventilator System. The treatment of patients with acute respiratory failure due to COVID-19 needs ventilator machine support to provide oxygenation and ventilation processes. The most important control in the machine is how to provide precision-inspired oxygen fraction to the patient during the treatment. Generally, low-flow nasal cannula can provide for up to 6 liters per minute of supplemental oxygen with approximately 37 up to 45% oxygen fraction. In this paper, we present high flow and high pressure oxygen mixing to provide up to 100% oxygen fraction and 60 liters per minute. The proposed system also employs the closed-loop feedback control to achieve the desirable oxygen fraction set point. It can be used for a continuous positive airway pressure and level positive airway pressure ventilator system with oxygen, as well as a high flow nasal cannula system for acute respiratory patient syndrome. Figure 1 shows block diagram of the proposed ventilator pneumatic system, which consists of several functional modules. The ventilator system was developed by the Research Center for Electronic and Telecommunication, National Research and Innovation Agency of Indonesia, named Smart Innovative Ventilator Indonesia, SIVENISIA. Source of the gas consists of two inputs that are input source from an oxygen inlet and an ambient air inlet. The two sources are used to provide an inspired oxygen fraction in the mixing module before delivered to the patient. In the first source, oxygen gas will be regulated by a gas regulator to maintain the pressure around 3 up to 5 bar. Then, a proportional valve is used to control the oxygen flow to the mixer. The module proportional valve was developed by ourselves and is responsible to provide the required oxygen flow. The DC motor control proportional valve based on a self-locking gearbox. The module has been patented with the Indonesian patent application. The module maintains oxygen flow for control inspired oxygen fraction production. High RPM DC motor and high ratio gearbox use. lead to the high resolution flow oxygen as 0.1 liter per minute can be achieved. A filter and oxygen sensor also installed to filtrate and monitor the flow oxygen. An oxygen flow sensor used to provide the oxygen feedback as the input to the closed loop feedback control system to achieve the desirable oxygen flow. The second source, ambient air from the air is filtered and blown by a motor control blower and air filter. A brushless centrifugal DC motor blower is used to supply adequate ambient airflow and pressure, provide high pressure up to 7.5 kilopascal and high airflow up to 240 liters per minute to deliver airflow and pressure into the oxygen buffer. Then, inland flow restrictor, ELFR, is used to control the airflow to the mixer. Then, the oxygen and air are mixed and circulate in the oxygen buffer to provide precision inspect oxygen fraction to the patient during the treatment. After that, pressure release valve, PRV, is controlled to provide the desired high flow and high pressure oxygen mixing. The outlet of this system is air filter before the exhaled air from the patient is thrown into the free air. An oxygen fraction flow and pressure sensor is used to provide the feedback as the input to the closed loop feedback control system to achieve a desirable oxygen fraction flow and pressure. There are minimum two important parameters for the output in ventilator. That is oxygen fraction and pressure. To maintain these two parameters, we set the desired set point using databases. The database consists of the data of oxygen flow, ambient air flow, and opening closing valve. While the oxygen fraction sensor is used to monitor the level of the oxygen fraction produced. All the modules are controlled by a microprocessor in the data and signal processing unit. Table 1 shows specific medical parameter, the developed Venetia ventilator, where this is a standard parameter that must be met on a ventilator system. Figure 2 shows the test setup in this study. The ventilator needs an oxygen source from a portable oxygen tank attached to the oxygen inlet. Meanwhile, the air inlet is used to feed ambient air from the environment and receive the oxygen pressure to the flow analyzer, the personal computer used to control and process the data. Figure show the result of measured airflow from ambient. The flow of the air was controlled by used to control the speed using pulse width modulation. As shown in figure 3, we can find that the relation of the PWM and airflow is quite linear. Using this data, we can control the output flow of oxygen fraction precisely by mixing the airflow from ambient combined with from oxygen source. The inspired oxygen fraction detection use flow and pressure sensor. The sensor can measure uni or bidirectional flow and pressure from inspired and expiration processes. A flow up to 250 lpm and pressure up to 100 centimeter X2O can be provided. The accuracy of pressure reading is 1%. The data and control using I2C connection with the output is linear. Figure 4 show the sensor output voltage correspond to the oxygen fraction. The graph show that the output sensor works that oxygen fraction from 20 up to 100% can be detected, which is suitable for monitoring bidirectional the flow and pressure oxygen fraction. Figure 5 describe the measure flow of the oxygen, ambient air, inspired oxygen fraction, and pressure, which correspond to the inspired oxygen fraction. Minimum output flow specification is determined at 60 liters per minute, and minimum output pressure is 20 centimeter X2O. Based on the requirement, the continuous positive airway pressure therapy need up to 40 centimeter X2O flow oxygen fraction. Meanwhile, above 50 centimeter X2O flow oxygen fraction can be used for high flow nasal cannula therapy as well. Both flow oxygen and airflow are used to produce the oxygen fraction flow. Here we simple the formula by flow oxygen fraction equal flow ambient air plus flow oxygen with the assumption of no leaks in the system. There is no correlation in the amount of blood flow with the output flow oxygen fraction to reach above 100 lpm flow oxygen fraction. The required flow oxygen and ambient air 20 up to 60 liters per minute and 115 of 20 up to 60% and pressure remain flat at 20 centimeter X2. However, below 100 lpm flow output oxygen fraction, increased flow oxygen is needed 40 up to 80 lpm with decreasing flow ambient air 120 up to 0 lpm. This led to the oxygen fraction from 60 up to 100% and pressure stable at 40 centimeter S2O. Due to varying input flow oxygen and ambient air to produce the output flow, it is difficult to use manual proportional mixing. Here, the mixing process based on calibrated value is used. These values are measured at calibration on the normal operation of the ventilator using the Fluke VT650 gas flow analyzer. All calibrated possible values were saved in the memory of the data and signal processing unit. Whenever the required flow pressure oxygen fraction is needed, the system generates the suitable value on the system to achieve that. With this method, all possible target parameter output can be easily reached. Conclusion: high flow and high pressure inspired oxygen fraction in the C. Venetia ventilator have been described. The mixing process relied on the amount of oxygen and ambient airflow to achieve a determined oxygen fraction. The inspired oxygen fraction can be achieved from 20 up to 100%. The flow oxygen fraction as high as 60 up to 120 lpm can be reached instantaneously mixed from oxygen flow from 0 up to 80 lpm and ambient air flow from 65 until 120 lpm. The output pressure can be provided from 20 up to 40 centimeter H2O. This release is stable for obstructive sleep apnea syndrome patient using continuous positive airway pressure treatment with oxygenation filter as well as high flow nasal cannula therapy. Okay, thank you.
Okay, thank you for interesting and nice presentation, Mr. Eko Joni. And now maybe for participant have question, please. Is there question? Okay, Mr. Eko, if there is no question for participant or other presenter, maybe I have many questions because your research is very complex, but because it's limited time, I just want to ask 2 questions. The first, how to make sure that oxygen resulted is pure. Determine pressure and determine the fraction of oxygen. And the second question is how to control the output of oxygen pressure. I think that is my question.
Okay, thank you, Mr. Yana. To produce oxygen fraction, we use a database table comparing the value of flow blower and oxygen flow. Oxygen fraction result we calibrate with a standard measuring instrument. This is a VT 650 gas flow analyzer instrument. For the flow blower, we set the PWM value, while for the oxygen flow, we use closed loop control with the PID system, where the set point is the oxygen flow value and the flow sensor is used as feedback. But in this paper, we don't detail the PID control system, only explain the process in general.
The second question, to control the output oxygen pressure.
Oxygen oxygen pressure. Yes. Pressure or
pressure.
Pressure. Oxygen pressure I control with module PRV, pressure relief valve. This is the module I can control with PID system. The sensor feedback will use a pressure sensor, and pressure sensor used to use as a feedback.
Okay. Maybe it still have time. Maybe another question for from participant or another presenter, please. Okay.
Sorry, Mr. Moderator, I have question for Mr. Doni.
Okay, please, Mr. Henry.
I think it's a nice presentation that your research are very useful in this pandemic situation because the ventilator are still needed in this pandemic. So I have one question for Mr. Eko. In this system, how about the resolution of your oxygen fraction? It's been, you say you calibrate with the flux as the standard calibration, and how much error you get in this measurement? And then the second question, in this paper you say this is for high pressure and high flow ventilator, right? So is it possible this ventilator can be used in other mode compared with, in this your paper you say only used in the CPAP and BiPAP, right? So it's possible is this ventilator used is like in the emergency or something mode in this ventilator?
Okay, thank you, Mr. Ari, for the question. For oxygen fraction resolution, we follow the standard BPFK, Balai Pengamanan Fasilitas Kesehatan, which is 5%. The actual requirement of BPFK for oxygen fraction is only 35% until 85%, while the ventilator we develop can produce an oxygen fraction from 20% up to 100% with a resolution of 5%. The second question, what?
Yeah, the second question, is it possible you use this kind of the machine for the others mode? In this paper you say you use in this CPAP and BPAP, right?
Okay, next, the mode is the Venetia ventilator. I will use mode is HFNC, and I use the HFNC is Hegnesal Vulcanula. Is make the mode is significant Venetia ventilator.
Okay, thank you.
I think, Mr. Eko, it is last question I find in the chat room from Jalu Ahmad. He asked a question. How is about gain creation of VID? Are there exciting founding again of KP, KE, and KD? I understand maybe Jalu Ahmad can ask to presenter, please.
Okay, thank you for Mr. Jalu Ahmad. We control.
Can you? Yeah.
We control the variation of PID control, funding gain of KPID. Is a trial and error because we not yet for the modeling for the proportional of oxygen proportional valve. So no modeling for proportional valve. For the PID control, funding PID use trial and error.
How about Mr. Jalamat? Is enough?
Oh, okay. Yes, it's just try and error. Yes. Okay.
Yes,
maybe next time it will be more advanced to gaining the PID control. Yes.
Okay, I think it's enough because time is up for Mr. Eko Joni presentation. Thank you for Mr. Joni for nice and interesting presentation. And then we will continue with the presentation, Mr. Jalu Ahmad Prakosa, with title Synthesis Method of Mixed Sensitivity for Edge Infinity Reduce Control Optimization on DC Motor of Mechatronics Model. Time is yours, please.
Hello everyone. I hope you keep healthy and happy. I will present my result of here, right moment. This is our presentation. I will present for the 10 International Conference on Radar, Antenna, Microwave, Electronic and Telecommunication, or Icramet 2020 on virtual conference. Our title is about a synthesis method of mixed sensitivity for edge infinity robust control optimization on DC motor of mechatronic model. The presenter is me, Jalu Ahmad Prakosa, and my friend. For full of my co-author, you can see the paper. I came from Research Center for Physics, National Research and Innovation Agency, BRIN. Okay, next, this is the background. Direct current DC motor is extensively used in industry, education, and household appliance. In the corner, you can see this common type of DC motor. The speed quality of DC motor need to be guaranteed from interference and uncertainty. Although the component of DC motors as electronic and mechatronic can develop and model, mechatronic model, but its degradation and sensor might provide uncertainty. In addition, disturbance from environment and overload can interfere the performance of DC motor. Okay, our research goal. This research aims to apply the mixed sensitivity synthesis method of edge infinity robust control for optimization on speed control of DC motor model to deal with uncertainty. This our synthesis technique of mixed sensitivity. Yeah, W1, W2, W3. It is located in the error, and this is a controller. So the position of it is W in the controller and W3 in the measured output from the sensor. It is in the closed loop control system. So we develop from the corner frequency. It is the cutoff. This is about the plot. You can see this is the point of cutoff. The omega cutoff, the omega 1, omega 2, omega 3, omega 4. This, we can calculate the cutoff frequency with the formula we use later. From this graph, we can develop some equation. This equation 20 log W1 for W2, same with this gamma minus. So we can use this to calculate our mixed sensitivity of W1. This equation. T is the period, is inverse of the frequency. Is W2 is can set near to 0 or in small number. And W3 is the formula almost the same. Next is about the robust control theory of H infinity method. This is the norm of the H infinity. The robust control criteria occur when infinitum of singular value from the overall transfer function of the system doesn't exit from 0. It just means that the system should be stable. So this is the diagram. There are Y, there is disturbance input, there are U, there are control input, there are also the error output keep to be small, and Y is measuring output from the sensor. They also P and K are matrix. This is also the criteria. The infinium norm to find the control K is defined as supremum of the maximum single value of the Fourier response of dynamic system. Alpha is non-negative cycler of control performance. Furthermore, controller K supposed to be included in the system to solve the mathematical optimization to this equation below. Then this is DC motor plan. It's our DC motor. We use experimental tool. Dot gear, encoder, expression sensor, connecting gear, DC motor. And this is the diagram. They are resistor, voltage. They are inductor. They are here voltage. It is also back FMF. You can calculate there connecting with the connection and the load. This is back EMF. Is constant to the speed of DC motor. You can draw from the Kirchhoff law to voltage, resistor. This is also inductor. This is DC motor. Yes, you can calculate this from this formula, this equation. We can develop and implement it using MATLAB simulating software. We develop this diagram. We design this variable. They are in this scheme. Then is the result and discussion. After we implement the model, we try to run it. This is speed control in radian per second. This is time. You can get the linearization of this step response to get this transfer function first order. So from the we calculate the critical cutoff frequency from the transfer function is 10.05. Yes, we calculate this frequency, so we can calculate W1, W2, and W3. For remember, we can see again this slide before. Yeah, this is the calculation. You can see in detail in the our paper how calculate W1, W2, W3 to mix the sensitivity method to do H infinity optimization from this weighing. So the other result is singular value. This is control K that we calculate with the formula above the singular value. We see that from 10 dB and decrease near to just 30 dB and almost 10,000 radian per second. We should make an assessment to the singular value. So it is the alpha value. For remember, we can look again to slide before. So the theory of H infinity control. It is the robust criteria and also the infinity norm. It is all we can assess, and it is satisfy all because it's although start from 10 but is decrease to 0. And the other is the result and this discussion. These are the result, the step response, they are plan and DC motor in black, and they are plan under disturbance. We make simulation of noise of sensor. This is the purpose method in green. Signal is you can see so beautiful. The overload is this signal is don't interference by disturbance, so have a smoother signal. But the consequence, the controller car have the higher transfer function we input in the system. So the proposed design increase the order of transfer function from 1 to 2 because it is multiply. So the other conclusion, the development of sensitivity synthesis method for edge infinite optimization on mechatronic model of DC motor speed control was successfully constructed due to improved robustness performance. In addition, the decrease of single value added proof that supports as is improvement. Applying result of optimization step response happened because the perfect robust control signal both before and after simulation assessment. The robustness improvement occurred on proposed controller designed by decline overshoot, error, and time response and getting smoother signal. We can see before. Although the proposed controller increased the order standard function dramatically, it could be solved using personal computer performance today. It is easy using a MATLAB simulating. The application of electronic component and position sensor, also environment disturbance on DC speed motor, might cause the source of uncertainty, noise, and disturbance, which could be neglected by edge infinite robust optimization to make sensitive technique that we have already developed. You can see. Yes, this is we assign the singular value. This is decrease, so it is proof for the improvement of robustness of the system. You can see the comparison, the model, the plan under disturbance, and our proposed design with the this is yes our conclusion, the improvement for our system that we apply make synthesis sensitivity. Okay, I think it is enough for our presentation. Thank you very much for your attention. Spasiba, thank you very much for the watching my presentation, Icramet 2020. Okay, I hope you be healthy. Bye-bye.
Okay, thank you, Mr. Jalwa Ahmad Prakosa. I think it's a nice presentation. Okay, now time is for ask and question. Maybe from participant and another presenter have question, please. Maybe Mr. Eko is still here because this topic is your skill. Mr. Eko is still here.
Mr. Yana in chat room, somebody will ask maybe.
Okay. There is no question in the chat room. Maybe for Dr. Dedi, you have question? Or another participant, another presenter? Have question, please. I think it's still time. It has still time for several minutes for asking question. Okay. If there is no question, I think it's enough for Jalul Ahmad Prakosa presentation. And thank you very much for your nice presentation, and give applause for Mr. Jalul Ahmad. Thank you.
Thank you. Thank you.
Okay. Next, the last presenter, I would like to invite Mr. Avtar Singh from Adama University of Science and Technology, South Africa. Is it right? Mr. Avtar Singh?
Yes, sir, it's fine.
Okay. Okay.
Yeah.
I think this is time for you to presentate your paper. Please, time is yours.
Okay. Hello everyone, myself Dr. Avtar Singh. I'm working as a faculty member in Department of Visi, Adama Science and Technology, University Adama, Ethiopia. In this paper, the co-author is Professor Virenji Mohan Shrivastava. He is working in the Department of Electronic Engineering as a professor, University of College Natal, Durban, South Africa. Here I'm going to discuss about my research work, effect of drain splitting on silicon nanotube tunnel field effect transistor. So this is the paper outline: introduction, related works, problem formulation and proposal, results, conclusion, future work, references, etc. Okay, so first the introduction. So in this paper, actually, we have analyzed the drain engineered silicon nanotube tunnel. Drain engineer means like we have taken the drain and we split into two parts. Okay, one contain the less doping, the other part contain the more doping. Means the major difference between the conventional and this structure is, in the conventional we have only one drain. Okay, but in this structure we have two drains. One means we are splitting the drain into two regions. One region contains lesser doping comparable to the other region. Okay, so the performance of tunnel fed by modulating the doping in the drain region have been realized in this paper. Basically, when we are saying with the dist. Okay, so the TFET device proposed in this work is actually a tubular type structure. Tubular type structure means this is the tube MOSFET. Like we have a one gate all around inside the tube and the one gate all around outside the tube. So this is the major advantage of this structure over the simple nanowire or gate all around, that it has two gates, one inside the tube, one outside the tube, and it surrounds the tube from the both sides, from the inner side as well as from the outer side. Okay, due to which the controlling capacity over the charge carriers is excellent. It has also been realized that on decreasing the doping of the split drain region, the ambipolar current decrease from 10⁻⁹ ampere per micrometer to 10⁻⁻11 ampere per micrometer, which makes it very suitable for the low power memory applications. Okay, the outcome also shows that the drive capability of the device is increased. So now this is the introduction. Introductions, actually, we have not started with the MOSFET directly. We are covering the tunnel fed due to the less of time as well as the paper length. So for better switching performance, we need the device which has lesser or steeper threshold swing, which should be below 60 millivolt per decade. Switching performance means the on to off time, it should be minimized. Okay, or off to on also minimized. Okay, so the tunnel fed is one of the promising candidate to replace the conducting mechanism, because in the conventional MOSFET we are using the thermionic emission band-to-band tunneling, but in this we are using band-to-band tunneling. In the conventional MOSFET we are using the thermionic emission, and in this we are using the band-to-band tunneling. So this is actually the major advantage of the tunnel FET. The tunnel FET is different from the conventional MOSFET. In the conventional MOSFET, we have a same doping on both the sides, on the N side as well as on the P side. But in the TFET, the doping in the source and drain of TFET is opposite. Means in the source we are taking generally P type, and the and the drain region we are taking N type. Okay, we can take the vice versa. Okay, that's not our means because there are two types of tunnel FET, PIN and NIP. So that's the thing. So, but the major drawback in the tunnel FET is the on current, because we have reduced the leakage too much. It's around 10 to the power minus 17, 19 as per the device. Okay, device material and all those things. But the on current is also reduced. Now, this is the major drawback in the tunnel FET devices. So to reduce these type of drawbacks, what we need something like many researchers all over the world have already working on this. Somewhere a lot of research papers are already published on the means to how to enhance the on current of the tunnel FET. So some of them I have put it here, like by employing a 4-layer PNPN structure, by employing high K double gate, by employing gain drain overlaps, asymmetric source and drain regions, etc., or by replacing a P plus device region with lower band gap material at source. Okay, so this is the about the on current. There is a one more major drawback in the tunnel FET, that the ambipolar current. Ambipolar current is also increased. We reduce it. What is ambipolar current? Ambipolar current is the current when we what we are getting at the negative x-axis. Okay, like we are means we have only one current in the positive x-axis. If we are talking, we have only one this type of a current. Okay, this is the IDVG characteristics if we are talking. But when we are talking about ambipolar, it means when we are increasing the negative, then we are getting also here. So this is known as ambipolar. Okay, so this is actually the one of the major problem for us. Okay, so there are a lot of, because lot of techniques, lot of methods are already came to reduce this ambipolar current. Okay, so to reduce the ambipolar current, some of the researchers have done by using the heterogeneous gate dielectric oxide structure, keep Gaussian doping in the drain region, employing dual metal gate, underlap gate drain region implantation, drain overlap structure. So these are some of the techniques by which we can able to reduce the ambipolar current. Now this is the device description. Okay, so this is the device. As we have seen in this device, there is a one, this is the inner tube and there is the outer tube. Okay, so there are two tubes. Okay, so in this structure, we have two gates, one outside and one inside, as we have seen. Okay, so the channel length we have taken 45 nanometer, tube diameter we have taken 10 nanometer, silicon dioxide we have taken as a gate dielectric, and the thickness of the silicon dioxide is 1 nanometer. Doping source regions means doping of the source region we have taken 1:10 to the power 20 per centimeter cube. This is the P type. Then the doping in the drain region we have taken 5 × 10 to the power 18 per centimeter cube. Okay, and because we have two drain regions, one region we have taken 5 × 10 to the power 18, and the another one is 1 × 10 to the power 17. So the doping in the drain region and region second can be possible by the ion implantation, or means we can able to fabricate this using ion implantation, or we can make it using the epitaxial layer. Both process can be done. Okay, so here we can also see we have two regions. See, this is the one region, this is the second region. Okay, so the doping in these two, this is the only difference between the conventional and this structure. Okay, now the results. So we have seen this is the result. This is actually the BT diagram, band to band tunneling diagram. This is major. If we are going for the tunnel FET, then we have to show this diagram. So here our target is to reduce the ambipolar current. Okay, so ambipolar means the current between the drain and channel, not the source and the channel. Okay, so here we can see that the drain and the channel, because this is the conventional, this is the proposed. So in the proposed, because we have taken the readings at -1. Why? Because we are more interested in showing the ambipolar characteristics only, not in the drain on current. Okay, so that's why we have taken the things on the -1 volt. So that's why we have seen here. So the distance between the red to red, which is the proposed one, is more comparable to the distance between blue to blue. Okay, so this is the major advantage we are getting in this splitting grain structure. Okay, so This is already written. The energy band diagram we have taken. I already told you VGS equals to -1 volt and VDS equals to 0.7 volt. The splitting in the drain part is generally employed to decrease the ambipolar current. Ambipolar current is considered the current that is usually flowing when the negative voltage is applied at the gate terminal, as we have already seen. So it has been observed that the tunneling width at the channel drain junction is wider for the drain splitting tubular defect compared to the conventional defect. Okay, now this is the IDVG characteristics. Now this is the ambipolar current. Okay, this is the ambipolar current and this is the on current, we already know. Okay, so we have seen that the green line is when we have the doping is 2:18, then 3:18, then 4:18, and this one is the red one is the conventional. So we can see that ambipolar, due to the reduced doping, the ambipolar current is decreasing. Okay, because we are getting the minimum at means we can say, because after sometimes after some value it's not going to be reduced. Okay, so 1:17. This is our optimized one. If we are saying that this is the optimized one, and we can also say there is no any difference on the drain current, not any significant difference. We are getting some small, that's not value, but there is no, because this is the logarithmic diagram. So if the doping of the drain region second is decreased from 4:10⁻18 to 1:10⁻17, and the value of the ambipolar current is also decreasing from 10⁻⁻9 to 10⁻⁻11 ampere per micrometer. So this is the major advantage we are getting in this. So now this is the pictorial representation of the total current density. So we have also seen, because this is for the drain channel region. Okay, so we have also seen that the conventional have more and the red one, which is the proposed one, have less total current density. Because the current density is less, definitely the current is less. Okay, so this is the advantage we are getting. Okay, so this density we have taken when the doping of the drain region is 1:17. All the readings are taken at ambipolar behavior. To show the ambipolar behavior, we are taken all the readings at VGS equals to -1 volt. Okay, so the maximum current density for conventional silicon-based tubular FET is around 63 ampere per centimeter square, while for the proposed structure, the current density value is reduced to approximately 35 ampere per centimeter square. So now this is the conclusion. A novel split drain silicon nanotube tunnel FET device architecture is proposed and examined using 3D device ticket simulations. The proposed structure with optimized doping shows better results in terms of ambipolar current as compared to the conventional silicon nanotube tunnel FET. On introducing the split drain concept in the traditional structure, the tunneling behavior from channel to drain is wider than the optimized proposed device and the other one. So it has been found that on decreasing the doping of the split drain region, the ambipolar current decreased from 10⁻⁻9 to 10⁻⁻11. So we can say that in the future, it can be possible to use these type of low power devices for the RF and analog performances. Okay, and we can also do for the electrical modeling, and some circuit implantation can be explored. So this is some of the references we have taken. Okay, so thank you. Questions? Okay, thank you.
Okay, thank you, Mr. Avtar Singh, for your good presentation and interesting presentation. I think this time is for asking a question. Maybe participant or presenter have a question, please.
I have a question, Mr. Moderator.
Yeah, please.
Okay, please, Mr. Eric.
Thank you, Mr. Avtar Singh, for the nice presentation. In the tunnel FET is more different with the conventional MOSFET, right? They use band-to-band tunneling as the carrier transport mechanism. The disadvantage of the tunnel FET is they only give low current, low drive current, low ion. In your slide, you saw in your proposed structure, they can give a very low I of current, but in the total current density, they only have less current compared to the conventional. Do you have any comment of this your structure?
Sir, as you said, actually this is the tubular structure. Okay, this is not the normal structure. It is different from the normal structure. It has two gates, means one from inside and one from outside. Like we know about the gate all around. So this is the advanced, we can say the advanced version of gate all around. So definitely we are getting less because we are using the tunnel FET. Definitely we are getting less of current, but actually our work is more emphasized on the ambipolar current. Okay, that's why because we know that we are using, when we are using for the low power, then the ambipolar is also one of the major parameter to check the devices. So our concern is to minimize the ambipolar. That's why this is one of the method. Okay, although the complications and the fabrication definitely for this type of a structure is very typical, but not now, but in the future definitely we will have some technology to, although there is a patent file and the structure is available. Means there is a one paper from Daniel Clape. Okay, they have already patented the fabrication of this structure. Okay, so our emphasization more on the ambipolar. Is it fine?
Okay. So your propose is to decrease ambipolar current, right? Okay.
Yeah.
Thank you very much.
Thank you, sir. Thank you. Please.
Okay, is there question anymore? Please. Okay, if there is no question, okay, in the chat.
So 1 minute, I have a question on chat. There is a one question on the chat.
Yeah. Yes.
Yeah. Have you increased the doping concentration to up to 10 to power 20 for region 1? We'll check it once.
Please answer.
Yeah. No, actually, we have not done this thing. Actually, we have make it maximum is actually 5:18. Okay, actually, in the drain we are keeping less drain current and less doping. Okay, as compared in the source we have a doping of P type of 1:20 is to power 20. And in the drain we have up to 4:10 is to power 80. Or not make it more than that, because actually there is some because we, as you know already, we have done the simulation work. So there is a we are not getting on this when we are making it 10 to power 20. So what happens, there is the some other parameters are including. So that's why we have not taken that. We have taken up to 10 to power 18. 4 into 10 to power 18. Okay.
Okay, Mr. Dr. Dedi Bada, is it enough with
yes, any other?
Yeah. Okay, I think it's enough, Mr. Akhtar Singh. And
you,
maybe another question from the participant or another presenter, please, because we have still time. Okay, I think it's enough. There is no question anymore. Thank you for nice, interesting presentation, Mr. Akhtar Singh.
Thank you, sir.
I think this program or this session is finished, and I would like to say thank you for all participants and for all presenter in this session, and see you next event, annual event in International Component Radar Antenna Microwave Electronic and Communication. See you next year. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
wabarakatuh.
Recording in progress. Recording in progress. Recording in progress.
Oh, nggak ada suaranya ya? Ada bahasa Inggris.
Kita start 2:50 PM, Pak.
Please take a coffee break, Profesor Pamungkas.
Oke, thank you. Sorry.
Coffee break apa teh break?
Anything, anything, up to you.
Okay, thank you.
Water break. Okay, good afternoon, everyone. Today, we can start the session 8 in this conference. So we can start with the presentation. I am Efri Sandi from the Universitas Negeri Jakarta. Will be moderator for this session. So we can start with the first presenter, please.
Hello, I'm Isandin Lamri from the University of 20 August 1955 from Algeria. I'm the corresponding author of the paper titled "The Design of Novel Ultra-Wideband 4-Element MIMO Microstrip Patch Antenna for Sub-6 GHz 5G Applications." The aim of and objective of this paper is the design of 4-element MIMO antenna that covers the entire ultra-wideband and be suitable for the use for sub-6 GHz 5G applications. The configuration is investigated and improved and then fabricated and measured by VNA, and we have found a good agreement between simulated and measured results. At the early beginning, a sample PCDM 1-element antenna is developed on FR4 substrate. Then in the first step, which is the step 0, but in the first step, step 1, an inset is inserted at the bottom of the radiating patch. At the bottom of a radiating patch to achieve more matching and enhanced bandwidth. Then, in the second step, a rectangular slot is inserted into the ground, which yield an enhancement of the reflection coefficient, especially at higher frequencies. At the first and the third step, an etching on the upper part of the radiation patch is carried out, which yield an enhancement of the bandwidth at lower frequencies, as we can clearly see from the reflection coefficient graph illustrated here. Furthermore, the final step, which is the third step, this antenna is considered as a reference antenna for the 4-element MIMO structure. On the basis of the reference antenna, a 2x2 MIMO antenna is developed, where spatial diversity scheme is introduced to improve the isolation. The MIMO antenna has an overall size of 65 by 65 millimeter squares. The configuration is fabricated, and the prototype is shown in the figures appears in the slide. Then we have here the results of the MIMO antenna. Well, the manufacturer, the prototype is measured using a VNA. Concerning the reflection coefficient, it's observed that the bandwidth of all ports is less than ultra-wideband, especially at higher frequencies. This can be explained by the imperfection in the fabrication process and the introducing of SMA connectors, and the variation of FR4 substrate relative permittivity at higher frequencies. And for the isolation, it is well observed that is greater than 15 dB throughout the operating bandwidth. Regarding the radiation patterns, the MIMO antenna exhibit roughly omnidirectional radiation pattern in both the two principal planes at the frequency 3.5 gigahertz and 5.8 gigahertz, as seen in the simulated 2D pattern. Concerning performance analysis, ECC, DG, and CCL are calculated using measured S parameters throughout the bandwidth. The operating band ECC is less than 0.025 dB, which means that one element has a little effect on the performance of the other MIMO antenna elements, and as a result, the DG is near to 10 dB, which is the ideal scenario. For CCL, which measures the channel capacity loss, it is less than 0.4, as it should be. Include throughout this work, an ultra-wideband single element has been developed, and based on this reference antenna, a 4-element MIMO antenna have been considered, and the parameter involving S parameter, gain, isolation, ECC, DG, and CCL are studied and confirmed to be within accepted limits. Hence, this structure has been found that it fits well the intended sub-6 GHz 5G applications, and it's suitable for use for that purpose. Thank you very much. Thank you for your listening, and stay healthy. Thank you very much.
Okay, thank you very much, Mr. Istam, for your presentation. I think this is good presentation and also good result for your work. Okay, everyone, please, any question for the Mr. Istam, please, your time. Please, hands your, yeah. Okay, Mr. Yuyu, please, Mr. Yuyu.
Thank you. I want to confirmation for your the name of the antenna. 2x2 or 4x4 for MIMO?
2x2.
You can show your antenna?
Yes, yes, of course. Let me share the screen, please. Yes.
Yes, yes. I think this is the 4x4 MIMO, yes? Because
yes,
no,
yes, yes.
2x2, no, not 2x2. I think you're wrong. I think yes.
Yes, because actually, there is ambiguity between 2x2 and 4x4. I
because
use it.
You will face between the same antenna for MIMO, for time for MIMO. Yes.
Yes, this is 4 element. Yes, I agree with you. This is 4 element.
I think your name is wrong. Yes, I think.
Let me explain first.
Okay, thank you.
Yes, thank you very much, Mr. Gayo. In my previous work, I used the 4x4 for 4 element like this structure like this. I use this 4x4, but the comment of the reviewer, they said that this is not 4x4. You should correct. It's 2x2. Yeah. In the first draft, I write it 4x4 by the comment on this for this work. Yeah.
Okay.
I don't think perhaps when we comparing this structure with the, for example, matrix. Yes, it's 2 by 2. 2 rows and 2
2 by
columns.
2 is only two antenna, yes. 4 by 4, 4 antennas.
I think it's related with the
pen. You can face the same of the antenna 4 by 4. Yes.
Ah, yes, perhaps. Oh, well, it's we have ambiguity here. Thank you very much, Mr. Yu, for your comment. Yes, thank you.
Okay, thank you. Any others question? Please raise your hands. I want to remind of all the attendants. Please don't forget to fill the attendance in the chat room. This is the important one for our attendance. Okay, any others?
I am Mr.
Okay, please, Mr. Teguh.
Thank you, Mr. Isham.
Thank you very much.
Okay. I'm interested with your design and your realization.
Thank you very much.
It's about fixed antenna. I want to know what is the effect of on the bottom of the substrate. You are not use a full ground plane for the that's connector. What is the effect you make?
Well, let me share.
Sorry. What is effect if you use a full ground plane and with your design? That
yes,
is, I want to know. I want to know what is the effect. Thank you.
Yes. Let me share the screen, please. Well, this is the design. The first, the one element design here. As we know, for fully ground, we cannot actually achieve this wide band. In order to achieve the wide band, we have to use partial ground like this structure. For example, for result here, if we use full ground, we will take we will get a bandwidth of around 2 gigahertz to 3 gigahertz. Yes, only. But we are aiming by this work to achieve ultra wide band. For that, we have to use partial ground. Do you understand? This is a question, I think.
Yes. So the defected on the bottom of the substrate for the ground plane, you will make more large bandwidth for USB.
Yes.
For the ring of the UEB. Okay.
Yeah.
Yes.
That's it.
Yeah. You will make more large bandwidth like that.
Yes. This will make a larger bandwidth. Yeah.
Okay. Thank you, Mr.
Yeah, you are welcome. Thank you very much.
Okay, this is the second question. Any others question? I think we have around 8 minutes.
Lagi azan, Pak Efri. Lagi azan di sini.
Okay, if any others question, please raise your hands. Okay, Mr. Izam, yeah, I want to ask some question for you for the effect of the ECC parameter. As you know, for the MIMO, this is the most important parameter, to know about the relation between the element radiation. Can you explain for your work what the impact of the ACC for your 2x2 MIMO, please?
Yes. Well, the ECC. As you know, first of all, the ECC we can get the ECC from the radiation pattern or from the S parameter.
Yeah.
As we are intending to get calculated one from the measured result, we have take the ECC from as parameter. We have calculated the ECC as you ECC is a metric that measure the influence of each element in the MIMO structure on the other element. The higher the ECC, the higher this effect is. Well, for MIMO structure, we need to isolate the elements. So we have to minimize the effect of each element among the other. Well, because we are using spatial diversity, which gives enhanced isolation and minimize the effect of the element on the other elements. Well, we have get close to zero ECC, as you know, in the band and the ultra wide band, which is from 3.1 to 10. We have ECC under 0.0025, which is very low.
Okay, thank you, Mr. Izam.
Thank you very much.
Yeah. Okay, I think that's all, about.
Okay, can I show you the?
Okay, Mr. Yu, we have
I can
2
show
minutes.
the share for the sharing for the 4x4. Yes.
Yeah. Slide.
Sorry. Sorry.
Yes, Dr. Yu, yes.
Yeah. Okay.
This slide.
This
one. Okay. You can share, Pak. Mr. Isam.
Yes.
Okay.
Yes.
This one.
Yes.
You know.
Please.
You can see.
Not yet.
Need 4 time 4, yes. Okay.
Not yet, Mr. Yu.
Not yet. Yes. I didn't see your screen.
Thank you. Okay, thanks.
Mr. Yu?
Yes.
Please share the screen. I didn't see it.
Yes. Sorry. This is
No problem.
I think my internet is bad. Yes.
Okay. Okay, Pak Yuyu and Mr. Izam, I think that's all about this time.
Okay.
I think we can go for the next presenter. Yeah, the second presenter. Pak Yuyu, please to. Okay, thank you.
Okay, thank you.
Thank you very much. Thank you.
Okay, thank you, Mr. Izam. So we go to the next presenter, please.
Good Good afternoon, everyone. I am Shobhit Agrawal and currently a PhD candidate in the Department of Electronics, Electrical and Telecommunication Engineering, or DEI, which is also the city of the founder of radio, G. Marconi. And I'm currently enrolled in the University of Bologna, at the Bologna campus. So today I'll talk about our recent work, which is accepted in this conference, which is designing of a super wideband antenna, which has a postcard type shape, and it provides you the high BDR. So let's have the first look at the outline of the presentation. So we first introduce the microstrip antenna, the basic introduction about the microstrip antennas. Then we see the evolution stages of the antenna. Then we see the proposed antenna and its corresponding results. And finally, we conclude the presentation with some remarks. So, introduction of the microstrip antenna. As I believe that being an antenna engineer, you all must be aware of the microstrip antenna technology, but there might be some of my new friends joining this exciting world of antenna. So for them, I just want to brief it out. So a microstrip antenna in its simplest form is nothing but a 3-layer structure in which a radiating patch and the ground plane is placed on the either side of a dielectric substrate. The dielectric substrate is kind of a core part of microstrip antenna design and has the radiating patch and the ground plane on either side. There are some other technologies as well, where if I talk about the CPW technology, where the ground plane and the radiating patch are designed on the same plane. On the top side, you can say, and on the bottom side, it's nothing is available. There is no ground plane. And if it is a ground plane also available, it's a kind of a dual ground plane structure, which is commonly known as the CPW ground plane or ground CPW structure. So there are a number of technologies available, but if we talk about the simplest form, yeah, it is a 3-layer structure. So why to use the microstrip antennas? Okay, so there are numerous advantages. Number one is they can give you the high gain. They are light in weight. They are compact in size. They're easy to fabricate. The fabrication facility is quite easy. Okay, they have the planar configuration. You can achieve the dual polarization. I mean, you can have the linear polarization as well as you can achieve the circular polarization if you design accordingly. Okay, so you can achieve any kind of polarization as well. So these are some of the basic shapes introduced in the quite a long time back, where you can have a square patch or a circular or triangle, semicircular, and the ring, square ring, and number of shapes. So nowadays people have modified these shapes in n number of shapes. You can refer many articles. They have used these basic shapes into designing some of the beautiful antennas which are serving this world. So for this project, we have also employed a rectangular patch antenna. If I show you the basic structure, so the substrate, as I told you, is a quite crucial part. So here we have used a very low loss dielectric substrate, which is provided by one of the fabricators named as Rogers Corporation. So it is a Rogers RT Duroid 5880, which has a thickness of 1.57 mm and the relative permittivity of 2.2. As you can see, the 10 delta is 9 × 10⁻⁴, which is very less. It is measured at 10 gigahertz. So if I start out of the evolution of this antenna, in the first stage, you can see it's nothing but a simple rectangular patch antenna, okay, which is having a partial ground plane, but it does not have super wideband performance. It generally has a multi-band performance. Okay, so to have the better impedance matching, which is the criteria that we must have, the S11, the reflection coefficient should be less than 10 dB or minus 10 dB, I would say, sorry. So to have the S11 minus 10 dB in the entire range, we have modified this structure. In the step number 2, we have introduced 2 circular defects in the patch as well as in the ground plane. Okay. So by this, we were able to achieve quite a good bandwidth, but not completely. It was mismatched at 2 different points. Then in the final stage, we have introduced a stair type defect in the ground plane. And after that, we achieved a full impedance bandwidth, which starts from 2.75 to 30 gigahertz, which is, I believe, I think it is shown over here. Yeah. So as you can see from the black curve, it is resonating here and somewhat here. So it was for the rectangular patch. Then by introducing the defects, the red curve if you follow, so it has a bandwidth from somewhere around here to here. So it's also super wideband, but our intention is to have it from here until more than 30 gigahertz. So by introducing the stair type defect in the ground plane, we were able to achieve the desired performance as we wanted. So it is the final layout that we are presenting in this article. So here is all the parameters you can also see. So the size is just 20 by 20 mm. It's very compact size. Okay, and there's a stair type defect if you want to see. This is the clear picturization. I believe it was not so visible in the earlier slide. So here we have put the more visible configuration you can see over here. So the ground plane has 2 circular type defect and a stair type defect. Okay. Now this is the reflection coefficient that I have already shown you, but here is again reproduced to claim that the bandwidth is from 2.75 to more than 30 gigahertz. Okay. If we talk about the gain and efficiency, the maximum gain we achieved was 5.56 dBi at the 29 gigahertz, and the average gain, I'm sorry, my friend, I forgot to write over here, but the average gain is around 4 dBi in the operating range, as you can see from here. Okay, and average radiation and total efficiency were found to be 75.77 and 74.22%. So it is actually a very high efficiency antenna, and to achieve the high efficiency throughout the operating range is quite a difficult task in the super wideband antenna. So yes, in this sense, yes, this antenna is quite good. And in the title, we discussed about the BDR, which is nothing but the bandwidth dimension ratio. So what is bandwidth dimension ratio? It's actually the percentage bandwidth divided by the lambda L into lambda W, which is where lambda L and lambda W are the length and the width which are normalized to the wavelength at the lowest operating frequency. So in this sense, the BDR value of this antenna is quite high, which is compared to that other literature, and I believe readers can refer to the article for the more information. If you talk about the surface current density, you can see that the current is concentrated near the feed line at the lower frequency ranges. As we move to the higher frequency ranges, the current is starting distributing uniformly over the entire patch. Due to this, since if the current is distributed uniformly over the patch, over the radiating structure, then it enhances your gain performance by the antenna fundamentals. We can understand this. So that's why that as the frequency increases, the gain also increases of this antenna. Last we talk about the radiation characteristics. So you can see that the radiation characteristics are almost omnidirectional at the lower operating frequencies. At higher, yes, there is some problem in the YZ plane, but it's just one null and some ripples, which are present due to excitation of higher order modes. So, but in the real life applications, yes, they do not have much impact on the antenna performance. So we can mitigate these effects. As a conclusion, I would say highly efficiency miniaturized super wideband antenna is proposed in this article. The antenna has an impedance bandwidth of more than 27 gigahertz. and the peak gain of the antenna is 5.56 dBi. So high value of efficiency, as I already told you, that it's quite a tough challenge to achieve the high efficiency throughout the antenna operating range. It's a challenge, and we were able to achieve a good efficiency value for this antenna, and because of this we claim the candidacy of this antenna for the super wideband operation. Thank you for your time. If you have any query, please do not hesitate to tell us.
Okay, thank you, Mr. Sobit. It's interesting presentation. So please, question for Mr. Sobit.
Yep. Good morning, everyone. At my place, it's the morning, and good afternoon to you who are present in it, Indonesia.
Okay.
It's morning in Algeria too.
It's a small world now.
Please raise your hand.
Sorry?
Any question? Please raise your hand from the audience. Yes.
Okay, thank
Mr.
you,
please.
Dr. Every. I want to ask the simple question. Yes.
Yep.
I think you can make the super ultra wideband. Yes, super ultra wideband. Yeah, maybe up to 70% bandwidth. Yes.
Mm-hmm.
What for your antenna? What your application of the antenna?
Okay, so it increase it. You can imagine any application which starts after 2.75 gigahertz. For example, you can use it for WiMAX, for WLAN, WLAN 5.2. Yeah, then you can use it for the satellite downlink communication. Then I mean the frequency ranges which are beyond the 2.75, you can use it for that. That's quite a general antenna, and it's a I would say it's a starting prototype. As of when we designed this antenna was quite bad, and we submitted to this conference. The current status of this antenna is that it is being investigated for the microwave imaging applications. That's kind of a thing I'm revealing to you. So maybe for microwave imaging.
The GPR maybe ground penetrating radar can to use.
Ground penetrating radar
can use.
No, I'm not sure about that. I'm sorry because I'm not familiar with that that thing. Really sorry for that, because my more of the work is in now. I'm focusing on the biomedical applications. So we are trying to detect the breast cancer using this SWB antenna. Because as of now, if you go for the literature, you will find the people are doing it for the UWB range. That is up to 10.6 gigahertz. But we are trying to expand it to the SWB range, so that the antenna could be more miniaturized, and I mean we can do it more efficiently. So, yeah.
Okay, thank you.
Most welcome.
Okay, thank you, Mr. Yuyu and Mr. Sobit. Any other question? We still have 8 minutes.
May I ask a question, please?
Yeah.
So in your paper, in your title of the paper, you mentioned bandwidth dimension ratio.
Yes.
So what is it actually? Because it's actually new, new for me. And can you elaborate more on the bandwidth dimension ratio? Thank you.
Yeah. So let me share the screen, because it will be better if I can show you in the article, I believe. Right. So can you see this is the article? Are you able to see my screen?
Yes.
Okay. So if I'm not sure if I have mentioned it. Okay. So you know how to calculate this percentage bandwidth?
Yes.
Okay. So percentage bandwidth and the wavelength that you calculate according to the lowest operating frequency of your antenna in this case, which is 2.75 gigahertz. So if you normalize your length and width of the antenna according to the wavelength at 2.75 gigahertz for this particular antenna, because the PDR depends on antenna to antenna. In a general form, if I define it, it's a kind of a per unit area bandwidth. So an antenna which is giving you a bandwidth in a unit area. Okay. So for this particular antenna, the size is 20 by 20. So you calculate a wavelength at 2.75 gigahertz, which is the starting frequency of this antenna, which comes roughly around, if I calculate at 3, it comes around 100 millimeters. So you normalize this length and width with the wavelength, which is 20 by 100 equals to 0.2. So the size becomes 0.2 into 0.2 lambda. Then you divide 166.4 divided by 0.2 into 0.2. That gives you in a result of the BDR, which I believe in this article we are receiving at 5136.
Okay, so BR is a common common term right now.
Yeah, it's a general term. If you refer to the super wideband antenna, you can find this term quite oftenly. Yes.
Okay, thank you.
My pleasure.
Okay, any others question? We still have time.
I believe I was able to convey my message to the attender.
I have a question, please. Yes.
Yeah, please, Islam.
Yes, thank you very much for your presentation. Well, I think if you will do the MIMO configuration for this antenna, yes, you will have a problem with isolation.
Exactly.
As you know, yes.
Yeah.
As, I think for further work, you should do the MIMO selection for this antenna and work on the isolation, which is very challenging for ultra wideband and super ultra wideband.
I agree with you, Islam. Actually,
yes,
my last two projects were related to the MIMO isolation and enhancement, and we have used quite decent results. We have received quite decent results using the decoupled structures, using your meta surfaces. Okay, and so these are the things we have done. For this particular antenna, this was designed for the biomedical applications, to investigate biomedical application in the super wideband range. But yes, your idea is also appreciated. We would try to explore that direction.
Yes, thank you very much. It's a good presentation and work. Thank you.
Thank you. Thank you.
Thank you.
Please, if anyone has any question, please let me know. Or the suggestions like Islam.
Okay, I think I have a question, Mr. Sobit. Yeah, it's our 3 minutes about the your structure. Yeah, how you to calculate like the LD or LG. Yeah, I still not you not show in your presentation. So how you to calculate the dimension of like LD parameter or LG parameter? Thanks.
LD and LG. Okay. So there is no definite rule for calculation of this parameter, number one. These are achieved through the iterative optimization. We have done the optimization through the iterative simulations. So there is no definite rule we have applied, no definite formula. Yeah.
Okay. Okay, thank you, Mr. Sobit.
Thank you, Eric.
Okay, thank you. I think that's all about this session, this presentation. So we go to the last presentation in session 8. The presenter from Mr. Muhammad Fadel Diagana. Okay, please for the third presenter.
Hello everyone, my name is Mohamed Farel Jagana from Sheikh Anta Diop University of Dakar, Senegal. We are going to present to you with Sirin Birage, a study on patch antenna gain improvement with mathematical structures. The presentation follows this plan. After the introduction, we will talk about our reference patch antenna design. Then we discuss about mathematical unit cell, the cell design and the selection. After that, we will talk about the inclusion of the antenna with mathematical structures, first by 2 arrays, then 3 arrays, then with some optimization. Patch antenna are used in many geometry and in many configurations. For example, they can be used in linear polarization and in circular polarization. But as any device, they suffer from some limitations, and these include a low gain, a narrow bandwidth, and surface waves losses. Mathematical can be used to solve those problems, and they can address it individually. For example, we can use mathematicals to solve antenna gain limitation. We also can use mathematicals to solve antenna bandwidth limitation and to create, for example, wideband antenna. But one important thing is that with mathematicals, we can keep the solution planar. It means that we can print the antenna in the same substrate. To analyze patch antenna, there is mainly two models, the transmission line model and the cavity model. For circular patch antenna, the cavity model is more suitable. And the first step to design our antenna is to get the effective radius. So this can be done by having our design frequency, the substrate height, and also the relative permittivity of the substrate. Once we have our effective radius, what we need is the input impedance. As we are using pin feed antenna, we know the exact position of the feed point. So this is done in two steps. First is to get the edge impedance of the patch antenna, and second, we get the input impedance, and we can choose it so that we have a good matching for the antenna. So once we get the radius and the feed point, this is the reference design for our patch antenna. And we have here the bottom view in figure 1 with the position of the feed. And for the patch antenna, this is the results. For example, for the reflection factor, we have minus 25 dB. And for the curve of the maximum gain, we see over here that we nearly reach 4 dB for the maximum gain. And this is the curve of the directivity. And over here we have 6.41 dB for the main lobe. So once we get the antenna with the design characteristics, the next step is to choose a mathematical unit cell to improve those characteristics. And over here we choose a reference mathematical unit cell, the split ring resonator, and we have mainly two configurations for the split ring. We have the circular one and the rectangular split ring resonator, but both of them exhibit a Lorentzian tip response. But for our work, we choose the circular split ring resonator. So after choosing the split ring, the next step is to adapt the cell dimension to our needs. For example, over here, for the split ring, we have a frequency band where we have negative permeability. So we want to do such that this frequency band correspond to the frequency of the antenna. So what we are doing over here is we are scaling the dimension of the unit cell. We are dynamically changing the dimension of the unit cell, and for each scaling factor we have the response for the unit cell. And over here in green we see that with a scaling factor of 1.2 we have a negative permeability in our frequency band. So once we have the scaling factor for the unit cell, this is the specified parameters for the scaling factor. We have a negative permeability of -2.21. We have a transmission factor of -18 dB, and we also have a reflection factor of -1.22. So the transmission factor is low, but the reflection factor is very high. So the structure is mostly reflective, and we have an refractive index of 1.3. So there is many ways to improve antenna characteristics using metamaterials. We can use near-field parasitic structure, a study by Zayevskovsky and Kibble. And we can also use reactive impedance substrates, a study by Mozali and Sarabandi. And the basic idea is to create a frequency selective substrate. So we use the second approach. We want to create a frequency selective surface using metamaterials. So the next step is to choose the best configuration to match the geometry of the antenna. And we have here the corresponding design with the main radiator of the patch surrounded by two arrays of unit cell metamaterials. And the result that we get over here is a better matching for the antenna. For example, this is for the reflection factor. We see that there is an improvement compared to the reference patch antenna. For the reference patch, we had -25 dB, and for the new one, we have -28 dB. And for here, we have the curve of the maximum gain. And also we see that over a frequency of 400 megahertz, we have an optimization compared to the reference patch antenna. And for the directivity of the new structure, we see that there is also an improvement. We have 7.57 dB for the directivity. So over here, we see that it is like we are creating around the patch antenna waveguide. So the structure with the patch antenna over here, it is like we create a planar waveguide around the main patch antenna. So after that, we are performing some optimization by adding a third layer of metamaterial unit cell around the antenna. And what we have is a better directivity. We have now 7.67 on directivity compared to the reference patch antenna. There is an improvement, and compare also to the patch antenna with two arrays of metamaterials around. So this figure gives a summary of what have been done. The line in blue is the reference patch antenna, And over here we have patch antenna with 2 arrays of metamaterials around. And in orange over here we have patch antenna with 3 arrays of metamaterials. So this is the first optimization. But the 2 last curve is where we add a rounded ground plane. So we have a wider band of gain optimization. For example, this can be used in wideband antenna to have improvement in gain. And this table summarizes what we have for 2 arrays of metamaterials around the antenna, a frequency band of more than 400 megahertz. For 3 arrays, we have an optimization band of more than 700 megahertz. And for 3 arrays with rounded ground plane, we have an optimization band of nearly 8 megahertz. So the benefits of this work and the use methodology is that we have here an accurate method to choose the cell dimension. We also have a planar-like waveguide for patch antenna. And we reach an improvement of more than 1.7 dB over the reference antenna with simple split ring resonator. And for the optimization of the gain, we have a band of more than 800 megahertz. So for the perspective of this work is to begin first the fabrication and the measurement process. And we can then further improve the antenna characteristics by using other negative permeability materials. So one thing to explore is to combine linear negative permittivity and permeability to try to have better improvement in radiation characteristics. Thank you for your attention.
Okay, thank you, Mr. Muhammad Fadal. This is a good presentation. So please, attendants in this room, if any question, please raise your hand.
Can I ask?
Any question?
Yes, Dr. Afri.
Okay, please, Mr. Sobit, it's your time.
Yeah, thank you for your presentation. Can you please comment on the polarization effect because of the SRR? Because I see that you are using the split resonator with a cut in between. So can you comment on the polarization effect? Have you studied the polarization effect on the antenna because of this SRR structure?
Thank you for your question. Let me present. Let me share my screen, please. Sorry, but actually we have not. Yeah, I'm trying to share my presentation.
You cannot share screen?
Yeah. I'm sharing now my screen.
It's okay. You can explain like that. It's not a big deal. I just asked if you have started. Oh, okay.
Okay. So actually, with the SRR, we have not studied the implication of the change in circular or linear polarization. We just study the impact of the SRR in our base antenna. But I think that it is a good point to study for the next work to be done. So thank you.
Can you go to please slide number 11?
11.
Right. Okay, just below that. Yeah, this slide. Can you use this slide?
Okay.
Yeah.
This one?
Yeah, it's okay. It's okay.
Okay.
No. It's not 11, no? Which one is 11? Yeah, this
one. Yeah.
So I mean, your size has been increased tremendously because of this SRR, right?
Yeah.
And you are getting just 1.7 dB of improvement. What are your views about that? I mean, is it worth increasing this large size with just improvement of mere of 2 dB only?
Yeah. The increase in size is, for example, to be able to have more metamaterial unit cell around the main radiator. But this, for example, for this study, it is a base SRR. It is not an optimized SRR. So that, for example, with different SRR, we can have better performance. So this is just a reference to be able to improve the antenna. But in the next study, we will change, for example, the SRR to a new one that can improve better the performance of the antenna.
And how did you calculate this distance of 14.337 mm? It's quite precise.
Yeah, the size. Yeah.
How did you decide this distance?
Distance of 66.
No. The distance from patch to this meta surface.
Yeah. This is just, for example, to avoid
Not this, my friend. The 14.337, 14.337 mm. Yeah.
For example, over here, we have just below the antenna, the ground plane.
Okay.
So one thing is that we want to avoid to have the metamaterial upper to the ground plane, because when the metamaterial are upper to the ground plane, nearly we are no effect on the gain improvement. So what we do is that we avoid to have the metamaterials upper to the ground plane. That's why we have this distance.
Oh, okay, but okay. Okay. My last question is on slide number 14. If you can go.
14.
Yeah, here I don't understand this concept. No, that the last column confuses me.
Okay, this table.
Why the bandwidth decreases when you increase the distance?
Yeah, here is just is the size of the ground plane. For example, over here we have a ground plane with 18 millimeters, and over here we have a ground plane with 20 millimeters. But the effect is that, for example, for those two ground plane, this change, for example, the bandwidth improvement. For example, for a ground plane of 20 millimeters, we have 1.7 dB. But for a ground plane with 18 millimeters, we have 1.6 dB. So it is just to have a compromise between the ground plane to choose the best configuration.
Thank you, Mohammed. Good luck. Good luck. That was a nice hearing you.
Thank you.
Okay. Thank you, Mr. Sobit, for your question and discussion. So any other question? We still have 2 minutes. Any other question? Okay, Mr. Fadel, Muhammad Fadel, I have one question. 2 questions actually. The first is, so you also give the 3 layer of your design. So what the impact if we are using a 2 layer and compared to the 3 layer? So what impact actually in your design?
Okay. For example, when we use 3 layer compared to the 2 layer, we see that we have an improvement on the band optimization. For example, with 2 layers, we have only 400 megahertz of optimization. But when we add a 3rd layer, we see that we have more bandwidth in the game optimization. We have nearby 800 megahertz. We have nearly 2 times the gain improvement compared to the 2 layers.
Okay, so this is the maximum 3 layer, yeah, you have done for this study.
Yeah.
Okay. Okay, thank you, Mr. Muhammad Fadel Diagana. I think our time is finished. So thank you very much for all attendance in this session. I am moderator for this session, Efri Sandi from Indonesia. Thank you very much for your kind attention. Thank you. Good day.
Thank you, Dr. Efri.
Thank you.
Thank you very much. Thank you.
Recording stopped. Recording in progress.
Ladies and gentlemen, now that we have finished 9 sessions of paper presentations, I would like to thank to all presenters and participants for their active participations during the presenter sessions. Now we have come to the third keynote speech by Professor Marco Di Renzo from Paris-Saclay University, France. This session will be moderated by Dr. Agus Subekti. First, I would like to introduce Dr. Agus Subekti. He received his Bachelor of Engineering and Master of Engineering in Electrical Engineering from Institute Technology.
Recording stopped.
In 1998 and 2001 respectively. He then joined Nakajima Laboratory,
Recording
Tokai
in
University,
progress.
Japan, as a research fellow until 2004, prior to conducting his PhD in Electrical Engineering and Informatics from Institute Technology Bandung. That is completed in 2016. After that, Dr. Agus Subekti joined Indonesian Institute of Science, or LIPI, or now known as BRAIN. His research interests include signal processing, wireless communication system, machine learning, and artificial intelligence. Please welcome Dr. Agus Subekti.
Thank you, Ms. Ardita, for your introduction. Ladies and gentlemen, distinguished participants of this international conference, it is a great pleasure to meet you all, and we will have, in this plenary session, we will have a presentation from Professor Marco de Rinso. Let's introduce Professor Marco de Rinso is from Paris University, France. He will give a talk about reconfigurable intelligent services for wireless communication. Professor Marco de Rinso finished his laurea cum laude in electrical engineering from University of L'Aquila, Italy in 2003, and he got his PhD in 2007 in electrical engineering from University of L'Aquila, Italy, and in 2013 he got the Doctor of Science degree from University of Paris, France. Currently, he is a professor at CNRS, Paris, and he is also editor-in-chief in IEEE Communication Letters, and he is also visiting professor at Aalto University, Helsinki, Finland. His research interests encompass in wireless communication, RIS, MIMO, and machine learning. Professor Marco de Rinso, welcome to this international conference. You have about 35 minutes to present your lecture. Please, the time is yours.
Okay, so thank you very much for inviting me. It's a great pleasure to be with you. I'll try to also share my screen. Okay, so as I was saying, thank you very much. It's a great pleasure, to be here with all of you. So I will try to give you some kind of introduction of the research activities that I have been doing with my group in France. And recently we have been working on this technology, which is called reconfigurable intelligent surfaces. And I will try to give you a short overview here in almost more or less half an hour. So first of all, where we are, this is basically where we are, the new campus in our university, which is now called the Paris University. So we are not that far from Paris downtown, not really in downtown. So we have some laboratory of excellence in wireless communications within the university, where we develop also these research activities. And also we have a quite strong PhD school in information and communication sciences. So, if you are interested in any opportunities in France, please feel free to get in touch with us. So I will try to touch upon these points today, and not all of them, because there is no time to do that, but maybe I will just give you a few references. So I will introduce the concept of programmable radio environments, smart radio environments, then this technology, RIS. I will just show you a list of papers that we recently wrote with many colleagues to give you some pointers on what research topics can be addressed. And I will discuss some open research issues. So I don't really think that I'm going to go through this part because it will take much more time, but I will give you a reference and the problem that we try to solve. Of course, I'm happy to take any questions during the presentation and at the end. Okay, so what's the idea? That is this. This is a wireless network, a simple one. So one base station here, one mobile terminal here, one large building in between, so there is no good line of sight. In such a situation, what we can do is to try to communicate through the multiple reflections that are in the network. But usually these reflections arrive at the mobile terminal out of phase. Therefore, when they recombine, they may not give us a good signal quality. Of course, we may try to use multiple antennas at the transmitter and the receiver in order to improve that, but fundamentally we cannot control what happens on the objects. Object 3, object 2, and object 4. Of course, this we cannot do anything here because there is a strong blockage. So the idea of this programmable radio environment is to endow this network, to distribute throughout this network some metamaterials, more precisely metamaterial surfaces that are attached on the walls, for example, of these buildings, if we are considering an outdoor scenario. And these metamaterials have the capabilities of changing how the electromagnetic radiations are reflected, for example, from the wall. So as they all reach the mobile terminal in phase, and you can also change the direction of reflection, for example. So therefore, you move from an environment where you adapt to the wireless propagation to a new environment where you can change how the waves propagate throughout the environment. And this is the reason why it's called programmable wireless. So how can we make this possible? The technology enabler to do that is called the RIS, or there are many other names. But there are fundamentally three main terms here. One is surfaces, which means that they are not volumetric structures. So one of the dimensions is much smaller than the others. They are intelligent, which means that if you compare it with a regular wall, you can change the direction of reflection, for example. And they are reconfigurable, which means that you can change the response over time, depending on the network conditions. That's the reason why we call them RIS. So we can do many things with this RIS. So you can reflect your signal in an anomalous way. You can also transmit the signals if you think that this is a window, for example. Then I will give you a concrete example. You can even try to reduce the interference in some places by minimizing the amount of the waves that are irradiated. Or you can do many other things. So an RIS looks like this. As I said, it's a surface. So the thickness in the specific case is very, very small compared to lambda, much smaller with respect to this size and this size. On this surface, you have radiating elements that here are shown with this H of different sizes, plus electronic circuits that make it reconfigurable. So if there are no electronic circuits, you can change the reflections of the surface. With the diodes, you can change the on-off state of the diodes, and depending on the combination of all diodes, you can adapt the response. So one of the most studied cases is that of a surface where that reflects your signals. So here the idea is that you have a transmitter that illuminates your surface from a given direction. And then in principle, if this surface is not reconfigurable and is not intelligent, you will get a reflection towards this direction, according to Snell's law. So this is not useful for this receiver, which can be your intended receiver. So what you would like to do is to electronically steer the signals towards this receiver. And you want to cancel, you want to null these reflections and all possible reflections that you may have in order to have the max efficiency towards the direction that you want. If the receiver moves, you want to track the positions and steer the signals where the receiver is. What are the main characteristics of this surface? So some of the main characteristics are we don't want to use power amplifiers in these surfaces because they are expensive, they consume a lot of power, and we don't know to do that. We don't want them. We don't want to have digital signal processing on these surfaces for the same reasons. And we want to keep the structure very simple. So we don't really want to multiplex signals by using multiple radio frequency chains like we do in conventional MIME. So these are positive features, but also challenges to solve in order to make this work. Because as we'll see in the following slides, if you cannot amplify, it means that your coverage is relatively small. If you cannot go to the digital domain, it means that you cannot remove noise, and therefore you cannot do many sophisticated signal processing things. So I will go back to this point to these points in the next few slides. But this is what, in principle, an RIS should be. Everything is done at the electromagnetic level, if you want. So, of course, this application that I showed you is a sort of a relay type application where the surface is being used as a sort of relay, but a relay without amplifying the signals, without digital signal processing, without multiple RF chains. And we will see this later on. But there are other applications. So another application is to use the surfaces at the transmitter side. So in this case, you have that the surface is very, very close to the transmitter, is part of the transmitter. You can always illuminate this surface in the near field now of the surface. And then each of the scattering elements that I mentioned before can independently reflect your signal. And this reflection that you get is a sort of QPSK modulation that you apply. And therefore you multiplex n PSK signals together. And this gives you a MIME, fundamentally. One possibility, one example is this one, where you may have a panel with different tunable elements, which we call macro cells here. And then you have, of course, all this is your transmitter. You illuminate this surface on the near field, and then you control the elements that are on, which are in green here, with a bit stream that you want to transmit. This can be, for example, 2 bits, something like that. And then once you decide the phases that the elements that are on, you can also adjust, optimize the phases to maximize the power where you want. So the bottom line is that if you want to transmit the symbol 1, you switch these elements in green on. If you want to transmit symbol 2, you switch these other elements on. And this is a mechanism of encoding information without using multiple RF chains. So another application is ambient backscatter communication that we have been working on quite a while. And here the idea is that you have a tag, and this tag is illuminated, and it has something to transmit. A way to transmit what the tag wants to transmit is that the tag re-radiates the signals that illuminates the tag, and depending on the information that you want to transmit, 0, 0, 0, 1, 1, 1, 1, 0, the tag changes the radiation pattern through these metamaterials. And this gives you an implicit way of conveying information, extra information. There are many other applications, but these are 3 popular applications for these surfaces. So now, what are the main novelties and challenges of this technology? So if you look at it from the point of view of info theory and comm theory, what we usually do is to optimize a transmitter and receiver or encoder and decoder, and this is fixed. So this is what the transition probability is. So this is the channel that is fixed. With these surfaces, you can modify also these probabilities. So now you optimize encoder, decoder, and also these probabilities. Therefore, you have more degrees of freedom for system optimizations, and this is called optimizing the environments, because you adapt the environment at the same time with your encoder and decoder. So this is a co-design. But you may not only shape the environment, optimize the environment, but as we said with backscatter, ambient backscatter communications, is that you could also shape the environment and at the same time encode the information on the different configurations of the surface. So you can do these 2 things together, and this is proved to be information theoretically optimal under some conditions. But there are many open issues because with these surfaces, we reformulate completely the problem in terms of information theoretic formulation We don't know exactly what the capacity is, especially in a multi-user environment. This is not known. So there are many challenges basically to solve. From the signal processing and optimization point of view, the main point is that if you have this RIS, of course you have a transmitter, receiver, and then you have this RIS. Now, assume that the RIS does not exist. What you can do, as we said, is only optimizing the receiver, the transmitter jointly, and then you cannot do anything. This is the given. This matrix is still there. It's the response of this surface, but you cannot control it. So you need to accept what there is in between here in black. If you plug an RIS in between, you open this channel, this product channel, and somehow you have three variables for optimization, which gives you more degrees of freedom. But there are fundamental problems. One is that W, theta, and Q are jointly coupled. Therefore, the optimization problem is complex. And the dimensions, the size of this matrix is very large. Therefore, the optimization algorithms need to be scalable. The other main problem is that to be really optimum, you need to know what G is and what H is, so what the channel is, if you want to be channel state information optimization. But the point is, how can you estimate these channels on the RIS if the RIS has no digital signal processing units? Therefore, people are studying many optimization techniques that allows us to overcome this. So if you look at a typical problem formulation, which is very, very simple with respect to the actual functionality, the actual behavior of this surface, usually you end up having this problem formulation where you want to maximize, for example, your rate as a function of W, Q, theta. And then, of course, I mean, your pre-coding vector Q belongs to a given set, feasible set, W the same, and also theta. One of the typical assumptions of theta is that the amplitude, for example, is equal to one of these reflection coefficients, and the phase belongs to a discrete set. So this is a non-convex optimization problem, which is pretty difficult to solve. So, and this problem formulation does not account for the physical implementation of the RIS, or at least only in part. Another problem, which is maybe one of the research topics that I'm currently most interested in, is that we always design the communication systems by using information theory, which is a very good tool, and but this is a mathematical tool. As a mathematical tool, it's very powerful. It gives us a powerful way for abstracting complex system models, but we lose completely the physical aspects of the transmission, the concept of power, and so on and so forth. So now there is an effort in wireless communications to develop what we call the physically consistent networks, physically consistent wireless systems, where we either depart from electromagnetic theory or from circuit theory, or maybe a combination of both, in order to try to include the fundamental physical characteristics of advanced technologies such as RIS. Therefore, we need to go a little bit beyond the mindset that we usually have, where in each device we take the signal from RF, we go down to baseband, then we do digital signal processing, and then we go up. So that's completely different, and we need to adapt our models to do that. So now, let me just give you in a couple of minutes an idea of what there is around on this research topic. So in Europe, I'm more familiar with Europe, but similar things can be said for other countries. But there have been quite a large number of projects, European projects now funded so far, which are collaborative. So if you sum up all the budget put together from Europe to work on that, there is more than 20 million euros in the next 4 years, more or less, that will be used to do research in this field. And there will be a lot of experimental activities as well. So within the IEEE, especially Comm Society, there are many activities. So just to mention a couple, we are gonna have a special workshop at ICC 2022 next year We are going to have also selected areas in communication symposium at Global next year. It's the first one, the same for ICC 2023. So there are plenty of opportunities to contribute and a lot of interest. So one of the main things that we are trying to do is to see what role this technology can play in future telecommunication standards. So we recently established an industry specification group within the European Telecommunication Standard Institutes, and we created this group in order to understand a little bit how we can help providing guidelines on the standardization of this technology. So these are serving as the vice chair for this group. Is to try to give a definition of what an RIS should be, and one of the key points that we try to emphasize is that is truly a new. The main aspects is that each response can be adapted to the propagation environments through appropriate control signaling. So we cannot ignore that we need to send the command signals to the surface to be able to adapt its response to the network conditions. One of the other things that we try to do is to try to compare a little bit this technology with other technologies, similar technologies, even though this is never simple to do, because they are completely different and from different point of view. So it's very difficult to compare, but if we should basically just say some main differences between an RIS and other technologies, we could say that an RIS has the characteristics of being intelligent and being reconfigurable. Those are the two key points. Therefore, with respect to a regular surface, it cannot be completely passive because you need to have some electronic circuits in there. So a surface is completely passive. You cannot change the response. It's not intelligent. An engineered surface, you can change the direction of the irradiation, but you cannot change it. So once you design the surface, you cannot change it anymore. So it's a sort of non-reconfigurable structure. One of the closest technologies for sure the repeater, but in the repeater you have in any case active components and you amplify, which you don't want to have in an RIS. Therefore, the difference is even more important with a relay, where usually you also apply some digital signal processing capabilities, which have also digital signal processing capabilities. And of course, massive MIMO gives you the best flexibility, maybe the best performance, but it's relatively complex and power hungry. So if you are interested in more information on this technology, of course, I mean, you can consult this website, which is the website of this ISG. You will be an overview of the things that you have been doing, and then I conclude. So one of the main things that you have been studying is the channel model, or more precisely the path loss model of this RIS, of a link where there is an RIS. So the idea is to understand how the power decays when you illuminate the surface and then you receive, I mean, the signal that is scattered, radiated from the surface. So we developed a quite nice analytical model. We are developing other ones which have pros and cons. But if you really want to know and to have a model for link budget analysis, this can be a good reference to start from. The work is not completed. I mean, there are many more things to do. We also try to characterize how robust this link, RIS-aided link, is against fading, if you want to make it very robust. And we managed to get a nice scaling law that says that you can make the fading fluctuations on this link as small as you want, and so you can make the channel as deterministic as you want by increasing the number of elements on the RIS. And in fact, you can see that this is a parameter, the amount of fading, that tells you how robust, how stable, how robust against fading your link is. And you can see that if it's very small, if it's 0, it means that your link is deterministic, which is good and in some cases, if this is what you want to do. We did also a lot of work in developing efficient optimization algorithms. As I said, it's a key point, and to study where you should put the RIS. It's better to put the RIS here, it's better to put the RIS here, or it's better to put in the middle, as we usually do with relays. Well, it turns out that it's better to put the RIS either near to the transmitter or near to the receiver, because this really depends on the path loss model. So we are doing quite a few things, and maybe another things that I want to say before sharing with you a couple of new things, then is that most of the people are looking at using the RIS to shape the channel, so to adjust the response of the channel, what we call channel shaping, but not to use it for encoding information. Well, this gives you good performance, but it's not the optimum that you can do from the information theoretic point of view. So we prove that from the information theoretic point of view, what you should do is to basically jointly encoding data on the data X that you want to transmit, plus the optimal, plus the phase response of the RIS. So here you only optimize on the probability of emitting X, the data that you want to transmit. Here you optimize on joint probability of X and Y, X and theta. And this basically gives you a boost in rate, okay? So as I said, we are now working truly a lot on the circuit-based representation and modeling on the RIS. Now this would take maybe another talk, but we are actually trying to develop new models for RIS, new channel models for RIS that mimic a MIMO channel, but departing from circuit theory. Viewing this system as a circuit and applying techniques from circuit theory in order to develop these models. And we have used also them a lot for optimization, and we found quite good performance. So we managed to develop a model that departs from the circuit theory, and then we use it in communication, signal processing, in optimization. We plug it into an actual network, which is a MIMO interface channel, and we manage to apply some optimization algorithms for optimally configuring the RIS. And we have actually shown that in some cases there is a huge gain under some conditions. Okay. So I need to stop in a while. So I wanna just skip some of the things because I have a lot of material. But if you are really interested in I want to tell you three things. One is, if you are really interested in the issues of channel estimation and optimization at the same time of the RIS, we did quite a lot of work with many colleagues here, and on an approach that is now known as a 2-time scale design. So we didn't introduce the technique, but we studied it a lot, which basically tackles a little bit the issue of channel of acquiring channel state information, which is a critical point in the RIS. And this technique foresees that you optimize the RIS only based on statistical channel state information, and then you optimize transmitter and receiver based on instantaneous channel state information. So this give us a very good balance, a very good trade-off in terms of complexity, overhead, and performance. This is a very long paper. It's more than 70 pages, I think. There is really a lot of derivations, etc. But it's a nice reading. So there is also a very good state of the art. So you can have a look. I mean, if you are interested, as I said, it's really an effort with many people. Yeah. Another things that I want to tell you is, okay, if you now Google this RIS or similar names, you will find hundreds of papers. Okay. So I mean, just in a few years. So what a PhD students could do now. A PhD students who want to do a thesis on this topic, so what they should do. So there are many open problems really to solve. So there are more open problems to solve than problems that have been solved. I think that over the last couple of years, we understood what the problems are, rather than providing true solutions to the problems. Therefore, I think that there is really a lot of things to be done. So if you like implementations, if you do hardware, implementing these surfaces, building prototypes, doing measurements, it's not trivial at all. There is a lot of stuff to be done. channel estimation algorithms, optimizations, interference management. And then, I mean, I will show you now a paper that I didn't put into the slides because we submitted it yesterday. So, I will show you just some figures now in a while, but there are no real ray tracing simulators and system level simulators for this. So I will show you something that we have now. One thing before I go to this paper, many people ask possible use cases where these surfaces can be utilized. We have been discussing about the possible use cases, to be honest. At the moment, it's not clear at all, but I found a couple of things that very interesting from Docomo, for example, which is at the forefront of research. I mean, in this field. And basically, I took these pictures from this Docomo open house in just this year. And the idea here, for example, is to use this a couple of RIS. If you're in the millimeter wave frequency, it's very difficult, for example, to get to have outdoor to indoor communications. So what you can do is that you have here a base station. Then the signal needs to go through this window. This window is a metasurface. It's a transparent metasurface. That is capable of focusing the signals where you want, as you can see. Okay, it's focused here, the signal. It focuses this towards a point where you know where this point is. This can be a surface, another surface. And then this surface radiates and illuminates the room. And this gives you an efficient way of doing outdoor to indoor communications at frequencies that is very difficult. Another thing that I really like is the possibility of having these transparent surfaces because you can put them anywhere. Without really spoiling the appearance of your environments. So you can control the environments without really making it bad. Nobody likes to have these huge base stations, I mean, around, in the cities and whatever. So here you can really use these reflectors, which are transparent and gives you this nice functionalities. So now I want to give you an example of things that give me just a second. I stop sharing because I need to find I just tell you this and then I stop. So. Yes, so let me go back to here. Okay, so you should see this. You should see now this my internet here, and so the good point is that we submitted yesterday basically this paper on a system level analysis in collaboration with some colleagues, and I want to show you what we did because if you're really interested in understanding the game, so this is really a system level study that is extended to an entire city. I mean, it's not an entire city, but it's a fraction of a square kilometer. Okay, and this is done in collaboration with some colleagues from Huawei, Sweden, who have available this very sophisticated system level simulator, which was improved with RIS, which was where we added RIS. So an idea of the simulator is this one. Oops. Where basically you can have a very large city-wise deployment. And then you can see here where we can have different points where you measure the received signal without RIS and with RIS. And the interesting part of the point that we did a lot of simulations, a lot of studies in a city by considering an actual deployment, which is the city of Hangzhou in China. The area covered is 800 meters times 800 meters. We consider two frequencies at 3.5 and 28 gigahertz, and therefore we targeted the C band and the lower millimeter wave band. And we did a lot of studies, and here, I mean, you can see that if you deploy a given number of RIS, if you deploy a given number of RIS per base station, you can really move your coverage from something, this is the 3.5 gigahertz, from something that is 77% to 95%. Even a few RIS allows you to get a quite good, quite much better improvement in the coverage. At millimeter wave, things are even more important because the coverage that you have a millimeter wave, it's very, very relatively bad. It's less than 50%, and you can reach 95 with only a few RIS per base station. So here you can find really what we believe, at least, to be the first system level analysis of an actual deployment in a city where we use an actual 5G network. And of gains that you can have in terms of coverage and in terms of rate, for example, results, you can find basically this information here, that the ID of the paper, and you can find it where we analyze a lot of communication models. Now they can be included into optimization, the electromagnetic consistent model. So
it's about the recent advance in RIS. Okay, let's continue to question and answer. Is any question for participants? I see question. Okay, please.
There is one question in the chat, and there is somebody who raised the hand.
Okay.
So maybe I start from the one who raised the hand, if you want to speak, and then I read the question. Go ahead.
Okay, thank you, Prof. Marco Direnso. Nice to meet you. Your presentation is so interesting. Actually, I'm one of the people that's interested in doing PhD in RIS topics, especially in its beamforming design. First, I have two questions. First one is how to estimate channel in this kind of passive surfaces. Is it possible, or do we use another scheme? Is that the statistical or instantaneous CSI that you mentioned on your slide? And the second one, I have read some papers regarding RIS, especially the one you wrote with Professor Lejesanzo, that it is the possible candidate for 6G communication systems, right? Especially to overcome the coverage and blockade system in millimeter wave communication, because it virtual line of sight. It is kind of shorten the distance between the transmitter and receiver, right? So it reduces cost and power consumption. So what is your comment regarding this? That's all my questions. Thank you.
Yeah. So thank you very much for the question. So that's very interesting, and indeed, I mean, these are key points that needs to be solved. So let me start you with the channel estimation. So you are completely right. The main point here is that channel estimation is a critical issue. So the main point is that usually, basically, we should estimate this H here, and we cannot do it because we don't have the active elements here. And also, we should transmit pilots from the RIS to the receiver such that we can estimate G, or vice versa. We should transmit pilots from the RX and then estimate here. So this we cannot do that. So people have been doing, at least to the best of my knowledge, there have been three main phases so far in trying to tackle this problem. In the first time period, people assumed perfect channel state. I mean, they wanted to have a perfect channel state information. So the idea was to estimate H and G perfectly. What they did is to retrieve H and G individually from the product channel. And this turned out to be quite complicated. Then people said, okay, I don't really need to have H and G individually. I can just estimate the product. And under some conditions, this works. And the system can be, and this is more practical, much more practical. But the point is that it consumes a lot of time to do that. And then now the third phase is that people say, okay, forget completely that we try to estimate H and G instantaneously, and let's work on second order statistics. And this seems to be something that is relatively interesting. Also because people who build this RIS, they don't build the RIS thinking at the fast fading, as we do in wireless communication. Usually they design them based on long-term statistics like the path loss, etc. Therefore, I mean, now people are looking into that, the statistical CSI, even just the location of the users. I can show you one paper that we did that is pretty nice. I didn't have time to prepare to explain. But for example, what we did is, imagine that you have a base station and many RIS, and then your users can be in a given area. Here, for example, in gray, you can optimize your response of the RIS, whatever the locations of the users is. So this is a statistical optimization of the RIS in a given area, like 1 square meter, 2 square meters. And this is shown to be relatively, this is not optimal, of course, but it gives you good performance. Now, for the other question, so this is very critical challenge now, we are trying to understand. But the other question, yeah, is definitely correct. So what you say, one of the applications of the RIS, especially in the millimeter wave and beyond the frequency bands, is to try to overcome this, the absence of line of sight, or the fact that the line of sight can be bad or cannot be available. So you want to reroute your signal through this RIS and get a very strong signal. That's one of the applications that many people consider maybe to be one of the most important one. Other applications, so that's I'm working a lot on that. Is definitely this is a use case. Okay? And usually what we notice is that the users that take more advantage of this solution is the users that are very close to the surface, or when the surface is deployed relatively close to the base station. So this also tells us if there are many surfaces, which surfaces we should pick, we should use. Other applications are, for example, if you have a scenario where the channel is rank deficient. So, for example, you have, but then you want to use many antennas, multiple antennas, the transmitter and the receiver. Then you can use these panels to create a rich multipath. That's another thing that a lot of people are considering. And then, of course, there are many other things. So, physical layer security, reduction of interference. There are many things that can be done. But of course, the one of increasing the coverage at millimeter wave and beyond, it's one of the main, it's one of the most important applications to me. Yeah, so I hope that I answered more or less the question. I could go ahead for another half an hour. Let me see if there is, so thanks for the question. So let me see.
Thank you very much, Prof. Marco Direnzo.
Thanks.
That's really clear answers. Thank you.
Thanks a lot. So now there is okay, there are two questions now in the chat. So the first one was, it seems to me that research mostly less on circuit level, coming from what? Yeah, so that's a very good, let's put it this way. What you say, I would say that research on RIS now is more or less everywhere. But the point is, there is a lot of research at the circuit level, which means implementing the RIS. And people working in metamaterials have been working on that for years, but not 3 years ago, really many years ago. So they have a lot of things to be done. We started, wireless people or signal processing people much earlier, so 3 years ago, more or less. So we are very much behind. So of course you find a lot of papers on the implementation of surfaces, and much fewer than in signal processing. But in 3 years, we published many more papers in SP than they published in the other. So the key point is not that circuits versus signal processing. The point is that these two communities don't talk to each other, or it's very difficult to let them to talk. And therefore, there are implementation of surfaces that maybe are not useful for us, and our signal models are not compatible with the actual implementation of meta surfaces. So I think that the true research is neither at the circuit level alone, not at the SP alone, but is in between the two. So if you are able to work on both things, and that's where the true research lies, in my opinion, at the moment. That's at least what I'm trying to do. For your information, I'm wireless person, signal processing guy. Now I'm visiting colleagues in Finland in the metamaterial department. Next year I will go in sabbatical to the US with a colleague who is an expert in metamaterials and physics. He does not do anything in wireless communication. So that's, I think, the only way to bridge a little bit this gap. So it's really in between, at least in my opinion. And the second question is how to synchronize the RIS with the transmitter is very important. Yes, that's a very good point. So the answer to this question is that we don't know. So that's the point. So we are trying to understand this within this ISG, within the European Telecommunication Standard Institute. What is the best way? How to create the control plane, how to create the control channels that allows us to control the RIS in a good way to make it work is not clear. I'm not aware of many papers on that at the moment, but the companies are really interested into that. What I can tell you is that there are some companies which are trying to develop solutions where you can make the surface so-called plug and play. So, for example, the surface might be able to sense the directions of the signals, estimate the direction of the signals, and then to adapt to the environment automatically through a codebook. So that's another technique that may allow you to reduce the control channel. Then the synchronization, that's another things that at the moment we don't, I'm not aware of papers at least on that. So maybe, in 1 year or something within these sets, we will be able to understand this a little bit more. Yeah, that's a critical point, and nobody knows how it's going to go. Okay, so I don't see any other questions, but if you have, just feel free.
Okay. Any other question? Professor Marco, maybe I have a question. How about the frequency of interest? I mentioned the operating frequency of interest for this current research. It is only in millimeter wave or in future 6G. Thank you.
Yeah. That's a very good point. So we don't. At the moment, it's not clear. There are a few companies that are. So let me tell you first what there is around. So far, I've seen papers, especially in the computer science community, that they are interested in using this RIS for Wi-Fi applications. So there are prototypes at the MIT and Princeton, University of California. They are all working at the Wi-Fi frequencies, and they have shown significant gains for indoor communications. Now we are more interested, the wireless communication community, more in the cellular case. The frequencies that we are considering are more or less, at the beginning, many people said that these are more useful in the millimeter wave frequency band or even higher, sub-terahertz and terahertz, because of this possibility of getting strong line of sight signals. But there are companies that are very much interested in applying that also in sub-6 at 3.5 gigahertz, which is called the C band. And also at those frequencies, you can get quite significant gains. So at the moment, I can tell you that there are many people working on millimeter wave. There is a European project working on millimeter wave, another European project working at sub-terahertz. And most of the use cases that I've seen from Docomo are in the millimeter wave case, more or less. But at the moment, this frequency of operation is open. So in principle, you can use at any frequencies. The point is that how complex to implement the surface is also at those frequencies. So it's much easier to implement it at sub-6. The problem at high frequencies is that you have these elements that are extremely small with respect to lambda. And then it's very difficult to have electronic circuits that are so small that allows you to control each element individually. So to make the surface really reconfigurable, it's can be quite challenging. Maybe rather than controlling every element, you can control a block of elements. But what people tell me, at least, is that there is a sort of technological barrier at the moment for the reconfigurability, to make it complete and full reconfigurable. But maybe, I mean, some companies will solve this problem, because I would have never imagined to see transparent surfaces, meta surfaces. So maybe this will be solved as well if there is a need. So at the moment, I would say every frequency it's okay, but the gains and the implementation complexity are quite different. Yeah.
Thank you, Prof. Okay, it's likely that there is no more question. Okay, thank you very much, Professor Marco Di Renzo, for your interesting presentation and fruitful discussion for this conference. Let me express our gratitude for your presence here and in our international conference. And once again, thank you. And we hope we can, let me express our token of appreciation to Professor Marco Di Renzo from delivery of keynote talk in this 2021 International Conference on Radar, Antenna, Microwave, Electronic, and Telecommunication. It's hosted by BRIN Indonesia, and hopefully we can still contact you in the future for maybe another occasion, another opportunity. Thank you, Professor Marco Di Renzo, once again, and have a nice day.
Thank you very much.
Okay, let me give applause to Professor Marco Di Renzo, and we will finish this session, this plenary session, and I give back the time to MC. Thank you.
Thank you to Dr. Agus Subekti for having moderated the last keynote speech of the day. Also, thank you very much to Professor Marco Di Renzo for having brought to us such excellent talks, even though it was the last session, but it seems to me that there are still many participants are well engaged in the Q&A sessions. Now, with the completion of the third keynote speech from Professor Marco Di Renzo, it marks the end of the day one of the 2021 International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunications. Thank you for all of your participation during the first day of Icramet 2021. We hope that all of you have gained new knowledge and insights from the talks and discussions we are having today. We also would like to remind you tomorrow is the second and the last day of Icramet 2021. There will be 3 keynote speeches, 6 paper sessions, as well as the closing ceremony. Please join us again tomorrow at 8:10 at UTC or GMT +7. See you all tomorrow.
Record.